Good morning, everyone. Are you ready for the second day of Ubuntu Summit? There we go, there we go. It looks like you're awake and alive. My name is Andrea Montanu, and I'll be leading out the event today. If you have questions, if you want to throw out with some tomatoes, don't shy away. If you're a developer, a hacker, or just someone who likes to dig into the ones and zeros, today is for you. We have a stake of talks and workshops for those who like to build. We'll be building with Python, Rust, and much more. But before we begin, I have to be the boring one and just give you a few important notices. Let's see. First and most important, we have the group photo at 10 o'clock, so don't run or don't try to avoid it. It's very important to be here at 10 o'clock for the group photo. What else? Well, we have the Summit merchandise. We all want that pretty t-shirt, the beanie. Do we still have the beanie this year? That's a question. We do have, I see Aaron there. It's going to be handed all day in the room Princess Amalia. It's right at the entrance. So anytime you have a break or during lunch, just go for it. We also have the Hackerspace evening. It is something new that we're doing this year. It's going to start at 6 o'clock, and it's going to be dedicated for those who registered online. And you might say, but I didn't register, so why do you tell me about this? Well, I have good news. There are a couple of more slots available. So if you would like to register for the Hackerspace evening, scan the QR code and choose one of the topics and join us there right after the talks finish. There we go, I see people scanning, so I can just wait a bit longer. 3, 2, 1. It's long gone. Now it's time to start. I'm done with all the notices, and we will be talking about Rust, reaching for a better future together with Eric Holk. Are you ready to welcome him? There we go. Eric?
Thank you. It's really good to be here this morning, and I am excited to get to talk to you some about the Rust project and some of the work that we're doing there. I gotta say, it's a little bit surreal being here. So I work at Microsoft, and if you told me back when I started my career that someday I would be presenting as a Microsoft employee at a Linux conference about work that we're doing at open source, I would have been a little bit surprised to believe that. But I'm really glad to be here, and I'm glad to get to talk on behalf of the Rust Leadership Council and the Rust Project and share a bit about what we are doing in the Rust Project. So to tell you a little bit about what, I've been involved with Rust for a while. So currently I'm working at Microsoft as a software engineer in DevDiv, and mainly this is an internal focus thing now. We are at Microsoft starting to use Rust a lot internally. And so that means that we need a team to support and make sure that we can meet our requirements and be successful in shipping Rust code. But part of that is also making sure that we have a healthy upstream Rust project, making sure that it's well-staffed and well-supported. And so I get the privilege of spending a lot of time working in the open source community. So I do a lot of different things within the project, but the thing that's maybe most relevant for us today is that I'm the representative for the Rust compiler team on the Rust Leadership Council. And I'll explain a little bit more of what's involved with that later on in the talk. But my history with Rust really goes back pretty far. When I was in graduate school, I had the chance to be an intern. I think one of the first interns on the Rust project at Mozilla. So this was kind of 2011, 2012, when Rust was really new and exciting, and just lots of changes happening very quickly. And so that means that I also get to share a lot of kind of my personal history, or when I talk about the history of Rust, I get to share my own experiences in that too. So I'm excited to be able to do that. I was thinking about what I wanted to present today, so I took a look at the Ubuntu Summit website, and this paragraph that I have up there is, I think, kind of maybe the theme for the talk, why we're here. And there were two phrases out of this that really stood out to me. The first one was that we were looking for people who are not satisfied with the status quo, who really would like to see better and more reliable software. And then the second is this idea of doing excellent engineering in the open. And both of these, I think, really resonate as a Rust contributor, as a Rustation, because Rust is really about challenging the status quo, about saying, hey, with better tools, with better programming languages, that can form a foundation for better and more reliable software. And Rust has been open from the very beginning. We care a lot about doing excellent, high-quality engineering and doing that in the open. And so I thought this was a great idea to talk about these two things. So these are going to be kind of my themes for the talk, and I hope they come through as we talk about it. But looking at the ways that Rust challenges the status quo and tries to build better software, better systems and things like that. And then looking at the way that Rust strives for open, excellent engineering and doing that in the open, having a collaborative, welcoming process for the community. So for the rest of the talk, I have kind of 3 sections. We'll have a brief intro to Rust, because I imagine there are, some people use it, some people don't. So, kind of set a baseline for that. I want to talk some of the history of Rust and how it got started, how it got to where it is today, and some of the things that we've learned in that process. And then, once we've done the history and we've caught up to today, I want to talk about how the Rust project runs today and the ways we continue to evolve the language and develop it and do this excellent engineering in the open and build, make the language even better than it is today. So one thing I want to just kind of acknowledge, how many of you have had the opportunity to run into the Rust evangelism strike force on the internet before? Yeah, so in the Rust community, we're really known for being sometimes perhaps overzealous and promoting the good news of Rust. I'm not here to convert you to Rust. I think Rust is an amazing programming language, but there's other good languages out there too. And that's okay. You should pick the language that works best for you, that you're most comfortable with. If that's Rust, great. But what I really want to focus on instead is inspiring better software and share some of the things that have worked for Rust. I'd really like this to be a talk about, even if you never write any Rust code, there's something you can take away from it that you can learn. The goal is to get better software, better technology that we all work with. And if Rust is a tool that does that, then great. And then I feel like I'm here a bit as a guest of the Ubuntu community. And so I'd like to have this chance to learn from you as well. One of the things that Rust does is we try to learn from other communities and take things that have worked well and adopt those and share the things that work well for us. And so I hope this is a chance for me to learn as well and have new ideas to bring back to the Rust community. So with that, let's get into our introduction to Rust. If I were to give Rust maybe a 1-sentence summary, I would say it's a safe systems programming language that's suitable for the kinds of programs that you would have previously written in C++. So this means it's a language that gives you a lot of low-level access and low-level control to the machine, the way your data is laid out and things like that. But it has a lot of other sort of features built on top of that. It has a very powerful type system and a really flexible trait system. Probably the thing it's best known for is its borrow checker, and that's a way of it's a sort of safety system on top of pointers and references that allow you to do things that can be really aggressive and performant, but you can do it with the confidence that the compiler is making sure that you're avoiding the kinds of errors that can be tricky to fall into with complicated memory access patterns. Like I said, the language is ahead of time compiled, and so this means it compiles down to native machine code and can run very efficiently. And part of that is also that the language has really minimal runtime requirements. I should probably just say it has no runtime. You can compile Rust to run on bare metal. You can write the operating system in Rust, and so you don't actually depend on having services provided by the operating system there. Anyway, one slide's not really enough to show all the features of Rust, but those are a couple of highlights that I wanted to share. One of the things that I think is particularly special to Rust is the way that it's built around this idea of ownership. And so I wanted to have just a short program here to explain, or to maybe demonstrate a flavor of what that looks like. So in line 1, I've created a new structure called thing struct. I've defined two functions, consume thing and borrow thing. The really maybe relevant difference there is that ampersand in front of thing and borrow thing. So that's saying we're taking this by reference, or in Rust we sometimes call them a borrowed reference, whereas the first function, consume thing, takes the value by ownership. And if you know Rust, you're probably already kind of looking at this and thinking, hey, this might not work. And this particular program doesn't. But this highlights what Rust is doing with ownership, transfers, and movement, and borrowing. So in this main function here, when I create a thing and then I pass it to consume thing, that passes by value, or sometimes I like to say it passes by move. You can think of it as moving it from the caller to the callee. You're giving up ownership of it in the caller and transferring that to the callee, and then it's up to the callee to take control of that and to take care of cleaning it up when it's ready or handing it off to someone else. That means that from the compiler's perspective, after we call that function, this t variable has been deinitialized. It's now uninitialized memory. And so when we try to borrow it, we pass a reference to it that the compiler is complaining there that this thing has been moved and you're trying to borrow it, and that's not OK. And this is an example of the kinds of things that Rust does to help you avoid errors with uninitialized memory or things that have been deinitialized or things like that. So that was our introduction to Rust, and now I'd like to share a bit of the history of Rust, how we got to where we are. I want to start off with this, what I've called the legend of Graydon Hoare and the elevator. This is somewhat rooted in truth, but I think at this point I'm calling it a legend because I'm kind of going to embellish the details a bit to make the point I want to make a little bit better, or to tell the story in a little more entertaining way. So the legend goes that one time, a long time ago, Graydon was, he was living in his apartment on like the 14th floor of this building, and he was, coming home from a busy day and was tired and just looking forward to relaxing in his apartment. When he went to go push call the elevator and get up to his apartment, it was, I guess, a fancy elevator with like kind of a screen on it and all that, and he was greeted with the blue screen of death on there. So the elevator control software had crashed. The elevator was inoperable, and so Graydon had to take the stairs all the way up 14 flights of stairs to get to his apartment. As you can imagine, it gives you a lot of time to think when you're climbing up all those stairs. And Graydon was reflecting on the state of software and how so much of it is unreliable, and we really ought to be able to do better. To put a point on it, we struggle to even make elevators work, and that's not really, we'd like to do better than that. And then Graydon got the idea that maybe if we had a better programming language, we could do that. And so starting off on Rust was really this idea of let's find things that have worked well in existing programs. If you've written C++ for a long time, you have a good idea of the kinds of patterns that lead to robust and correct code. So why don't we try and codify those in the language and let the language help you follow those? So Graydon got up to his apartment and started working on a new programming language, and ultimately what that led to is what we have today as Rust. Here's kind of a timeline of the Rust project. So Graydon started working on Rust back in 2006. And for a couple of years, it was really just a hobby project that he was doing on his own time. But then around 2010, he shared it at Mozilla, where he was working. And Mozilla thought, hey, this is pretty cool. Let's put some more effort into it. Let's build a team. Let's keep experimenting with it. Around this time also, so we had an excellent talk yesterday about Servo. This is also when the Servo project gets started. And that's something that I think is particularly cool, this relationship between Servo and Rust, because from Rust's perspective, it gave this application to sort of co-develop the language with. And I think for a lot of times when you have a really successful programming language, there's usually some killer app that was developed alongside it. The one that kind of immediately comes to mind is C and Unix, where the C programming language was essentially developed so that they could write Unix. So C allowed people to write Unix, and then Unix sort of relies on C. C is the language really of Unix. So that synergy there, that collaboration, and Rust had a lot of that with Servo as well. being able to have an application that's, not the compiler. Rust is a self-hosted compiler, so the compiler is written in Rust, but also having another project to really guide and inform the language decisions is really nice. In 2012, we had our first public preview release of Rust. It was Rust 0.1, and that was a point to say, hey, we're ready to let people start experimenting with it. The language was still very experimental. There was a lot of churn in it, but people started to try it out, and we got a lot of great feedback from it. A few years later, in 2015, we released Rust 1.0, and the theme of that was really about stability. It was about not having to do these breaking changes all the time, having to just constantly update your code to keep up with the changes in the compiler. And then since then, we've continued to develop the language through this mechanism of additions, which are ways to sort of make changes that allow the language to evolve further. And I'll get into more of that in the talk to come. I'm excited that our Rust 2024 edition is coming out soon. We're hard at work on that now. It's actually going to come out in January of 2025, but we'll finish the edition in 2024. But because of the sort of train model, it'll be 2025 before it's unstable. So when Graydon first started sharing this project at Mozilla, he gave a talk that, there's a link there if you want to go find the full talk. It's pretty interesting as a bit of language history. But he had this slide in there that talked about how this has been kind of a young and immature project, but that the design's mostly done. We've got 90% of the language features working and around 70% of the runtime. So, essentially just a little bit more work and the language will be done. We know with hindsight now that it was actually 5 more years before the language was finished, or before we got 1.0. And that was because as we worked on it, there was a lot of churn that went through it and a lot of evolution and iteration on the language. The easiest way to see this is to look at all of the release notes that we had. So in 0.1, we had this. We ended the release notes saying future code will break unexpectedly. I don't know that it really was unexpected that there would be breakage, but the particular breakage was maybe hard to predict. And then if we look at the release notes coming up after that, each one has this long list of, most of those bullet points there are syntax changes that were made to the language. And most of those would mean if you are writing Rust code, you'd have to go and update your syntax to work with the new compiler. So, this works for some people with that want to keep up with the changes in the language, but at some point you kind of just want to write code and have it be done and have it keep working. So that was the goal when we moved towards stabilization. To give you an idea of how the language has changed, though, up here I have an example of code from Rust as it was in about 2010, and then what an equivalent program would look like in modern Rust. I put 2024, but I think the same program would work in 2015 in Rust 1.0. When I use a slide, I update the date on it to show that it still works now. So, structurally it looks a lot the same. The curly braces are in essentially the same place. But you can see some changes. Like, early Rust had this idea of objects. It was kind of a prototype object model. And then that was replaced with struct and impl. So we made this clean separation between describing the data structures that you have and then attaching behavior to those data structures, either in the form of inherent methods like this, or by implementing traits, which are a way to sort of package, essentially like interfaces, a way to package up a set of behavior and then say this is how this particular type implements that behavior. And then you can kind of see small syntax changes, like, instead of auto for declaring variables, we use let, and logging had special syntax before, and then it was replaced with a macro, this println macro, and so on. But that gives you a flavor of how the language has evolved over the years. But then, as I mentioned, we released Rust 1.0, and this was really about stability for the language, getting to a point where you could rely on your Rust code still working, so you don't have to just every time there's a new Rust release rewrite your code. It's great for if you have hobby projects where you work on it and then come back to it 3 months later. Your program would still work after this, where that wasn't really true beforehand. This was great. It was a time the core ideas of the language were done, and we were ready to commit to them and support them in the long haul. And then really the flavor and the approach that the project took towards evolving the language changed a lot at that time. I'd like to take a minute to talk about some design principles behind Rust. And some of these were there from the very beginning. They, kind of built in from the beginning to the Rust ethos. But some of these were either refined or sort of grew organically through the course of this early development in Rust. And so I'd like to share some of the principles that stand out to me. Here's my list, and this is my list. If other people were giving this talk, they might have slightly different things on here, but I think all of these things are things that we generally agree are valuable in the way that we design and develop Rust. So I'll go into each of these a little bit more detail now. And the first is this idea of being safe and sound, and that's that your program behaves as specified, the behavior is well-defined, you don't have things like out-of-bound memory accesses. We have array bounds checking built into it. We rely on things like the borrow checker to prevent things like use after freeze and double freeze and all kinds of things like that. Some of the features that really build into that are obviously memory safety. But then again, if you're working in low-level hardware, a lot of times you need to escape that. And so we have this unsafe mechanism that lets you basically encapsulate these things where you have to do things that the Rust compiler can't understand and verify as safe. But if you encapsulate that inside a safe API, then you can use it outside of that boundary with confidence and without having to worry about memory safety errors there. Type soundness is also an important part of this. And so, broadly I would say type soundness is that if your variable is declared as an integer, it holds an integer, that things hold the type that they say that they do. And then that avoids a lot of errors with like type confusion and where you think you have one thing, but it was this other thing because it was illegally casted or something like that. And then part of memory management is automatic cleanup. So Rust has this drop trait, which works a lot like destructors in C++. And so when the compiler can see that a variable is no longer needed or a value is no longer used, it can clean it up and free the memory with it. And so that helps prevent things like memory leaks. And because this is automatically done by the compiler, it also prevents some of the issues that come from when you try to do it yourself and maybe miss a detail or a corner case on it. The next principle is this idea that if your code compiles, it works. Obviously, this is kind of an ideal we aspire to, but a talented program can write bugs in any language, and that's true of Rust too. You can write buggy Rust code. But Rust really strives to provide tools that will make it easy to make sure your program is correct by construction and works the way that you expect. So there are a lot of language features that encourage correct programs. One example of that is the match construct, where you can sort of consider different cases, different categories of things that could happen, and then the compiler can check and make sure that you've covered all of those things. And so you don't have this case where, I forgot to handle, I have an error case here and I forgot to handle it. The compiler makes sure you do that. And then that's also supported with this rich data type language. I mentioned struct and enum. There's a lot more to it. Enum is particularly nice. It lets you have a type that can be this thing or this thing or this thing with different data attached to that. And that is nice because sometimes you have the state of your object evolves through time, and sometimes it's hard to tell, like, is this field valid now or not? And with enums, it's nice because the invalid fields just don't exist when you're in that state. So that, coupled with match, helps you be really robust in reasoning about the state of your program and what kinds of things can happen. The next principle is this idea that if it works, it keeps working. And that's really another way of saying our stability guarantee. You don't want to have to rewrite your code every time you upgrade the Rust compiler. And so we work really hard to make sure that we don't break backwards compatibility as much as we can avoid it. There always are cases where we have to do it in a very limited way, but as a principle, we're very cautious about making those kinds of changes. But of course, we still want to evolve the language. Rust, even modern Rust, looks a lot different than 2015 Rust, and that's because we have this ability to evolve it. So how do we do this? Well, there's a few things that we do that we use to make this happen. The first thing is this release train model. And I think Rust really borrowed this from the browsers. That makes sense coming out of Mozilla, where Firefox was shipping on a 6 weeks time schedule, and Rust follows that same model now. So as an example, we just recently, a couple weeks ago, released Rust 1.82. That means we now have Rust 1.83 in beta, and then we have 1.84 is the current nightly release. Most of the development happens in the nightly branch, and then every 6 weeks we promote that. We sort of move the trains along and promote to the next stage on there. We do have the option of doing backports into the beta branch before we release it to stable. But my sense is these are pretty uncommon. Well, maybe a handful of patches that we have to do each release, like 3 to 5, something like that. Almost all of the development happens on nightly. We also have this tool called Crater, which is really cool. It goes and it can pull every Rust crate that's listed in crates.io, many of the ones that are on GitHub too, libraries or projects that are written in Rust. And it goes and fetches all of those and compiles those with a new compiler and reports anything that has changed, anything that breaks that didn't break before. And this gives us this really powerful ability to assess the ecosystem impact when we're making changes that might be breaking. Sometimes it'll say, hey, someone could be depending on this, but we think it's unlikely, so let's see, does anyone actually depend on that behavior? And we can say, oh, okay, we found 3 crates out of 50,000 of them that would be impacted by this. And so this is really helpful to be able to tell what's happening with Rust, what people are using, and can help us detect unexpected breakages also. So there's sometimes we make a change where we're like, oh yeah, that'll be fine, and then we realize, no, it actually has this surprising impact over here, and then we can use that to reconsider whether we want to make the change or not. We also have feature flags. So you can't implement a lot of the language features that we're trying to add in 6 weeks. So we need some way to allow them to evolve over multiple releases. And we do that through feature flags. So we can design a feature behind a flag. This is only available on nightly, and that's because if we put it on stable, people would just start putting the feature flags in their code, and then we'd end up having to support it. We want to explicitly not make a backwards compatibility promise on something that needs an unstable feature flag like this. But we still want people who want to experiment with it and take on that risk to be able to play with it and try it out. So one example, a feature we're working on now is generator blocks. So you can enable that by adding this gen blocks annotation here. And that lets you write functions like this. So we can write gen fn, count to 3, we yield 1, yield 2, yield 3. A nice simple way to count to 3. This is familiar if you're in languages like Python or JavaScript, or many languages have generators, and I'm looking forward to seeing them in Rust as well. And then we also have our stabilization process. So we've done this development behind a feature flag, and then at some point we want to turn it on by default and make it an official part of the language. This is by necessity a conservative process, because if we make bad decisions, we're kind of stuck with them because we have this backwards compatibility promise. So the solution there is to only make good decisions, right? That's not too hard, but it means we have to be really cautious, and that's, in a lot of cases, the main reason why development in Rust can sometimes feel really slow. So we want to make sure that we're confident in the design, we've had the chance to experiment with it, it's had time to bake, and that we're willing to support it indefinitely. So once we get to that point where we're ready to do that, we can leverage that feature flag mechanism to turn the feature on by default, and then it becomes part of stable Rust. We also have this mechanism for additions, which we talked about before, which is really a way of unblocking or unlocking language evolution. So there are some times where we want to make a change, but because of the way something worked before, we need to change the existing behavior as well. And additions give us a very controlled way to be able to do that. So additions are opt-in. When you write your Rust project, you define what addition you're using, and then you can interoperate. So you can have a Rust 2018 crate link with a Rust 2021 crate, and vice versa. But then within your crate, there's Rust is using the rules for the addition that you've chosen. And so that makes it so you can have this controlled choice to move from an older edition to a newer edition, that will mean making changes to fix your code, but in many cases we can automate those as well. We have a tool called Cargo Fix that can basically just go through and mechanically change your code so that you have the old behavior if that's what you wanted. As you can see from some of the changes that we've had, this is, I think largely additions are about unlocking future work, and so it's not so much, for example, in Rust 2018, we reserved async and await as keywords. We did not actually add Rust, or add async and await, like the features in Rust 2018. That came a couple of releases later. But by reserving these keywords, that gave us the freedom and the flexibility to do that without breaking existing code, at least once you've migrated to 2018. And with Rust 2024, I think a lot of the changes that are going in there are kind of a similar flavor. There are changes we'd like to be able to make, but we need to make these opt-in changes in behavior first. So our fourth principle that I want to talk about is this idea of building great tools. There's a list I have up there of some of the tools that we develop as part of the Rust project. So the compiler itself, we have Rust Format, Rust Analyzer, which is this really, I think, excellent IDE tool for looking up definitions of your code and applying fixes and just kind of understanding how your code works. And there's Cargo, which is the Rust build system, and does a few other things as well. And then also this idea of having built-in testing. I like a lot. I think when I write Rust code, I test it better than code that I write in other languages, and a lot of that is because you just have, in the default setup for the language, you can just add your test in there. You run Cargo tests, they all run. It's really seamless to do that. I also want to highlight Rust Format, and because I think it's kind of interesting that this got really mature really early on in the process of Rust, and I've always thought of an auto formatter as being something that would come later in the language evolution. But this ended up being extremely valuable when we were making syntax changes for the Rust compiler, or like in the Rust language, because the Rust compiler is written in Rust. So when we change the syntax, we also have to go rewrite the Rust compiler to use the new syntax. And Rust Format ended up being really valuable for that, because we could have Rust Format read the old syntax and then reformat it using the new syntax, which made it much more seamless to update our code and adopt language changes in a compiler that is itself written in this changing language. Part of this excellent tooling idea is to have helpful error messages. We saw an example of that earlier, of the kinds of error messages that Rust gives. And I like this quote a lot here from Esteban Couver, who has really driven a lot of the work around diagnostics and error reporting in Rust. So he says the primary function of a compiler is to take malformed code and emit diagnostics to help the programmer turn it into well-formed code. A compiler is an error reporting tool with a code generation side gig. And I really like that, because we a lot of times think the compiler is about generating your code and making your code run. But this kind of turns that around, and we can think of it as the compiler is really helping you write code that's correct. And then, that's why a lot of your work is this dialogue with the compiler. I tried something, and it says, no, I don't like that. Here's the change you should make. So you make the change, and you fix it. And then eventually, it's, almost anticlimactic that it's like, now it can generate code, and your code works the way you expected it. And that's because of our helpful error messages. And then our fifth principle, and our last one, is this idea of learning from others. So the Rust reference has this page in it that I like a lot, which says that Rust isn't a particularly original language. And what we mean by that is that almost every single feature that's in Rust is we've taken from some other language. We got inspired by some other language. I think really, if anything is novel about Rust, it's this particular combination and making these features work well together. But yeah, just all of the features that Rust has, we borrowed from other languages. It's great to be able to take good ideas that have worked elsewhere and find a way to make them work within Rust as well. Okay. So that's our history of Rust and introduction to Rust. I want to spend some more time now talking about how we build Rust. The first thing I want to talk about is the way that Rust is structured, the Rust organizations are structured. And I want to talk about the Rust Foundation and the Rust project. These are two distinct entities, which I think is maybe a little bit uncommon. So we have the Rust Foundation and the Rust project that work well together, but they actually have different responsibilities. And so it can be easy to conflate these, but they are different. The foundation's really there in support of the project. So let's get into a little bit more about what that looks like. First of all, the Rust Foundation. Its primary goal is to support and promote the Rust project. So to support us on the project side, to develop the Rust language and really make a great programming language. So that means a few things. That means this idea of being a steward for Rust. It also provides like legal services for the Rust project. So there are some times where we need like a legal entity to sign a document or to own intellectual property or things like that. And that falls within the foundation's role. They look over the things like trademarks for the Rust programming language and provide this legal entity there. And then a lot of the work they do is around fundraising, and that primarily comes through corporate memberships. And then taking these funds, they can then deploy that in service of the Rust project and to enable the Rust project to do excellent work. The foundation has several components within it. The first one I want to talk about is the board of directors. And so these are the people that oversee the foundation and set the strategy for how the foundation works, what things they should be pursuing. One of the things that I think is somewhat uncommon about the way this is set up for Rust is that the half of the voting power within the board of directors is reserved for the project. So the project appoints what are called project directors, and then the member companies in the foundation appoint member directors, and then that makes up together the board of directors, and then those two halves have equal voting power. And so this gives the project a lot of say in the strategy and the direction that's set by the foundation too, which helps us really focus on making Rust great. I mentioned the Rust Foundation it's a foundation made up of different member companies, and so they play a part of this. They're a stakeholder in the foundation. And then we also have the foundation staff who manage kind of the day-to-day operations of the foundation. And actually, some of the staff work on the Rust project itself in engineering roles or other support roles like that. Okay. So now let's shift gears and look at the Rust project instead. This is the entity that really does most of the development on the Rust programming language and then most of the engineering that goes into Rust-C and all of its related tools and things like that. It's largely a volunteer organization, so people come and help out either as hobbyists or, some are sponsored or hired directly to work on it. And many of us are, in a situation like myself where we work for another corporation, and part of our work for that is to work externally or upstream on the Rust project. But it's largely volunteers, mostly people that are not actually hired by the foundation or the project itself to work on it. The project itself has several components in it. So I'll go kind of right to left on there. We have working groups, which are these entities that are either geared towards working on a particular aspect. So one example is we have the async working group that works on designing and developing, building out Rust async feature set. Some of them are more almost kind of like special interest groups. So we have like embedded or game dev, which are people that are interested in using Rust in those domains. And they may maintain a set of crates to help make that work better or provide resources if you're wanting to work in these domains as well. The bulk of the project, though, is this set of project teams. These are top-level teams, and they're the ones that have maintainership responsibilities over different aspects of Rust. So, for example, the language or the compiler and things like that. And then we have the Leadership Council, which is made up of representatives from each of the top-level project teams. So here's our set of, at the moment we have 7 project teams, these top-level teams. This changes over time, but I think we have a pretty good set right now. So there's compiler, the library teams, moderation, dev tools, infrastructure runs things like our CI, and some of the different tools we use to communicate with each other. There's the language team that owns what the Rust language itself is, and then Launchingpad is kind of this umbrella organization for all of the working groups so that they also can get representation within the project. These teams can be further subdivided in the sub-teams. So for example, the language team uses this to great effect. We have things like the Lang Advisor, we have a team focused on documentation, the style guide, having a spec, operational semantics. It's not listed on there, but there's also a types team that is kind of a dual sub-team of Lang and compiler. And so that lets the Lang team delegate authority and responsibility for these subparts of the language as well. and that can help increase our bandwidth and abilities to get things done. And then, as I mentioned, the top-level teams can also send, they select members to go serve as part of the leadership council. So that makes the council a little bit different. Most of the teams are sort of, they select their own membership. They invite someone to go join the rest, or that team and participate in maintainer responsibilities. The leadership council is more of like a representative body, so it's made up of the teams and the people that they send, and then that lets the, if the teams are not happy, for example, with the way that the leadership council is running, they can change the makeup of that and try to put people on the council that reflect what they want and set a good direction for the Rust project. So the Leadership Council was established by this RFC that basically it was set up to say that the Rust project members confer the authority to ensure successful operation of the project. So there's a few things that the Leadership Council does. Some of that is sort of dealing with cross-cutting concerns across the language, or helping teams work together better and facilitate communications, making sure we have the right mechanisms for that. The Leadership Council ends up being kind of the point of contact between the project and the foundation. So we on the council talk a lot with the foundation and work closely with them. And I think in a lot of ways the role of the council is to basically speak as the voice of the Rust project. So sometimes we need to know, like, what does the project want to do or think or say about that. And so for those kinds of statements, that's usually where the Leadership Council comes in and has the responsibility for making those statements and really doing it in a way that actually accurately represents what the project is doing or what the project wants. Okay. So I'm going to spend some more time now talking about how kind of day-to-day life works within the project and the way things get done. There's three things I want to talk about here. One is this request for comment process. And that's kind of how we make decisions at a high level for the project. And then a lot of teams will establish their own process for things that are more local to their domain. So I'll highlight a few of those. And then I want to talk about project goals, which are a new experiment we're trying that I think has gone pretty well so far. So I'll talk about that as this way we have of setting the direction for the Rust project. So first, let's talk about RFCs. RFCs are for big or impactful changes to the Rust programming language. These are things that tend to span several teams and really set a big direction for the project. Most of the time, those are technical. And so some examples of technical RFCs there are things like adding async and await, adding where clauses, changing the way that crates.io works, or things like that. A lot of especially big major changes to the language are done through an RFC, and then that's discussed and approved and so on. But then a lot of the RFCs are also used to shape the way that the Rust project runs. Maybe kind of the most meta thing about that is that the RFC process itself was established by an RFC. I think it's funny that was actually RFC number 2. So somehow we got RFC number 1 without having an RFC process. But yeah. So the RFC process was defined by an RFC, but then we've had other ones as well, like creating new teams, establishing the Leadership Council, like we talked about, changing the way the Rust release project works, or release process works, deciding we should have a specification, or declaring that we intend to make a Rust 2024 edition. And these are the kinds of process RFCs that we might have. Okay. So I want to talk a bit about consensus, because this is something that I think Rust has pushed really far, this idea of making decisions by consensus. So the question really comes down to, how do we know when one of these RFCs or other decisions should be accepted? And sometimes the majority vote is not the best outcome, especially if it's a really close vote. That means that there are really significant concerns or perspectives that are brought up that maybe we haven't done the best job of accounting for. And so because of that, Rust tends to go with this consensus model instead of really trying to get everybody on board with the decision and really putting in the hard work to make sure we can get a decision that everyone wants to go along with. We do this through this process called a final comment period, or FCP. and that's to obtain consensus about a decision. So we have a bot that you propose an FCP on an issue. It puts checkboxes for all of the people on the relevant team for it. And then once we have, no one has raised a blocking objection for it, and we have all but at most 2 missing yes votes for it, then we can say, hey, this has been accepted. We've met our consensus requirements, and we can move forward with it. But then after that, we have this we have this period, this final comment period. That's the FCP part of FCP for 10 days, which is this chance to say, hey, we've made this decision. We publish the fact that we've done that, and we give people a chance to raise other concerns that maybe hadn't been considered. And so we have this last chance to reconsider it, and we can cancel the FCP if someone raises something that we felt like needed more time to address, for example. But then if we don't have that, then we move on and we accept the decision, we move forward with it, and get to work on it. Okay. I mentioned that some teams have kind of smaller versions of these same processes, and a lot of times that's because RFCs are kind of a heavyweight way of doing things, and for many decisions, you don't need that whole process to do it. So 2 examples of those are MCPs, or major change proposals, and then ACPs, or API change proposals. MCPs are used by the compiler team. They mostly deal with things around the internal architecture of the compiler. So these are, maybe something like compiler flags or something like that. These tend not to have this broad user-facing impact as far as like the syntax or the semantics of the language, but they address how the compiler is developed internally. And so because of that, we can do this decision as a local to the compiler team decision. And then ACPs are this process that's run by the library API team. And that's a way of making changes to the standard library. So for example, proposing a new function or method or trait that's added to it as a new API. And then getting consensus around that and stabilization on that. Okay. So the last thing I want to talk about in this section is project goals. So these are relatively new, but they're really looking at this: how do we set long-term direction for the project, and in a way that is actionable, we can make progress on it, in a way that we can also signal that there's buy-in on it. So project goals are an agreement between an owner and then the Rust teams who support the work. So the owner of a goal is responsible for either doing the work themselves or sort of driving it forward. A lot of times they work with a team of people who are working on this area, but they're the ones that are responsible, like point of contact for how are things going on that and making sure progress is being made. But then there's also Rust teams who support the work. And then that support can look several different ways. One is just kind of a commitment to say, like, yes, this is work that we think is worthwhile, and so if you do this work, we will work with you to get it accepted, because we don't want this case to come up where somebody goes off and does a ton of work, and then the team is like, no way, we don't want this. Why did you waste all that time? So this gives us a way up ahead of time to say, this is a problem we think is worth looking at and worth solving. Other ways that support can come up is things like promising to do code review and allocating resources for code review, or allocating design meetings and getting the teams to make sure to give time or spend time looking at and addressing questions and concerns that are proposed by the project goal owner. So project goals begin with a submission period. So we put out this blog post that says, hey, if you've got a project goal you'd like to propose, here's how to do it. Put it forward to consideration. And then out of that, we come up with a set of goals that we want to accept. This last time, so we started this last May, and we picked 26 goals for the project, and we identified 3 of them as flagship goals. So those were around making the Rust 2024 edition, bringing async Rust and synchronous Rust closer together. So some people described async Rust as hard mode for Rust, which Rust can be a difficult language, so making it even harder is a little bit tough. So we want to make them feel less like different languages. And then Rust for Linux is something that's been getting a ton of steam. I think it's probably really relevant to a lot of people here, trying to get Rust in the Linux kernel. And so we want to make sure we can provide support for that effort and provide the things that the kernel needs so that they can run using a stable build of Rust, rather than right now where they depend on quite a few nightly features to make Rust work. So we accepted the goals, people go and start working on them, and then periodically we post updates. So like this one, our September goals update on the Rust project blog, talks about progress that's been made on those and how things are going. And then these goals are set up as a like half a year, 6-month process. They're iterative. So at the end of that 6-month period, we do a new slate of project goals. So there's a few things that can happen. We can say, hey, this goal is complete. That's great. We can unwrap it, or I don't know, wrap it up and say, hey, we don't need to work on it anymore. People can go work on other things. We can say, hey, we still believe in this, and so we want to keep working on it, so we'll continue the goal. Or we can say, hey, we didn't get it done, but we also want to prioritize other work now instead. And then that creates space to either completing goals or deprioritizing them, create space to bring in new goals and address new priorities. And so I just want to mention that this process of selecting new goals is happening soon. Relatively soon, we should see another blog post with a call for goals. And so if you're interested, this is something you can watch or get involved with and help to shape the direction of Rust for the next 6 months. Okay. So we've talked about a lot this morning. I tried to cover as much about Rust and the Rust project as I could in a fairly short amount of time. It's a lot to take in, but I just want to kind of review. We talked about kind of what Rust is and the what makes the language unique and special. The history of Rust, how we got to where we are today, and what Rust, what we learned from that, and what we've sort of developed as cultural things and the way the project runs. And then we talked about how the Rust project works today, and the way the project is structured, and makes decisions and things like that. And so I hope all this is helpful, and if you use Rust, that's great. Even if you don't, I hope you can learn from this and take some lessons that maybe can make your own projects more successful. And again, like I said, I want to learn from others as well, and so we can make Rust better too. So thanks a lot. I really appreciate the time to talk to you this morning.
Thank you, Eric. I think it's time for questions. We have 2 mics, one on the left, one on the right. Whoever has questions, don't shy away, and please come and ask questions. There we are. We have the first question.
Thank you very much. You described what sounds like a really thoughtful approach to project and foundation governance.
Thank you.
And of course, every project learns from the lessons of the ones that preceded it, but do you think you've been able to avoid some of the missteps that have they've been quite painful in some communities and significant projects, and do you think that the path ahead is going to be, do you think you'll discover new ones, new problems, or do you think that you've solved some problems that have plagued such projects?
I think the answer is probably yes to all of the above on that. Rust itself we've had some really painful things happen in the community too. So, I think like many large projects, problems come up in that. We've learned a lot from that in the past. That's why we have the leadership council now instead of what we used to have, which was the core team, which had similar responsibilities but was structured quite a bit differently. The Leadership Council is really an experiment. So far, I'm happy to see the way it's going. We haven't seen the real public kind of challenges that the Rust project had a lot beforehand with it yet. I hope it continues that way, but time will tell. It is something we're very aware of and trying very hard to make a project where people can feel heard and that we can address these concerns so that they don't boil up to the extent that they can or that they have in the Rust project in the past or other communities and so on.
Do we have other questions? If not, I do have one as well, but I see someone coming. 2 people, actually.
I'm interested in Crater. So it feels like that would give you a big fire hose of feedback data.
Yeah.
How do you decide if the change, if 0 things break, obviously everything is okay, but if 1 thing breaks, if 10 things break, if 100 things, how do you decide was it an acceptable change? How do you take action upon all that massive data that you must be getting all the time?
Yeah, I'll be honest, I think this is a place where we could probably codify that a little bit better. I think the way it works now is it's largely an input to the teams that are making a decision. We'd like to make this change, here's what creator said. We've actually seen even different teams within the project have different thresholds for like maybe allowable breakage. I know the Lang team, for example, is like very, very cautious, and if they see like 10 crates that have a problem with it, they're like, oh, I don't know, maybe how much is this change really worth? And other teams can be maybe a little bit more, willing to accept changes like that. One of the things we will do is if it is a small number of crates that are broken, we'll actually go out and send them a PR to say, hey, we would like to make this change. This fixes the problem that it will cause for you. Yeah, I think the best way to think of it is it's an input, and then we sort of weigh against, so that adds a cost to making a change. We like to keep that as low as possible, but if it's a really high value change, we might be willing to accept a little bit more.
Okay, thank you.
Yeah.
We have time for one last question before the group photo. There we are.
Okay.
Thank you. Just going off of your slides, but it struck me that in terms of inside the Rust project, there's tens of teams. In my understanding, there's kind of a fixed cost overhead of contention between teams and organization, generally speaking. Mm-hmm. Just curious what informs like that number of teams or sub-teams that are within the Rust project? Is it a function of the number of developers in the project, or something else, or a combination of things?
Yeah, that's a good question. I think a lot of the teams maybe were developed kind of organically, especially the sub-teams. It's like, hey, we've recognized this area that kind of is separable in some sense, that we can we don't need necessarily high bandwidth communication there, and so we can just delegate a lot of that to the sub-team. A lot of the top level teams in particular, we try to have them have fairly broad authority. They do need to talk to each other a lot. I think particularly around like compiler and lang and libs, because all of those, the lang team defines like the core semantics of the language. The library team defines the standard library, which has a whole lot to do with how the language feels to work with. And so there's a lot of back and forth that needs to happen there. And then the compiler has to implement the support for this too. And so, those teams end up having to have a lot of communication between them. Sometimes the way that happens is you have people that are members of both teams. And so they're attending both meetings, and they can provide this high bandwidth link between the two of them. And then now that we have this representative leadership council, that adds another consideration in there, which is the larger the council gets, the harder it is to make decisions and get consensus there. And so that adds this like pressure to have a smaller number of top-level teams. So like when the council started, we had 9 top-level teams, and we've merged some of those teams together, which now means we have 7. And I think that lets the council run a lot more effectively or efficiently. Thanks.
Thank you, Eric. If you have other questions for Eric, you can find him at the Microsoft booth. And I think now it's time to change a bit the moment, and we're going towards the group photo. Don't leave us.
Okay.
Don't leave us. But let's welcome Ahmed as well, who's going to help us out with the group photo. And then everyone else will have to come on this side of the room. Ahmed, are you there? Let's see. There he is.
Morning. Okay, as you can imagine, there's many of us here, so I'm going to need to just, I'm going to explain how this goes. So I just want to see where our photographers are. Photographers, if you're out here, please raise your hands. Okay, I see over there. So you're going to perch all the way on top there. So the highest point that you can reach. Thank you. So on your right, which is my left, you can see a lot of the Ubuntu mascots. And when prompted, they will make their way carefully onto the stage. Please proceed. Thank you. And some of you are thinking, these look really familiar, and you're right.
Ahmed knows how we're going to.
Okay, and our photographer is almost there. As you can see, they're making the trip all the way up. Okay, I see 1, 2, 3, 4, 5.
You don't have to run. Don't run. Okay. We want you in the photo, that's for sure.
Okay, I'm gonna move this way if you guys want to take pictures, and then we're gonna make our way, all of us, onto the stage.
I think you want to make it.
Who's here for their third summit?
Is this your first one?
Would you mind joining us on the stage? And this is kind of how it goes, right? We're just going to try and make it as batch-like as possible so we don't crowd. If this is your third summit, please join us on the stage. And everyone will get on stage, but this is the... Okay, like somewhere just around here. We're gonna be doing more organizations, but...
Just find your seat
Okay.
as well on the stage.
So they're taking it from this side. From this side, if this is like your second summit as well, please join. If this is your first summit, you're gonna be slightly in the front as well.
Someone to help me with this animal. It does work, but I think it's not going to be visible.
Okay, more people streaming in. Thank you. Thank you for your patience and your cooperation. This is never easy, crowding all the way onto the stage. And fear not, this stage is very quite durable. So,
Okay.
okay. Okay.
There we are. Someone will be here.
Okay, everyone, would you mind joining us on stage? As much as you can, try and take the right and the left.
The lobster.
Lunar. Okay, we're almost all here. So for those who haven't been part of one of these group photos, as much as, saying 3, 2, 1 and cheese is good enough, that's cheesy. And so we like to pose a little differently. We like to envision how one of the many mascots of Ubuntu would pose. So I just need a thumbs up from our photographer all the way up there that everything's good. Are we still setting up? Okay.
What do you need? The clicker or?
Let's just wait. You can join the photo.
How do I pronounce your last name?
German.
And Rachel?
Rochelle.
Rochelle.
Are we good? Thank you. Okay, so first thing we're going to do is we're going to try to pose like a jammy jellyfish. So how would that look like? To you. The answer is not behind you, it's with the photographer. So we're gonna count down 3, 2, 1. Okay. You guys ready? Okay. Okay. We're going to go 3, 2, 1, and then we're gonna pose. Okay. 3, 2, 1. And the most recent desktop release was Oracular, or Yoli. I think some of you remember that name. Yes? Okay. While noises are very much appreciated, they do not make it into digital photographs. But we're going to also try and pose like an Oriole. Can we do that?
The red thing.
Thank you. Let's go. 3, 2, 1.
So the gray one is the Minotaur, but the one right in the middle, like the shell, where Mark is.
Okay, many of us enjoy that way too much. And I think one last one. This is one we just do every year. The Minotaur. Okay, no. All right, let's do it. Once we're ready, I think our 3, 2, 1, whenever you're ready.
Should I go and help Ahmed? What's that?
That's the Minotaur. They're trying to do the horns.
Thank you. I mean, we're still here, so. I mean, are we good? Okay, we're good. Thank you. This one. Wait. Hey. One more. One more while we have everyone here, please.
Don't leave. No, make them take the photo.
The human. Thank you.
I have the speakers, I think. So. Are you okay if we start a moment earlier, since I have you here?
We have to set up a test, so we'd like to do that.
Then, do you need any help for the test? There we go.
How's it going?
It's good. It's a busy day, I would say. How are you?
Pretty good.
It's good to hear.
I will be making it to the conference in Austin.
Oh, really?
Yeah. Well, it's right there. So
That's true. That's
I
true.
was sad to see you guys weren't coming.
No, not this year, unfortunately. I'm done traveling this year. I don't want to travel.
This is my last time.
Okay.
I'll catch up to you.
Let's catch up later. Yeah. Should I invite them to take a seat?
Do we know if
We have around 5 minutes before our next talk. The clicker is here if you need it.
I think so. Yeah.
You want to set up a charger for this one?
Andrea, is this your laptop? Oh, okay.
No, I have no laptop. I barely have anything.
Can you take the speaker? Just, we don't want to. Yeah.
Is this yours? Do you need it?
They have audience.
Thank you.
Are we ready for the next talk? That's a quiet room. No, are we ready for the next talk? Yes? Let's see, what are we going to talk about? What do you think? We have a quite interesting demo as well. It's exciting, and I think we are getting ready to welcome our next speakers this time. We're going to talk about a new project based on Linux together with Carl Richel and Victoria Birkenfield. Let's welcome them. That's a shy room. Let's try again. Did we all get tired from the group photo? No, I don't think so. Well, let's welcome them, because I think they have more interesting things to say than I just did. There we go.
Good morning, everyone. Thank you for coming to our talk about Cosmic. The last talk before this was about Rust. If you enjoyed that, then I have a treat for you. Cosmic is a desktop environment written entirely in Rust. So we'll start off just talking about why we decided to make a new desktop environment. The story starts around 2019. We had our customers calling us. We were developing and shipping Pop! OS for quite some time, well, a couple of years at that point. And customers were contacting our technical support team, our sales team, and they were asking us how to install i3, if they could install i3 on Pop, if they could install Sway on their System76 laptop. And these were coming in pretty regularly. And then in 2019, I went out to Mountain View at Google, and it was for a open firmware conference. And at that conference, noticed that most of the people at the conference were using i3 or Sway. Clearly, in Pop! OS at that time, we were not delivering what our customers wanted and what our customers needed. Auto tiling or dynamic tiling was popular among our customers, and what we were shipping didn't include it. So at that point, we decided to build a GNOME shell called Pop Shell, or an extension called Pop Shell. Pop Shell added auto tiling to GNOME. And once we did that, we started shipping it, the calls stopped. Where people weren't asking for i3 or Sway anymore. We had solved a problem for our customers out of the box. Later on, as GNOME evolved and we learned more about what it was like to deliver a product using GNOME extensions, there are some inherent challenges to that. Any extension can override another extension. The quality and reliability of what we were delivering in Pop! OS could only go so far by developing extensions and delivering the features we wanted to deliver in that way. So we started thinking about building a DE, building our own desktop environment. It started with a pros and cons list. Our first one was, well, we can continue just doing extensions as we're doing them now. Well, we already knew some of the issues there, but it's also something we're already doing, so we can just continue that process. One of my major drawbacks to that was every 6 months there's a new GNOME shell release. A lot of our engineering time and the work we're doing is just keeping par, just keeping our extensions at the level that they're working each GNOME release. That means that all the engineering time and the development time isn't spent adding value for our users. It's just keeping us at par. And frankly, it's actually not very fun either. It's a lot more fun building new things. Another option was to fork GNOME shell and perhaps set up in a way where maybe extensions wouldn't be able to override each other. But the problem there is it's going to look like GNOME shell. It's going to feel like GNOME shell. Users are going to have the same expectations that we wouldn't be delivering. We're not going to be able to make our users happy that way. A third option was a Mutter plugin. considered doing that and thought it would be technically feasible. We did some work on it and found that that wasn't the case. Mutter, of course, being very, very tightly knit with the GNOME project, most of their considerations are what GNOME needs. The final option was, well, we could build a desktop from scratch. And we had, in 2017, I believe, we had standardized on Rust, so all new projects we were developing in Rust at that point. And so we understood the value and how building something in Rust might build a far more robust, reliable desktop environment. We also knew that it was the hardest and most expensive option of the four that we could choose, but we knew we could build the best product, and so that's the route we took. Our first team, so then our discussion started in August 2021. We went through pros and cons. And when we made that decision, we decided, what kind of team are we going to need to build this? And we began hiring the team that built Cosmic. In May of 2022, we brought the entire team together of the engineers, the designers, the QA team, and documentation team, and we talked about what our objectives were for building Cosmic. We wanted to build a desktop that anyone could use to build their own user experiences. So that meant we wanted to build a desktop that was composable. A desktop that you could adapt if you're a distribution to your own branding, to your own user experience. You're closest to your users, and so we wanted to give distributions the power to adapt the desktop to what they were hearing from their users. Because although our users all wanted auto-tiling, that doesn't mean every user base wants auto-tiling. And I think one of the things that makes open source special is that we don't have to be one monolith system that we're shipping to everyone. We have hundreds of distros, and those distros all are close to their users and can build experiences for them. So the next step was for us to choose what technologies we were going to build Cosmic on. We built some of the features in GTK. We were used to doing that with Rust bindings already, so we built panels and some applets, and we tried different things. We looked at Flutter briefly. Ultimately, we decided we wanted a pure Rust desktop from the bottom up, meaning the toolkit as well. And so we looked at Slint. We knew people over at the Slint team who were building a Rust toolkit, and they're a great team. But we wanted also something that was licensed in a way that was much closer to our own beliefs in open source. And so we landed on Iced. At that time, Iced didn't have text rendering. There was no text rendering engine for Rust. It didn't have very basic features that were necessary to build a desktop. So not only did we choose the hardest and most expensive option, we just decided to add on top of that building a brand new toolkit to build our desktop as well. 3 years later, like I said, it was the right decision, even though it meant an incredible amount of work and effort. But now we have something beautiful built from the ground up, all in Rust. After we started those initial discussions or made this decision, and as we were hiring the team, the design team started with design experiments. We wanted to go through our user experience in apps to see if some of the concepts we thought would work across a number of different types of applications. These were just mock-ups. You can see in some ways they have kind of an older feel to them because they have this, this elevation and this three-dimensional feel to it. I really appreciate that. I liked it. It didn't make it in the end, as you'll see, but this is how we started. The concept was that an application window is like a pane of glass. That's how I thought of it. Perhaps a pane of smoked glass. And in that glass, different features were etched into it. So the header bar, as you can see, the buttons and the menus and these things are kind of etched into the surface. And then from each side, you have one side, a navigation bar comes up, and it's the standard location for objects that will navigate through an application. On the other side, we call it a context drawer. The context drawer opens information contextual to what you're doing at the time. That might be settings, that might be more information about a file that you're looking at. What's nice about this approach in application development or this pattern is that it enables us to bring more relevant information out without going deeper and deeper and deeper into different windows. So in settings, perhaps you might go into one layer of settings, and then you go into another layer of settings to set your keyboard shortcuts. Then you go into another layer of settings. With context menus, we can bring that out faster, and you're not getting nested as deep as you would in a lot of patterns that exist today. Cosmic is a design-first, professionally designed desktop environment. We built an entire design system. The design system describes what variable colors are used in what locations in the application, what kind of design patterns we use, how a text input works, how a button works, how a search bar works. All this was designed beforehand, before we started building it, while the engineering team was working on experimentation and determining the technologies we were going to use to build Cosmic. All right, you've probably seen this. What?
So we can just daisy chain up to 127 USB devices here. That's an everyday task. Let's plug it in. It's going to say, hey, I see you've plugged in a new device. And it's going to load in the appropriate drivers. You'll notice that this scanner build, whoa.
That's so fantastic. So this is alpha software. It might break, but that's all right. Okay. So here we have the Cosmic desktop. I've come to prefer using a single bottom panel at the bottom of my desktop, but that's my personal way of doing it. Cosmic allows you to adapt the desktop to whatever your preferred workflow or style is. So what I'm going to start with is just some Cosmic applications. So we also have an application suite that's slowly replacing the GNOME applications that we were shipping by default. We have a file browser. We have a Cosmic App Store. We have a text editor. And text editor actually has some nice features for software development as well, including GitHub integration and other features of that nature. We have a terminal, and of course our settings application as well. Now, one of the UX patterns that we prefer when we were working through challenges our customers had was the Alt-Tab experience. In any operating system, you're probably familiar with kind of the pain of using Alt-Tab to try to get back to the application that you want. You might cycle through, and then you get past the application you want, and then you have to cycle all the way through again, or add Shift to go back to it. Well, with Cosmic, we center the experience around a launcher. You saw me launch applications with it, but when I open the launcher, I can now see all the applications that I have open. And if I want to go back up to the store, if I start typing store, it'll move me to that location and to enter that application. It doesn't matter what workspace it is on, what display it's on. If what I'm looking for, if I just type in the first few letters and enter, it'll jump me to that to that application that I was looking for. In Cosmic, we also have auto tiling, the feature that kind of started all of this. Auto tiling is done by workspace. So you can have one tiled workspace and you can have a floating workspace if that's the way you prefer to work. You can have workspaces per display. So this combination of different workspaces and tiling and floating and being able to separate them from monitors also means that maybe you have one display that has your communication stuff on it and you leave that floating, and then you have another one that might have browser and code editor and terminal and so forth all tiled. One of the things that we've done is try to make tiling more approachable to more people. There's a learning curve to jump into i3 and Sway. But with Pop! OS, we have easy to understand shortcuts. It's very easy to navigate and move windows. When you add a new window or a new application, you'll automatically tile in easy. And besides, and there's some people that are keyboard driven. I am, and a lot of our developers are, but there are a lot of customers that aren't. So we built tiling to work just as well if you want to use a mouse. You can grab a window and move it into any place within the tiled desktop. You can also stack windows, and now you have tabs of different windows, and then you grab them and pull them out. Besides tiling, theming and layout were really important to us. The intent of Cosmic is to give the world a platform to build user experiences. So to do so meant we needed to have a very robust theming system that allowed you to personalize it to both your own personal taste, or if you're a distribution, your distribution's branding, or your company's branding if you're building devices. So we'll make a few adjustments here. We'll move the panel to the top of the screen, and maybe we'll make it a bit smaller, perhaps. Each one of these that aren't opening, each applet is a separate application. Here you can see the applets that are on my panel. I'm going to remove the app tray, remove minimize windows. Maybe I'll move the date and time to the center segment. And let's now add a dock to our desktop. And let's put the dock on the left, and let's extend the dock. And now it's starting to take on a bit of a Unity feel. Let's go a little bit further, and in appearance, let's import a new design here. Let's see, pictures. Here we go. Oh, wrong one. I have Ubuntu. We're going to start with Ubuntu Classic. It's been 20 years, right? And let's change the wallpaper. Now we have a bit more of an Ubuntu feel. I loved Warty Warthog, Breezy Badger, and those kind of earthy tones that Ubuntu started with. So I think it's pretty attractive. We also have light mode. It always feels like it's really bright when it's turned on. Let's see. Dock. Okay. There we go. All right, and let's set the theme for the light version. There we go. The text editor didn't change color here though. All right. And here we have Ubuntu Classic. Now let's give it a more modern feel. We'll go back into settings and import a style that fits with the new Ubuntu branding. And fix our wallpaper as well. And there we have a light theme for the latest Ubuntu branding. So as you can see, between taking panels and being able to lay them out in any way that you want, and applets, if we open up System Monitor, for instance, and we look at, and we'll search for Cosmic, you see how many different processes are running. Each of the applets in the top of the panel and the applets on the side are all independent applications. You can write another applet to reproduce the Ubuntu experience. We all remember when you would click on the top left and an application menu would open and you could search, and there was the concept of lenses where you could add different sources that you could search through. That would be a relatively simple applet to write and produce that user experience here on Cosmic. What we've done is we've done the hard, lower-level engineering work to build a platform to make it easy to create custom user experiences. All right. And now I'll hand things over to Victoria. Victoria is going to talk more in depth about that the hard engineering work and how we brought Cosmic together.
Yeah, hi. My name is Victoria. I started with the Cosmic engineering team basically right when Cosmic was kicking off. So I was no System 76 employee before, but I was no stranger to the Wayland world. And of course, writing a new desktop these days, that's one of the technologies that you first look into. Because I was at the time for about 6 years or so working on a little side project of mine that is called Smithy. And that is a Wayland compositor framework written in Rust. Very similar to something like wroots. It actually started around the same time, but we had a lot less contributors, so wroots got a bigger head start with Sway and everything. But also, I was in brief contact with them, writing maybe Rust bindings for wroots instead or whatever. And we just figured that the design philosophies were a little bit different in various ways. So when you're writing a desktop on your own, which I was before I joined System 76, you immediately notice that this is absolutely no small task and there's absolutely no chance that you'll ever be done with it, right? The only way to get there eventually is by just building on the ecosystems that are already there. So my goals were, let's build something modular, something compatible, something composable, right? This is what every engineer really dreams of building. And then when I started working on Cosmic and suddenly had like a whole engineering team that shared the same vision and wanted to build the same thing, I figured, what if I could take these goals and still make them a reality? Wouldn't that also be a net benefit to what our desktop is going to look like in the end? And I really think that's the case because with the modularity, we can make it so much easier to work on all these different parts of the project in parallel. With compatibility, it meant we could use a bunch of components that already existed and were there, or use them as placeholders. For the longest time, we didn't have a proper screen locker, but if you just support the right protocols, you can just use Swaylock in the meantime. That's fine, right? Stuff like that. And in the end, we were also hoping to have something that's very composable, right? Everybody can just take the parts of Cosmic that they want, change them up to something else, use different things, and should still end up with, hopefully, a working desktop. But obviously, these were also the engineering goals. So let's start a little bit of a lower level and then slowly work our way up. This is an engineering talk overall, but I promise this is as technical as it's going to get. And talk a little bit about Smithy. Because we had a wonderful Rust talk just before this one, so it would be a shame to not chill on Rust a little bit more. And one of the things that I'm personally in Smithy really proud of is all the abstractions that we built. And I'm just going to take one single example. This is all the traits that make up our rendering pipeline. So if you want to write a renderer for Smithy, you can just implement a subset of all of these, and a bunch of functionality will be available depending on what traits you choose to implement and to provide. And this is not super unusual to other compositor toolkits, right? They have rendering abstractions. Most of them just use OpenGLES, but there are some that start using Vulkan. Software rendering is, of course, a thing, and a bunch of other things. So it makes sense to abstract all of this away. I'm not saying Smithy is any special in that regard, but what I really think that Rust gives us at this point is how expressive these traits and their requirements and the constraints you're exposing can be through Rust's incredible type system. So the result is that I know that there's a bunch of out-of-tree renderers maintained by different people, sometimes proprietary, sometimes not for Smithy. And it's not like they are in our chat every day and complaining about that we broke some API and that their renderer is suddenly not working anymore, right? And the reasons for their custom renders are many different ones. One example I can immediately think of is somebody doing work for a company with embedded systems, and they just have a little board that has a 2D accelerator. So no proper 3D engine. They can't just use OpenGL. They had to write their own renderer to get the performance that they wanted on that platform working with Smithy. And of course, Smithy also provides a bunch of implementation of these, most notably the GL one. But I think what is also really neat, and I wanted to quickly highlight here, is our multi-GPU renderer, which will just take different contexts from different GPUs, possibly even with different APIs, and in the background just manages all the shadow copies of frame buffers and of client buffers coming from different GPUs for you in the most performant way that it can find to do these things via DMA buff transfers in the best case, or just via memory copies in the worst case. And it just uses the same interfaces that you were already using when you were using the GL renderer before. So this is just plug and play, and suddenly you have a working compositor on complicated multi-GPU systems like the ones we ship at System 76. And these kind of abstractions were really what drove Cosmic very quickly much further. We have then a bunch of new abstractions and layers sitting on top, like damage tracking and then render graphs. And once you're at that level, we even have a little abstraction that will take your render graph and try to put those things on overlay planes first before you continue composing everything down onto your primary plane, which is now a very specific KMS terminology. I'm very aware of that. But you know, just being able to use these different layers and deciding, do I want this? Do I want to use the lower layer? Do I want to pick a different part of Smithy? Do I need to implement this out of tree? Really makes it possible for many different compositors that are based on Smithy to just pick and choose and use the same base technologies in some places and implement their complete own thing in different things for different things, and build completely different experiences. So it really lived up to everything I was hoping Smithy was going to be when I started this about 9 years ago. And then on the next level, we have our compositor, right? We are building a desktop, we need to write a compositor, and that is Cosmic Comp. And for that, we had the same kind of sets of goals. So what does that look like for a compositor? Well, that obviously means we need to support some common standards so people can interface with a compositor, because everything a compositor really does is I/O, and most importantly, IPC a lot of the time, right? We get a bunch of clients that want to output something, we need to combine that and send it to the display engine, and then we get input and we need to multiplex that again to a bunch of clients. So all we're doing is just shipping data through as quickly as possible with as low latency as possible. And that meant, if we wanted to be compatible with what's already there, to look at the other projects and the ecosystems that were already there, mainly the W roots. People already built like a nice namespace with the various protocols that we just straight up started adopting and using, and not had to think too much about the exact interactions between all the different binaries that we are shipping in the end, because the protocols were already laid out and we just had to maybe slightly tweak or extend them, but not invent everything from new. Most importantly, of course, something like the layer shell protocol, but also in smaller stuff like the output configuration protocol. And if you followed Cosmic a little bit, you might have seen that there's a Cosmic protocols repo though, right? What gives? Why does that even exist if we are so onto reusing stuff that's already there? Well, the most important point to make first is that we're constantly trying to upstream whatever is in there. Wayland protocols sadly takes a bit of time. I'm sitting there in the community as well and doing upstream work as much as my time working on Cosmic allows. And those efforts have already paid off. We are mostly using existing proposals and just slap the Cosmic prefix while we are testing them in our desktop at first, then try to upstream it, and then just easily transition, hopefully, over to the new protocol. And one of these that recently finally got merged is X screen copy. So now we can just do a search and replace and remove Cosmic screen copy from all over our code base, use the new protocol, and everything's handy dandy, and we've established a new common standard, right? At least that's the theory. Sometimes we do have constraints where no other desktop shares our vision, so we have little tiny extension protocols. And the goal is to make at least all of those that still remain in the end after Cosmic protocols shrunk as much as possible by upstreaming, optional, so that any component that might use these for additional functionality on Cosmic does not hard depend on any of these being available. So in the end, the goal really is to have no private APIs, no completely unstable protocols that nobody can really depend on, no hidden dbus interfaces that you need to look into the source code to understand how they actually work, but just have everything readily available for people that want to implement new components for Cosmic or just want to swap some components out. And I thought the best thing to show this actually off is to do a little bit more demos, because everybody loves demos, right? So we just quickly going to take a terminal here and do some stupid hacks so we can present with multiple computers. Don't worry about it. And here we have my Cosmic desktop. Nothing super special. Just have desktop icons enabled for people like that. I have a very minimal panel at the bottom. But that's actually not what I wanted to show you, so let's log right out of that session. Takes a little while. And then we select something completely different. And we are right back into Cosmic. Or should I say Cosway or whatever, because this is, of course, not Cosmic. This is Sway running all the Cosmic components with almost no modifications. I think I wrote about 80 lines or something to get this working on the train right here. And now we have Cosmic running on Sway. I can also start settings. Display configuration works because, of course, we're using the same protocol. I can go into the desktop settings, stuff that you've already seen. Say that I want my dock to be opaque or not opaque and translucent instead, or something like that. I can go into appearance setting. Now I could, of course, change the accent color, but that wouldn't really translate over to Sway. But of course it does, because I wrote a little daemon. So your accent colors get synced into the Sway configuration, and everything just seamlessly adopts, and now you can use Sway with Cosmic. But that's probably not super interesting, right? After all, we just heard from Carl how Cosmic's tiling was very much inspired by the tiling that A3 and Sway is doing. So let's try something else, right? Let's go back to the login screen. Let's quickly select something else. And, you know, we get a bunch of requests for, what about if we had scrolling tiling on Cosmic? And you know, for our UX developers, I imagine this is not a nice question, because they spend so much time in building out a good tiling UX, and now suddenly you should have a whole different tiling paradigm. How do you explain this to users? How do you make it easy to switch between these things? But I say let the designers figure this out. Maybe we'll support scrolling tiling at some point in version 4. Maybe we won't. No idea yet. But if you want scrolling tiling in the meantime, just use Neary. Neary is a perfectly fine project, also built on Smithy. I like it a lot. And then you suddenly have scrolling tiling working just fine on Cosmic. Mostly fine, I should say, because if you have a scale larger than 1, then somehow the panel breaks. I'm not super sure what's going on there. That only happens with Cosmic panel on Neary. It doesn't happen on other compositors, and it doesn't happen with other panels on Neary. But that's probably something for somebody to figure out in a single afternoon, right? And this is also a great point to make about this as being a very unsupported configuration of alpha software, right? So just let's exit this a different way. And when preparing these little demos, I thought, okay, but this is a Ubuntu conference. I can't just show off Sway. I can't just show off another Smithy compositor. I need to run this on Mir. Sorry, I still have a sore throat from an infection some weeks ago. And now this is Cosmic running on Mir. Unfortunately, the background daemon doesn't quite work, because Miracle, at least in the version that ships on Fedora, for some reason doesn't even support the viewporter protocol. Sorry, somebody of you will maybe have to fix this. Also, pop-ups on layer shell clients seem to be very interesting. As soon as I interact with this, the panel just crashes. But you know, the desktop icons work, and I can open Cosmic files from here, and I can open a terminal, and the launcher also appears. So this is as usable as it probably gets. All right. Great. Where did I leave the clicker? Here. All right, so this is hopefully going to show you that for something completely unsupported, you can pretty easily, on a completely different compositor, get a very usable desktop. And I think that's one of the staples where we can really show that Smithy delivers on its promises of compatibility, of composability, of modularity, by just showing that we can take a very, very core component of Cosmic, right? Something that I take much pride in and wrote for the last couple of years, and just replace it with something else, and everything still works. So this is the point where I do a little shadow drop. If you want to play around with these, this is the GitHub link. Just put it up yesterday, and you can run Cosmic on any compositor that implements a sane set of default protocols. Probably also on K1 if anyone wants to give this a try. Sorry. All right, so let's take this another layer higher, because of course composability doesn't end on the technical way with a compositor, but we also have our panel. And Carl already said all of these things are different processes, so how does that work? Well, if you're a Wayland developer, every problem looks like it's solvable by another Wayland compositor. So obviously the panel is a nested Wayland compositor. All the clients you see there are just standard XCG shell clients. The panel just chooses to position them, its little icons in there, and when they open pop-ups, they just get forwarded to the host compositor. Like this means that you can write a new applet in basically any Wayland native toolkit. You don't have to use ICE, you don't have to use Rust, you don't have to use libcosmic. Just use whatever feels natural to you as a programming language. Sorry, I need to take a quick break. And this obviously also enables a bunch of other very fun use cases. People are already writing new applets, but system monitors, you're used to that. Every applet has these. This is easy to build for all of the different panels. But what about just taking your i3 status output and rendering it into a Cosmic panel? And now you got a very weird hybrid of what would be sway bar on Cosmic. But given these are normal Wayland clients, can it actually run Celeste? And yes, it can. One of our engineers, Ian, who I absolutely have to shout out here, took the first Wayland native game they found, which nicely was Celeste. And I don't know how they got this far into the game. But it obviously runs in the panel, and there's probably also some Doom port out there that will run if somebody wants to build this. And I think this is, again, a nice showcase of how Cosmic Panel really solidifies on our promises of compatibility and composability. So if you want to rebuild the Unity desktop with Cosmic, I hope this is the point where I convinced you that this is not super difficult. Or if you want to take and build Cosmic Mobile, hopefully that's not super difficult either. Or if you just happen to love the little workspace dots that GNOME gives you, and you don't like the workspace applet that Cosmic provides you, just re-implement it. Or if you want to run Cosmic on Sway and you are very bummed out by the fact that the workspace applet isn't working because there isn't a common protocol for this yet, we are working on it. Just write a different workspace applet that uses Sway IPC in the meantime and use that for the time being. It should just be a couple of hundred lines. How difficult really can it be, right? And that brings me to the last and final layer that I want to talk about, and that is Cosmic Config. And it's mind-boggling to me that we even have to talk about config on a desktop system as if it would be something special. But it's really just a very small little library and an optional daemon The library by default just does I notify and watches for changes of our config files, but if the daemon is there that provides a little dbus interface, it will ask that to do all the watching and the notifications for it, right? So if you're running into file handle problems and too many open files on your system, just install the daemon and everything will be better. But you don't need it. Every application can just read and watch the config files and automatically reload them on its own. And of course, everything is atomic. As you might have guessed, it's all file-based. It's in the Rust object notion file format, which I think is not only human-readable, but also nicely human-writable, which is nice for the end user. And because it's file-based, you can also easily make backups, of course. Check it in a Git repository if you really want to. The important thing for distributions, of course, that it's layered, right? We have the system configuration, then we have user configuration on top where users can make changes and you can seamlessly update the system configuration without breaking their customizations. And then the last thing that we actually didn't need right now, but it is versioned, we so far didn't have to break any of our config files, but if we ever need to do this, there is a path forward and a path where we can migrate from version 1 configs to version 2 configs. And with that, hopefully you've seen how Cosmic is a platform, first for developers that want to build their own experiences and just use whatever is there, and then develop new applets, shell components for whatever is missing for them. For distros, they can just adopt different configurations, pick and choose what applets and components you want to ship in the end, and also provide branding through the custom configuration. And also, of course, for the end users that really can take this desktop and customize the heck out of it to make it their own. And with that, back to Carl.
You made it. All right. It's been a 3-year journey. We are getting close. We believe that there will be a beta release in January or February. As many of you know, when you have a beta release, it attracts a lot more users. I'm sure we're going to learn a lot at that point. Depending on how much we learn and how many things we've missed during the alpha releases, I would expect first release in February of March of next year. There will inevitably be things that we wanted to get in the first release that we didn't. So we plan to have a second release next year as well, where we'll fill in some of those gaps. After that, we plan to go to an annual release cycle for Cosmic. Very likely a release sometime in like the June or July timeframe each year. Cosmic is built for a bigger purpose. It is going to be the flagship experience for Pop! OS. But Cosmic is intended, built, designed, architected, organized, and developed to enable the world to create user experiences. To use this technology, to listen to your users, to your customers, to their needs, and be able to use this technology to deliver products and experiences that your customers and your users need. It's built to solve a problem that I think has existed for quite some time. You know, we've been at this for 20 years. Ubuntu is 20 years old. We've built successful companies in open source. And even though we've done that, we've put all this work in for 20 years, we've still made a very small dent in the proprietary desktop world. I want to make a much larger dent. And I know that's not going to be possible following the path of Apple or following the path of Microsoft. The only way, or I think the best chance for this really hard problem, is to take a uniquely open source path, a path that embraces the GPL not just in license but in spirit. That means what we want to build are things that people can use to build with. If you think about the most successful open source projects, there are things like the Linux kernel, Apache, Ubuntu, various programming languages and platforms and React and so forth. They all have a similar characteristic. They're all used by people to build things. So we built a desktop environment meant for you to build things with it. That's why we made Cosmic. So thank you very much.
Chris, Victoria, thank you very much. It's the time when we can ask questions. And looking at the project that they just presented, there should be some questions. We have the mics on the left, on the right. Do we have any? Or should I break the ice? There is one. I see it.
So you said you are aiming for yearly release of the Cosmic. Do you plan on sticking with Ubuntu LTS as a base, or also targeting the yearly .04 releases?
For Pop! OS, what I want to disclose now is that we will provide LTS releases in Pop! OS. We have plans for a different type of distro that we're not prepared to talk about yet. But there will be like the Pop! OS 2404, 2604, and so forth. Cosmic is very separate from Pop! OS, though. It's packaged for Fedora and Nix and Arch. It is on its own cycle that's separate from Pop! OS, and that will be annual, and then Pop! OS itself will have its own releases as well.
Okay, thank you. Mm-hmm. And can the panel run Doom?
Yes. Yes, it can.
I see another question.
Hello. Carl, how does it feel for System 76 to be not just a hardware company, but now a software company also?
That's a great question, because we've been a software company in many ways just as much as a hardware company, because hardware doesn't work without software. So writing drivers, we write firmware. Most of our laptops run core boot. What's unique about System 76 is we have mechanical engineers, industrial designers, electrical engineers, firmware developers, operating system developers. We write code from the very lowest level all the way up to the desktop environment. So it's unique in that we have a perspective across the entire spectrum of how to build a computer in every way. So this is new in a lot of ways, but still experience that we've just added to over years.
Early on in the talk, you mentioned the difficulty of shipping user experiences based on GNOME APIs or GNOME abstractions as a motivation for Cosmic. And I know of kind of like the built-in mechanisms of the Wayland protocols and how people make decisions and how the protocols themselves provide this ability to provide components that can interop with each other. In some future scenario where like Cosmic customers want X and developers want Y, and it ends up becoming a question or a toss-up between stability or answering a customer's request. How do you see that playing out? How do you, I guess the question really becomes, how do you become more stable or more of a platform than GNOME is, given a customer focus that your company must abide by?
In Cosmic, you see in settings we have a panel and we have a dock. That's just because in our view, those are two, it gives the user a lot of different power and capability to create the layout and workflow that they want. In Cosmic, you can have as many panels as you want. If you're building a different type of device that might have layered panels for maybe an exercise bike that has a menu and then it has classes and it has different layers to it, you can build that with Cosmic, but you can, because the complexity and the capability is all in the background. But we don't have to expose all that through settings. Settings itself is also composable to a certain extent. We need to improve on that. But if you're a distribution that has a different mechanism for upgrading your distro, you might want to change out our software and updates page to a page that works for you. So I think Victoria can talk more about that too.
Yeah, I think on the technical side of these things, what we ship in Pop! OS will always be focused on our customers that receive Pop! OS with our machines, right? But with the modularity and with all the different components, we hope to keep maintenance costs low enough that if other parts of the community, be that other distributions, be that other parts that might want to run Cosmic or Neri or whatever, can just develop their components, stand alone, maintain them themselves, And so in that kind of way, we do really divide and conquer for all the components that we are developing internally, and we will at some point put on hold or replace components if we end up growing too many. And also divide and conquer by inviting other parts of the community to maintain the parts they are interested in that might not fit with what our view for our customers is. So I hope that answers that question at least a little bit.
A very specific question is, do you have a back and pack policy? Would you, if you want to make a change that would break a previous version, will you make that change?
That's a difficult question because it very much depends where in the layer it happens. For the protocols that we are support, I think we are very much set in stone of continuing to support them almost indefinitely, and just trying to work with upstream if they're missing functionality that we need to add that, or to write a little extension protocol rather than to replace the foundation that we built this on right now.
Yes.
Thank you both for your presentation. I thought it was extremely compelling. Our community, well, and I should also say that the sort of singularity of the vision is exactly the sort of thing that really blazes new trails, right? So our community is famous for being, both a technical construct and a social construct. And that's exhilarating in both senses and frustrating in both senses, right? I'm curious, as you look at the different communities that you work with as part of this exercise and others, where do you see, what are the areas where you think getting consensus or the social dynamics are most challenging? And I ask that not in the spirit of sort of throwing someone under the bus or so on, because, we've got to talk about these things, but where do you find in the sort of stack that you find yourself most challenged in terms of getting other people on board with a singular vision, and what might make for a better set of constructs to achieve that in your view? Right.
Well, the most obvious one for me is application, not really portability, but the application ecosystem within Linux all feeling like they fit in with each other's desktops. That is probably because there are very different views throughout the community about theming, about appearance, about style. But I feel pretty strongly that we can build a Linux app ecosystem where a KDE app will look great on Cosmic, a Cosmic app will look great on GNOME, and throughout the community by collaborating on theming and styles, that we can build a more robust, more successful application ecosystem by ensuring they work together. I think this is going to be a challenge, and we have Cosmic as an example of how it can be done, and then it's I think up to us to get out to the other communities and talk about the interest and the value of our apps all working well and looking great on our respective desktops. I think Wayland is an area you work in quite a bit, and there's a lot of work to grow and build consensus there. Right?
I mean, that pretty much applies across the stack. You started with customization, but we were very much at least involved with the discussion around the accent color portal. Mm-hmm. So progress is slow when you have to work with other people because you need to reach a consensus, but I don't think that's necessarily a bad thing. And I hope we can be one of the contributors that just tries to mediate on contentious topics and in the end arrive at something that is workable for all of us. And I think the accent color portal is a really good example for that, even though it's just a very small piece of the puzzle and obviously not as themable as the full extent of what we provide in Cosmic is. But I think it's a really good core example of what we want to achieve in the long term there.
Right.
Thank you both. I think we're running out of time, but I hope you can find them around the summit if you have more questions.
Yeah. Thank you.
It is time for a break. We had 2 exciting talks today so far. We took the group photo, so maybe we should take a break until 11:30. And after that, we will be talking about open source and artificial intelligence. Please be on time. We are going to start at 11:30. And don't forget about the swag as well. Hello again. Did you enjoy your break? That's a quiet room. What's happening? You should have had coffee and be more energized. Let's try again. Did you enjoy your break? Are you ready for the next talk? There we go. Together with me, I have Christian Hosling, and he's going to talk about Open Platform for Enterprise AI, or Opia. Thank you, Christian, and good luck.
Thank you so much. Is the mic on? Yes, now it is. Okay. So I'm just really impressed with Canonical here because they gave me a clicker that has next on the green button, so the stupid German doesn't mess it up. And I haven't had enough coffee, I guess, myself. So, yes, as Andrea said, just to quickly introduce myself, my name is Christian Holsing. I work for Intel, and I cover open source vendors there. And I would just love to give you a quick overview of an open source initiative that Intel initiated called Opia, the Open Platform for Enterprise AI. Okay, the next button works. I claim success here. Wonderful. So the challenge that we see, and I'm sorry for that, although I'm an open source guy myself, I'm taking a little bit an enterprise view on this whole topic here, because ultimately we're all here to drive some revenue being paid, and unfortunately that involves pleasing customers. So from a Gen AI topic perspective, there's actually an emerging conflict that we see. If you look at what open source is doing, what the whole AI ecosystem is doing, what model providers are doing, it's incredibly fast. But on the other hand side, we see companies and enterprises actually adopting changes really slow. And that's a problem that we see, that I also see in my group, with my colleagues, that basically large corporations would love to use Gen AI more and more, but they actually struggle to figure out how they can move it into production, stabilize it, even comply with regulations that are enforced on them. And I basically had one that Intel enforced on me. I found a glitch in the presentation about 20 minutes ago and thought I'd rather update that. But when I thought, oh, I have my USB key, I just copy it there. I got a lovely message from Intel IT saying you're not allowed to copy it on a USB key. You can only read. So let's not discuss that from a security perspective, but from a virus perspective, but whatever. So these things are out there, they are reality in corporations, and we all as an ecosystem, as a community, need to figure out how we basically address that. Second aspect, second problem to this whole topic is the question of enterprise data today is mostly stored locally. There is still the move into the cloud, no doubt for that. But there are IP concerns. For example, there are local data centers. And again, this is kind of a different view on the problem I described initially of, how can slow-moving enterprises or kind of slow-moving enterprises start to adopt faster, I'm not saying with lightning speed, but faster, basically AI models and AI capabilities. And I think we have a lot of the building parts as an open source community with Kubernetes, containerization, and those kind of models in place. Open source, closed source, a mixture of running these workloads. But there's still some work to do to actually be able to deliver it and implement it in enterprises. So a few challenges, I spoke about them and made a little bit of fun about them already from an enterprise perspective, but really, if I'm moving open source, if I'm moving a commercial application into an enterprise and try to deploy it there, I have to comply with a lot of rules. That's starting with validated stacks. So I'm coming out of a collaboration email system background, and I can just tell you that some of our customers were testing even an update to an email client for about a year in production before they would even move and roll that out, which really conflicts with the speed that AI represents today. So validated software stacks is a problem. Security and manageability is a big problem, right? Because that was also a recent experience I had. I took the family to the US for vacation. Our flight got canceled. So as a German, I flew Lufthansa, and I was interacting with their app, which was basically a chatbot using AI in the background. Right? So there is a different requirement. From an open source perspective, from an end user perspective, we're probably all accepting that the service is down and we have to wait an hour or two. But if you put yourself into the shoes of using AI in a money-generating environment, that's unacceptable because it's really crappy customer experience. If you're stranded at an airport and you can't find anybody and there is a queue of 150 people in front of you before you're able to talk to a human. So just a couple of things. Enterprise grade is the same thing. There are not infinitive resources, even if all the cloud service providers give us almost infinitive resources. There is a limited resources for sure, which is money. So there really is a pressure on this whole topic, on the whole deployment, and the answer, I think, that we're coming up from an open source ecosystem perspective in a lot of times is defining standards, defining a way to really standardize the different components and define a reference architecture, so to say, on how to start driving things into production. So ecosystem complexity, I think I touched most of them already. It's just a more comprehensive list than the one before. Let me just touch one point out of this, which is important, integrating with enterprise systems. Right? As I said before, the data needs to come from somewhere, and that needs to be integrated. This is also why very often companies are just not taking their model and move it to the public cloud or train a model in the public cloud, because that means I have to expose data. So I could just do a little detour to confidential computing, which is one of the nice projects that we're doing from an Intel perspective right now with Canonical. So there are answers that are being worked on, but still it is a challenge. And the question of how do I bridge all these gaps, how do I bridge all these different processes and rules is, in the end, what we're trying to address with Opia. Also, obviously, the technical complexity. I hope that most of you have heard about the term RAG et al., and maybe I should explain that a little bit more. So in the past, I think AI meant I'm an enterprise or I'm an end user. I take data and I start training a model. That was working for a while, but if you followed the press recently, so there was, I think, OpenAI, that went to the US government and said, we want to do a US-based AI data center. We need 3 nuclear power plants to just power that. So where I'm going with this is training a model with billions of parameters is cost and time intensive. And what we see happening right now is a shift in the market that especially enterprises rely on pre-trained models instead of going out, invest in infrastructure, and start to train model. So AI breaks right now into two different disciplines, if you want to say it like that. One is training of models, which is, as I said, super compute intense. Just to give you kind of an idea, and you find this on public sources, if you go and buy a server with 8 GPU cards in it, that's basically almost blowing your data center, because we're talking about 10 to 15 kilowatt hours of power consumptions. And we've seen this in the German data center with one of our customers. One of their racks is specified with 8 kilowatts. So it's an interesting problem here, just from a compute perspective for on-premise with training. That's why a lot of people just move to, I use models that somebody else has trained, like Llama from a meta perspective, and I deploy that for my AI use cases. Now the question comes, how do I make that context sensitive? Right? Because your context, your enterprise has different data. And a friend of mine who's doing AI projects explained it to me in a way to say, the model is a multi-dimensional room, if you look at it that way. And when you send a query into it, it randomly starts somewhere. So the quality of your answer might be good or bad, you don't know. So the context of your query becomes important. Now this is what RAG is introducing. Instead of retraining a model, basically what you do in the RAG stands for Retrieval Augmented Generation. What RAG as a concept is doing, you basically take data, it could be a PDF, it could be an image, something, you parse that and move it into a vector database. So you probably have heard that concept before, the discussion about vector databases, which are rising right now. So it's a lot driven through the RAG architecture. And these vector databases basically store ultimately the data, the weighting that you put into it. And when you do a query, how the RAG model works is you basically say, I'm taking a whatever, for the sake of the argument, I'm taking a PDF that I want to ask the model questions on. So I'm taking the PDF, I turn it into so-called embeddings, store them in the vector database, and then these embeddings are moved into the LLM, so that basically you're not randomly starting anywhere, but based on these embeddings that you attach to the query, you start at a dedicated point where the context is very close to basically what your query is about. Now, you've heard I spoke quite a while explaining this concept, and if you look at the different components that you see on the architecture, it's becoming pretty complicated pretty quickly. Going back to where I started on this, if you go out to a customer and just for the sake of the argument, I live close to Heidelberg. There is a small enterprise software vendor called SAP very close by. So if you go and have a discussion with SAP about an architecture like this, there are a lot of people that have a say on this and have concerns. And how do you make this enterprise stable? How do I scale this out? And it's becoming pretty complicated here very, very quickly. You know, because again, it's above the vector database. There are tools to embed the data from the vector database back in. There are tools to parse data. So it's all open source. That's the good thing, or mostly open source. There's still closed source in it. But the model, the reference architecture becomes pretty complicated. So now going to Opia, as I said before, this is an initiative Intel started, open platform for enterprise AI, which is open source. I think it's accepted by the Linux Foundation already. But it's really, as I said before, an approach to simplify RAG models and standardize them, and have the open source ecosystem starting to contribute to it. Intel is contributing heavily into it, others do as well, and basically package it up at some point and be able to go out to an enterprise and say, instead of you're doing a research for half a year, 3/4 of a year, here are prepackaged examples that you can take, deploy, and take forward getting experience on it. So Opia really becomes a framework of composable building blocks. So the components I had on the chart before are defined. So these building blocks can be pulled, they can be combined, they can be replaced, you know, because somebody has corporate rules of using a different vector database. So the whole idea is I'm able to just replace my vector database with the one that's favorite of mine, or use a different LLM for it. It becomes a blueprint. You know, how does the whole RAG process work? And where can I start to basically get something into production, into production for a POC level? That's part of it, and also the assessment from a enterprise perspective, because ultimately you need to scale. And back to my Lufthansa example, at that day when my flight got canceled, it was probably a couple of thousand people that were interacting with their chatbot. And back to the crappy customer experience, right? If you get a slow response, then you're impacting your end customer. So it's also about performance, trustworthiness, enterprise readiness, really working with companies like Canonical here to bring it to that level and advance it to a point that you can easily move out of a POC into production readiness. Very high level, the way the project looks at it, and I referenced containers before. So the Opia architecture is a set of microservices, so containers, that make up a solution, including the LLM data prep, vector database, and so on. Everything becomes bundled into a mega service. So think about this as a use case. And an API entry point into it, because most of the work that's being done here on Opia is API-driven. So people write their own front end quickly, do a REST call into the Opia platform and get their answer. Which then is starting to break it down. I mean, there's still the same complexity that you've seen on an earlier chart in terms of microservices that can vary and that are plumbed together, right? But there are building blocks through Opia where you can start using, the model embedding containers, and then you just really, from an end user perspective or from a deployment perspective, start to replace the parts that don't meet your need for whatever reason, regulatory requirements, compliance, whatever. So that's really the overarching idea of the initiative and the project here. And here's a list of the initial services. This is all on GitHub, by the way. So it's completely open. You can basically go out, see what the development status is. Right now, there's a lot of contribution from Intel as we've started the project, but we see other companies starting to contribute more and more. So there is the reference architecture, the reference services. You can go on GitHub openly, download it, play with it. Here's a list of the services that are actually available and are pre-packaged at this point for your reference. And as we're talking about an enterprise deployment, it really comes back to the question of how does the data center stack look like ultimately, and how can we go to a customer, whatever your favorite customer is, and have an offering together with Canonical here to say, here's the foundation, here's a secure operating system, here's a secure Kubernetes management engine, container runtime, all the APIs are managed, and you put Opia in a containerized version on top. So that's work that's going on behind the scenes that we're collaborating on. And as I said initially, if we look at enterprises, there is companies that want everything on premise. There's companies that embrace the cloud. So we just had this discussion internally on Thursday in a team meeting of some customers just have the policies of, I just want to move everything to the cloud. I mean, AWS customer, everything has to run there. That's my policy. Others are saying, no, this has to run on premise because there is confidential data. There might be legal contracts that are feeding into the rack. And from that perspective, a company might just want to keep that on premise. And of course, you could go hybrid to some extent, and then the question for us becomes, how do we architecture this? How do we secure communication? How do we manage latencies? All these kind of funny things that come out. So this is kind of a snapshot of the project. Importantly, you see Canonical on there as well. So Canonical joined the Opia project recently. We're working very closely with Andrea, for example, and team here to to drive it, and it's an interesting and growing ecosystem. So this is already a couple of weeks old, but there is a lot of discussions. There is on opia.org or opia.dev, you can basically also start joining the groups. So there are regular meetups, as you would expect from a typical open source project. Feel free to take a closer look, and hackathons are happening right now. So all of that is public. So here's actually the slide that I noticed was messed up before. What we're doing from an Intel perspective right now is taking this one step forward. And in the next few weeks, there will be productized examples. The examples are already out of GitHub. We're working on productizing them. And one of them is a Q&A chatbot. So this is basically an end-to-end solution that you could just download, play with on potentially a local machine for not good response times. That should just do the trick. If you want better response times, then you could take this Q&A, and it's really a complete solution where you can just take enterprise data, PDF, whatever, feed it in there, and then run questions using an LLM of your choice. So this architecture is out there. The solution, again, will be stabilized. That's work, and there will be definitely more of these solutions actually coming out in the next couple of months. So that's where Intel is focused, besides the contribution upstream to the project. So this is the architecture. No surprise here. If you looked at it before, there is a user interface even that we provide as an entry point. But it's all the building blocks that we talked about before. Just as I can download it, I can deploy it, it works, and then I can start from there and adjust basically the different components based on my own needs or your customer's needs. Let me talk 1 or 2 minutes about Intel and open source. This is, I think, since I joined Intel, one of the best kept secrets. We are, for the last couple of years, #1 contributor to the Linux kernel. Intel has about 10,000 to 15,000 software developers that contribute to open source, and it's really across the board. I mean, it's fairly obvious when I'm saying, okay, we do kernel work, that we basically provide drivers to Intel GPUs and so on, the latest CPUs, but it's also really general work that we're doing, key kernel contributions, Kubernetes. If you think about PyTorch, TensorFlow, for example, as the runtimes that we're using in the AI/ML space, we're also very, very active. And Andrea has a nice project out called DSS, Data Science Stack, where basically the Intel optimizations for PyTorch are just prepackaged. So that's a lot of work that we're doing behind the scenes that I just want to mention, but that's a company strategy from an Intel side, wherever possible, going open source and contributing things to the Linux Foundation, and basically helping you guys out from an open source ecosystem to really advance things. So no Intel presentation without a roadmap. So basically, just quickly for your reference, this is the Opia roadmap as it looks like today. So really the next steps is the models, the examples that we want to bring out. That should happen in the next couple of weeks and months. And then really advancing the rack architecture, advancing the whole solution, and as I said, making it more enterprise ready. That's still some work to do here, but I think we're on the way to go there. And with that, I'm landing on time. I have 6 seconds left, so.
Exactly. Thank you, Christian. We have time for one question. Let's see who's running first to the mic. Don't be shy, don't be shy.
They are.
They are shy. Okay, then I'm going to ask you something. When it comes to adopting open source in enterprises for AI/ML use cases, there's obviously a lot of excitement, but there are still challenges. What do you think is the biggest challenge, or what have you seen as being the biggest challenge?
I think one of the biggest challenge in general is just the discrepancy between the speed of open source and the readiness for an enterprise to adopt. I mean, I spoke about Kubernetes in a former job. We were trying to deploy a Kubernetes-based stack, and I think all of you know that Kubernetes has quarterly release updates. The customer, it took them about half a year to just test the next Kubernetes release, which means they would get 3 months of a window to use that, and then they had to run over. So there is a challenge, and I'm not saying that only the open source developers can and have to solve that. It's also the enterprises getting there. But I think really coming to a point of stabilizing it, shortening the test cycles, building trust in both directions is important, right? And I think it's very hard from an open source developer perspective to realize the challenges that enterprises have, because if things are down, just another example, I myself worked in the SAP space for a very long time. And when an SAP system was down at a retailer, they are losing millions of dollars a minute. So you're not messing around with that. And there are really different requirements. And if we can solve them together, then I think we get open source a really long way into the enterprise.
Thank you, Christian. If you want to talk further with Christian, or you can find him around probably.
Or Helena for Opia. So find us. We have an Open Vino, sorry. Excuse me.
Thank you. I think we are getting ready for our next talk. I hope you are not too hungry. It's almost lunchtime. But we still have some interesting topics to discuss about. And we stay around the same big theme, AI/ML, and we'll talk about how TCPX optimizes RDMA and GPU direct performance for AI/ML and HPC workloads, together with Hassan Tasnim and Hugo Huang. Let's give them a big round of applause. There we go. Yes.
Thank you. Hey, everyone. So my name is Hassan, as Andrea already mentioned. So today we're going to have some fun talking about how TCPX optimizes RDMA and GPU direct technologies. So just to kind of quick recap, refresher, RDMA is the direct memory access, which is the memory communication between one CPU host and the other CPU host without going through the operating system. And TCPX is a Google-developed and open-source software that essentially implements that technology. So my name is Hassan. I'm with Google. I'm a product manager there. And with me today is Hugo.
Nice to meet you all. I'm Hugo Huang. I'm the product in the Chronicle side. So I think today we would like, it's very approaching the lunchtime. I know everybody is quite tired. So just to give you a very small task, can anyone figure out what's the problem with this picture? Hands up.
The handle.
Wow, great, great. Yeah, we'll deliver a chocolate for you afterwards. Okay, thank you. Yeah, this is the AI-generated picture. And at the typical unfortunate situation when you are, in the transfer of the airport, so everyone don't like the hops between flights. It's really, in the technical term, we call it the latency, right? It increases a lot of the latency, and maybe a couple of hours, maybe a few, maybe days. We don't know because it's latency. Yeah, that's the most status thing about when I come to the Hague. I transfer to Copenhagen. I stay there for more than 8 hours. So it's really, really bad experience. So anybody take the direct flight here?
Direct.
Oh, so fortunate. Yeah. Okay. So we'll get into the RDMA. We'll tell you why it's so good to take less hops.
Yeah. All right. So, so this is a rough agenda of what we're going to be talking about today. But let's go into explaining why we need RDMA in the first place and what is happening, when a host is talking to another host, specifically in terms of AI/ML workloads. So if you look at this kind of picture, there's a green line which is showing the intent of communication. So in a very basic term, when we are talking about the intent, we have a device memory, which could be any device. It could be a GPU device. It could be a camera. It could be any device you can think of. And what it's trying to do is it's trying to talk to another device in the destination host, because that's how the training is being conducted. That's the intent. Now, that's not exactly what happens in the real world without RDMA, of course. If we are using any AI/ML application, for example, running PyTorch or any kind of training, what is going to happen is that the device memory is going to talk to the operating system, kernel going to talk to the host memory. Host memory is then going to talk to your network card, transmit it, and the whole process is going to be reversed. So as Hugo was explaining, lots of extra hops involved in the communication between device memory to the other device memory without RDMA. Now, that's one of the problems. But if we look at some of the application use cases, so in some cases there's a file being transferred, let's say from a camera to on the other host side. It's just a file. It doesn't require CPU to be processing it, right? However, if we are using it without RDMA, that's exactly what's going to happen. CPU is going to find a memory block in host, go through, the host is going to assign the memory block, go to the network card, and so on. So that's really the problem that RDMA is trying to solve. It's trying to make sure that the actual communication is happening based on the intent. And here the intent is that we don't need any operating system processes or the host memory to process anything. So let's look into a little bit more detail. Hugo, do you want to?
Sure. This is a very basic logical graph about diagram about how the communication goes. First, you'll see on the left side it's the traditional network. Then your application initiated the conversation, and then your OS kernel will get involved to prepare data for transmission. And then you'll go through the session, go to the transport, go to the network. So all the 7 layers of the TCP protocol, you will go through everything. And then that's the first from the hosting machine, and then the receiver will need to get through the same process. It's a lot of hopes that you expect a lot of the delay and latency. But in the RDMA, in the right side, you can see that we just pass over the. Could you click again?
Yeah.
Okay. Yeah. We just pass over the 3 layers. We don't get involved in the presentation, session, transport. So the application initiated the conversation, and then the network driver, the NIC card, just start to communicate with other card. So we dump the data from the one host to another one. So this is quite the benefit we can get from the RDMA.
Great, thank you, Hugo. So the whole concept of RDMA here is to improve on 2 things. One is to provide the maximum throughput for the application communication, and second is to do it at the lowest possible latency. How does it do it? Essentially, the whole concept is to keep the data transfer at the lowest possible layer while keeping the control channels being at the application layer. So the reason we built TCPX is because it's a software implementation, and we're going to talk a little bit about later why it's super flexible, because it's not dependent on a certain type of hardware to be used. And how TCPX operates is shown here. Basically, we talked about the intent, that the intent is for the device memory from one host to talk to the device memory on the other host. And how can we reduce the number of hops here, which is also going to improve the throughput. So how it happens is that the applications on both sides are responsible for creating the control channel. And this control channel is essentially a wake-me-up control channel, which means it only gets activated when the application on host 1 is going to request it. It's not always open. So it's a very dynamically created channel, which essentially also makes the communication very efficient. So once the application on host 1 goes and creates this control channel, the data channel is built between the two NICs, and the NICs are directly then talking to the device memory. So in simple terms, we have bypassed the host memory from this operation completely. And as we were talking earlier, we had four hops from talking between these two device memory, and now we have basically one hop to talk between the two memories. So I think it's important to say that all of the data packet payloads are still TCP packets. So they still have the same payload, same headers and whatnot. But all of the packet transfer is happening at the data channel, not at the application or control channel. So let's get a little bit into details on, I know I said earlier that hey, TCPX is a software-based solution. There are other solutions in the industry that are built by many other different vendors. Some of them are software-based, some of them are hardware-based. One very famous one is InfiniBand, which is used for GPU Direct. So here, Hugo is going to talk a little bit about TCPX versus InfiniBand.
Sure. This is a graph, very obvious that you have to connect all the network cards, each one. I think this is good because it's a fully mesh, and you can ask each of the cards to talk with any of the other one directly. This is very efficient, but also it's some difficult problems we'll have. That means you have to wire them by yourself or by some of colleagues. Imagine, Hassan, you're from Google, right? Suppose I want to rent like 100 GPU from you. Will you go to the data center wire for me?
Not really, no.
Oh, okay.
If you pay me, but anyway.
Okay, how much I need to pay? Yeah. Could you explain to the audience what is the DCN?
Yeah. So DCN is basically a dynamic core network. And what it does is it's a mixture of the packet switch networks that we have in the modern networking and the circuit switch networks that we used to have with the telephones. So what essentially DCN does is if you have like a, let's say, basic fiber optic connection between two different cards, DCN is dynamically creating and destroying channels within that physical connection so that your applications and the hosts, they see a virtual channel as almost like a physical channel. But what DCN can do is, let's say you have a 200 gig physical fiber connection between two different devices. DCN can take that 200 gig bandwidth, and it can slice and dice it however they want. So you can create a 50 gig one channel, 100 gig another channel, 50 gig third channel, or you can create 4 channels of 50 gig each. Why it's important is because when we are running it in a host, you will have many applications probably that are using that bandwidth, the same physical pipe, right? But what's important is that to avoid the noisy neighbor problem between the applications, which means that, hey, if I give the whole 200 gig to application A, and it starts using all of that, now my application B's throughput is going to suffer. So Really, the whole concept of DCN is to manage the physical connection, in a more circuit-switched, virtualized way.
So in other words, may I understand it's in any place of the world of your data center or servers, I can make sure there is a direct connection between each other, about 200G at most.
Yes.
So it's like I can, logically hardwire any of the server from any of the data center of the Google that make it have the similar experience like hardwired.
Exactly, and not just Google, but also your on-prem other data centers, because DCN can be run on wide area network. It can be run on any logical network. It's a layer on top of an existing network.
Okay, that's good news. So
yeah. So you can make your on-prem network look like it's sitting right next to your Google network in the same data center, even though that's not the case, physically speaking.
Oh, great. So you don't need to wake up at 12 o'clock in the evening to hardwire any of those cards. That's great. Yeah. Speaking of the software, the advantage of software and advantage of the open source, we will see other problems of those hardwares because it's very high cost, right? There's only one vendor, so far as I know, only one vendor can provide those cards, and it's very expensive. Even I just searched this morning in the Google, I find that even those wires, you have to cost you more than $200 for each wire.
Yeah.
So it's very high cost, and also because you need to learn by yourself, or learn your employees have to learn these new technologies by themselves. You cannot actually leverage your existing knowledge and your existing networks. So that's a very expensive operation and management cost. And also, the worst thing about this kind of the only one vendor can do that is you get a vendor lock-in. That's the essence of open source, right? We don't want to get vendor lock-in.
Exactly. So, Hugo, what exactly is InfiniBand?
I don't know. I don't want to know that now.
All right. So I'll tell everybody what InfiniBand is. So InfiniBand, I keep calling it Infinity Band, but InfiniBand is essentially a wire between two GPU cards. It's an optical wire that is creating a connection between two GPUs. It's a somewhat newer technology, and it's trying to do the same exact thing that RDMA is trying to do, which is a direct communication between two devices, in this case, GPU. But as Hugo said, and as many of you would understand, that nobody wants to go to the data center, or even if it's not a data center, if it's your cloud deployment or whatever kind of server deployment in the basement, for example, nobody wants to go and start creating those wire connections between the two cards. So it's expensive and it's time consuming. So that's really what we are trying to solve here with this open source project, that you are able to leverage the same benefits without having to do the expensive efforts. All right, so let's talk a little bit. We have already talked about the advantages, but let's get a little bit more into the details of them. So why is TCPX better, right? Like we have talked about RDMA. There's many different vendors who are implementing RDMA, some of them through software, some of them through hardware solutions. The biggest benefit of TCPX is that we thought about it to be sort of an open implementation of this technology, meaning we don't want to lock anybody into any sort of vendor. So the first biggest advantage of TCPX is that it's more adaptable. It does not care about the hardware. You can use this to have direct memory connection between two regular memories or GPUs or any other device that is created in the future. this technology can be used to create a direct connection between those two. Some of the advancements, because it's based on TCP, and TCP also is obviously evolving with their own improvement in stacks, naturally TCPX becomes better and better over time because it's leveraging the TCP technology itself. We already talked about how it is less demanding on the hardware compared to the other RDMA technologies. This is one of the most fun point, the next one I'm about to make. This is a unique capability of TCPX, which is the receiver and sender sides are very independent. So if, for example, you have control of the sender and don't have control of the receiver, you can implement TCPX only on one side. So the optimization is on one side. Granted, you're not getting the full benefit of it, but you're still saving a lot of host memory on the sender side. Same applies for the receiver side, too. You can actually implement it on one of the two sides to get the benefit on the specific side. Because obviously it's using TCP, so the other side can still decode your packet. It's just going to have to go through the operating system layer and so on. And then finally, we talked about the hardware versatility. You can implement it on pretty much any device, whether they are NICs, whether they are GPUs or whatnot. So Hugo, do you want to tell us a little bit more about other benefits, real quick?
Well, I think the most important thing I consider is that you have the capability to scale it. So when you have, you normally won't do like only 2 GPUs, right? In most of the case, you do like at least dozens of or hundreds of. And in the extreme cases, we found recently a use case that people would like wire like 4,000 GPU together.
Yeah.
And at the most, at Google, there's a lot of people are using TPUs because TPU is cheaper and sometimes more powerful. But some people also want to connect GPU and TPU together. So that means you have to have a protocol that works on both sides. So I think this is another benefit of TCPX because it works with both technology.
Yeah, that's great. So let's talk about all of the advantages in action. A very typical use case where you have multi-host distributed training running in Google's case with A3, which is a machine family that has A100 GPUs. Very similar discussion or design as we were seeing earlier, that you have Nickel, which is a GPU library, going through the user memory, kernel memory, and essentially what we are doing here is that the GPU memory is directly talking to the NIC rather than going back to the user memory and the kernel memory. So pretty much the left side of that red dotted line and the right side of that right dotted line, well, no, actually, just the left side of this red dotted line is not being used. GPU memory is directly talking to the NIC, and on the right side of the right dotted line is where it's being received. So a pretty simple use case. But the point that we're trying to make here is that if you take this use case, this is obviously talking about 2 hosts. Most of the machine learning and HPC workloads are going to be running on thousands of hosts, if not hundreds. Let's look at the bigger picture. That's when we can see the real benefit of it.
Yeah, true. At the bottom, you'll see that's the case we were just describing you about the 2 hosts. But actually, if you imagine a data center or multiple data centers, you will see so many GPUs, so many TPUs. The throughput is like a petabyte scale. So it's very, very difficult for, I can't imagine anybody have the technology, have the capability to hardwire so many GPUs together. I don't think even it's possible, it's not really scalable.
Yeah.
So yeah, I think that's the best benefit of the TCPX. That's because it's avoided from vendor lock-in and avoid you getting so many daunting tasks about, you get easy to get mistakes.
Great. So finally, let's talk about TCPX and open source. So we actually worked very closely, when we were designing this with a bunch of device vendors, at least in the beginning. But our vision was always to make it an open source project so that it can be utilized anywhere without getting vendor locked. So right now we work with Canonical to make it part of the Ubuntu kernel that runs on GCE, but TCPX is available in open source for both contribution and use. I think the biggest point that comes into picture here is that it's not dependent on a specific type of hardware or the specific company that makes that hardware. Similarly, in the essence of open source, we encourage the community to go and add, to the upstream code. Essentially, a lot of it is to make it more device aware. So when we are talking about how to implement TCPX on your host, it's a package, it's a set of libraries, you implement it on a host-by-host basis, but it needs to be aware of what kind of hardware you're using it on. So that's the biggest piece that we want open source contributions on.
Yeah, sure. That's why we're together. So Google open source this project, and Canonical Ubuntu support all the latest hardware and software that enable this.
Awesome. And it's actually something that we have known that many enterprises and startups who are not on Google Cloud have actually been using TCPX to improve their communication, make it more efficient, both on-prem and on other clouds. So I think that's the biggest, I would call, win for us, that it's something that is being used outside of Google as well. So I think with that, thank you for listening to our short talk here. We really appreciate your time.
Thank you. I hope you always get a one-hop flight to your destination.
Always one-hop.
Hassan, Hugo, thank you very much. Now it's that time. We still have a couple of minutes for some questions. Let's see. We have the 2 mics. Is there any question in public? There is one coming in.
Yes, hello. I had one question about security. How do you, are there some other things you need to take care of for security, or is it taken care of by TCP as normal?
Good question. So because we are creating a data channel on a lower level, the security is still the job of the application. So if you are going to send encrypted packets, they are still going to remain encrypted packets that needs to be decoded on the other side by the receiving application or the device memory. So for TCPX, it doesn't matter that what kind of packet you're sending. It could be an encrypted packet, it could be a non-encrypted packet, but because it's doing the job at a lower level. Hugo, you want to add something to that? No?
No.
Okay.
Okay, thank you.
Yeah.
I think we are running out of time. Okay, that's the last question.
Yeah, we can
I think we can.
You mentioned DCN is working like a switch, and is it necessary to make any implementation? Is working like a layer 2 or let's say drivers? We can use it, or we need special software for that to make
DCN.
on-prem.
DCN, yeah.
Especially for TCPX, it's related with that.
Yeah. So it's a separate set of libraries that enable that communication. So yeah, you're going to have to use it. But in a lot of modern host and operating system, it's available by default, because DCN is still it's still important even if you're not using TCPX. So it has many other applications as well. So. Yeah.
Thank you both for your talk, and if you have further questions, probably you can find them around the summit.
Thank you so much. Thank you. Thank you, everyone.
Do you know what this is? No. Well, I'm going to tell you a bit of a secret. When I was in the backstage, I was actually playing games. I went back some years ago, and this is a board that one of the teenagers built with open source tooling. And that's exactly what this talk is going to be about, how more than 40,000 actually teenagers build open source software. And for that, we will welcome Zach Latta and also the co-speaker Cheryl Berhanou. Let's give them a round of applause, please. Apparently they're shy. Let's see, there they are.
Cool. Can you all hear me? Sweet. All right, awesome. Well, my name's Zach, and I'm the founder of Hack Club. Thank you all so much for having us here today. My journey with Linux started when I was 12 in 7th grade and went to Ubuntu.com and installed Ubuntu without permission on the family computer, and had to use terminal to solve basic problems. And it totally changed my relationship with computing, because suddenly I was a creator instead of a consumer. And I've been wanting to make things for so long, and Ubuntu was really the thing that pushed it over the edge. And I started by forcing myself to use Linux as the main operating system for a month. That turned into an Arch Linux installation over time, and found this incredible community of people from all over the world who were making things, sharing it for free, inspiring each other, but most importantly, going to the events and meeting people in person. They were incredibly kind people. So before I'm going to talk about Hack Club and what we do, and we're a charity and some of the different programs that we run. I also have a Hack Clubber with me who will come on in a few stage, who's with us. I don't know if my clicker's working. But before I do, I just wanted to start with just a little bit of context, which is, I think as software engineers, we tend to take open source for granted. It feels like, oh, software is free. The cost of duplication is 0. Information wants to be free. It makes sense. It's going to be copied and shared and given away all over the world for free. But you don't have to look far to find what different realities could have been. I mean, you look at mechanical engineering, where your CAD files are also files on a computer that can be shared for free. And there is no good open source CAD software. There is no agreed upon version control. The type of community is not the same. It is so much harder to get started. And Autodesk has completely locked it down. You look at electrical engineering. I mean, thank God for KiCad, but very similarly, coding could have been that. And the reason why it's not is because a radical group of individuals, 30 plus years ago, had a radical vision for what the world could be, and then they worked tirelessly to make that vision reality. And it's because so many of you worked tirelessly to continue that vision and continue giving away software for free. But coding's changing. With AI, the way we write code is changing. If you go to a Hack Club event today, there's no longer Google Open. It's all ChatGPT. Every single person uses Copilot or Cursor, stuff like this. And when you look at the open source models, they're not really open source in the same way. The weights are public, but the training data is not. And the code used to train is not. And there's you can't really upload your AI stuff to GitHub in the same way you can upload your code. So as software changes, I think we're at risk of losing what has helped make this such an incredible thing for so many people. So a little bit of background. Hack Club is a charity. We help high school students get into open source. We serve people ages 13 to 18. We're all about real projects. So teenagers in Hack Club build real projects with real friends, both online and in person. Hack Club in its best form is a friendship factory. We don't have curriculum. We don't have teachers. We don't work with schools. The thing that we try and do above all else is help two teenagers that don't know each other meet each other and become friends. Because as a young person, most of the friendships that you have are friendships of circumstance. you happen to sit next to each other in class, or you happen to grow up in the same zip code. That's not a very deep connection. But when you meet someone else and you bond over a shared interest, now you have a hacker friend. And that friendship is motivated by building things. And the way you advance that friendship is through building projects together. And then finally, we're a big tent organization. So we have very low floor. Every year there are thousands of students that write their first line of code in Hack Club, but we have a very high ceiling. In Hack Club, no matter how far you go, you're gonna find someone else your age who's like 6 months ahead of you. And there are people in Hack Club who've made contributions to Linux kernel and have built things that have millions of users. And they're helping people who are 6 months before them. One of the things that makes Hack Club really unique and special is that in most learner spaces, the advanced people are separated from the beginners. And in Hack Club, they're all in one room together, all helping each other. Hack Club, we're North America based, but we serve students all over the world. In our big summer initiative that we ran this past summer, we had 19,000 students sign up, and we had students in 119 countries participate. Historically, we've mostly been pretty US oriented. This past summer, we started being more intentional about Europe. We had so many students get involved. And one of the super cool things about Hack Club is you meet other teenagers who are just like you, who happen to be from a totally different background, totally different part of the world, totally different economic situation. But again, because they're a hacker friend, it's a motivated friendship. And it's something where you get closer through building things together. So I want all of you to meet some Hack Clubbers. And I want to show a 9-minute video from our big hackathon we did this past summer. This event that I'm about to show you was organized by an 18-year-old Hack Clubber named Dave. One thing I'll share more about is everything in Hack Club is built by students for students, including this epic collaboration. And you're going to see a train chartered across North America in partnership with the Canadian government, and that entire partnership, everything was ran by an 18-year-old. So I want to share that, and in this video, you'll see Cheru, who's a Hack Clubber who's backstage right now, who will come out and share some of the open source work that they're doing at Hack Club. So with that, let's get started.
Across the boreal of Canada, far away from factories and cars, riding the train through the forest and plains, under the moonbeams and stars. Stars. Beneath the beauty, a danger remains, with nature in the clutches of climate change. This is our time.
It changed quickly Monday night. Strong winds pushed fires from the outskirts of Jasper to within a few kilometers of town.
The town of Jasper and the national park now under an evacuation order.
About 25,000 people drove for hours through darkness in bumper-to-bumper traffic on the only highway out.
So I just woke up, and the people outside were talking about how we're going backwards right now because they're evacuating Jasper, which is our next stop. So we're going back to Vancouver.
We came across this one stretch where the entire hillside was just engulfed in flame. It looked like I was staring directly into hell.
Really, at the end of the day, what makes a great Hack Club event? It's three things. It's the friends you meet, it's the projects you build together, and it's the adventures that you go on. And if anything, we can do all three of those things in an even deeper way than we could before. We now feel the reality of what we're talking about in a much deeper way than when we first talked about it at opening ceremony.
I
I've been making a plant monitoring system, so you can monitor the water levels in the soil of plants, and it will send you an alert if the plant needs watering, or if you're overwatering, and it can tell you about the overall health of the plant. So to do this, I've been designing a circuit board. Over here, we have a microcontroller. We also have some programming ports for it, and some indicator LED. We have an oscillator for the microcontroller too. We have a temperature sensor. It's also a humidity and pressure sensor. And we have a LoRa module that can be used to alert people when your plant needs watering.
It's sad that it couldn't be what it otherwise could have been because of the wildfire, but I'm glad to be here anyways.
The creeper trying to steal our stuff. Help him out, help him out.
We're at the train station, but we're about to take a bus to go visit Linus Tech Tips.
Seeing the real habitat loss happen in front of me, like through the train, like the wildfires burning down all the forest, like I was thinking the work that colleges are doing is really important, so more forms of awareness, how that's really important. So essentially the user should be able to choose their setting, choose their species, and various other factors that goes into like a real ecosystem, and then based on that I want to like display calculations for like various ecosystem parameters. So for example, like quality, which takes into account like biodiversity and ecosystem resilience.
It's working! Yay!
News broke about an hour ago that the fires have reached the town itself. If you look at the news, I mean, it's so tragic. There's like buildings on fire. As far as we know, like people are safe, but this is just one example of one of the greatest crises that our generation faces. Every person in this room is gonna have some sort of role. Before we kind of get off to all the fun stuff, we could just take like 1 minute, close your eyes, send good thoughts to all the people who are like actively being affected by this, and just have a moment to like all reflect.
And I think every single person on the train really felt climate change and really felt the effects of what we're doing to our surroundings and to our environment.
We all pulled an all-nighter to finish our projects. So yeah, we have to demo in 2 hours and 30 minutes, so hopefully it all goes well.
So we implemented the GPT algorithm entirely from scratch, and then we had to collect a massive data set. We had to work on all the infrastructure to like load this data, the model architecture. Eventually we had it learn some basic structure of human language, which is really cool.
There's a lot more connecting and interacting with people. After the scenery kind of stopped, we kind of had to look more inward into the train and at each other. Definitely this hackathon, we're a lot closer together, both physically and like emotionally.
always heard about wildfires around me in BC, in Kamloops, etc. And I was never really moved by it. It was just a story in the background. And suddenly when we were on the train and we could see the wildfires right beside us, it was really, really like moving. So I downloaded a data set of about 1.8 million wildfires in the US. And I used Duck.gl and Mapbox to plot them every year. So here you can see what is the reason the wildfire happened. And you can play to see how it changes from year to year. And my goal was, one, to visualize the past, and two, to see what we can do in the future. So based on all this data, I trained a random forest model to basically predict how big a wildfire would be at a specific place. This gives an interesting insight to like how climate change is getting worse over time, and also helps us, look ahead to the future.
This is our time, we're hacking together. Nothing's gonna stop us now. You had your time, now we can do better. All aboard will show you how. 'Cause don't it always seem as though we don't know what we've got till it's gone. It seems so clear to me. Young minds and technology and nature are all we need. This is our time. It's time we work together.
So that's some Hack Clubbers in action. And that event was just one of dozens of events we host every year all around the world to get teenagers building projects with other people their age in person. We have an upcoming game jam called Counterspell that's happening in 50 cities simultaneously in November. Up on the upper right, 30 Hack Clubbers went on the Pacific Crest Trail in California on a 7-day through hike. None of them had been backpacking before, and they made their own radios from scratch and even made their own PCBs for that. On the bottom left, there's an awesome hackathon that happened in Boston earlier this year, and we do a ton of hackathons to help young women get into technology that are led by young women in Hack Club for other young women in Hack Club. Big picture, when we think about okay, what does successful open source education for young people look like? It's student-led. There's a leadership component to it. It's peer-to-peer. We run a massive online Slack community with over 4 million messages sent in it each year. And then young people need resources, particularly access to hardware. Many young people don't have fast laptops, and they don't have access to materials to learn how to do hardware projects. So we run these grants where you put challenges out to teenagers, and when they complete that challenge, they then get resources from Hack Club to take their work to the next level. And with that, I'd love to welcome Cheru onto the stage. Could we give Cheru a round of applause? Cheru's a 17-year-old on the Hack Club team. And is one of the engineers behind Sprig. Do you want to tell us about Sprig?
Sure. So yeah, Sprig is this kind of a lot of things. It's a game console, it's a game editor, and it's a game engine we made to get beginners into making games and coding. So we created this game engine, and we have this GitHub repository where anyone can submit a game if you're a teenager. So there's 700 games people have submitted, and the idea is if you're a teenager, you make your first game, and then we'll send you one of these consoles. So we designed, how does this work?
Yeah, here, I got it right here.
Okay.
Do you want to?
Yeah. This game console from scratch that we'll send to you, and it's also a hardware development kit. So you put it together, and then you can also hack on it to go further in tech after you've made your first game. And I'd like to show you some games that people have made. These were all made last month, actually. This one was made by a 17-year-old in Switzerland. It's just one of those phone games where you connect dots to fill a grid. This is actually, I learned today, this was made by an 11-year-old, which is kind of crazy, in Alberta in Canada. And it's a game in which you control a spaceship to navigate obstacles. And this one's one where you have to, this gets progressively harder, faster and harder. and you have to, yeah, you have to navigate a board and collect points while avoiding this cat that moves around. And these were all built by teenagers who submitted to our gallery, and then after they submitted, we sent them one of these consoles, which will run your game.
Let me flip you back over.
Yes. So this is that first game I showed. If it'll load. And this console was also made by teenagers. So the PCB was designed by a 15-year-old Hugo in New York. The firmware I'm working on right now, it was started by a 17-year-old in rural Virginia. And we give this game console, and they play games, but they also hack on it. Since it's all open source, you can hack on the firmware and the hardware. This is Gabe, and he made Sprig into a controller for a drawing robot, which is another one of our programs. And he wrote this firmware from scratch using MicroPython. So, yeah.
Awesome. Let's give Chair a round of applause. Just a couple other Hack Club projects I just want to show all of you, because like the best part of Hack Club is that teenagers in Hack Club build like the most incredible projects. So if you, in your browser, if you go to cpu.land, L-A-N-D, Lexi, who was 17 when she wrote this and published it last year, wrote this like incredible deep dive book into how CPUs work, with, of course, the best stick figure drawings on the planet. Lexi, it's 16,000 words. Lexi launched this on Hacker News last year. It got 1,337 upvotes, which I feel like is just destiny. And over 500,000 people have read it. Every week, on average, over 2,000 people check out CPU Land, and it's like even been linked in like popular video tutorials on YouTube to learn how CPUs work. And she was 17 when she made this, and she like was mentoring other teenagers in the Hack Club Slack. She was getting feedback from other teens as she was working on it. I mean, just totally incredible. Charlie, who you briefly met in the video I showed earlier, he was working the plant monitor. This is Charlie. He's 14. Charlie is like obsessed with PCB design and spent this summer making Stratosaur Mark III, which is a drone built and designed from scratch. This is his printed circuit board. He designed in KiCad. I believe it's a 4-layer board, which is crazy. Has gone through many iterations, is like doing microsoldering in his bedroom to like get it working. Actually built the drone this summer and launched it from a weather balloon. I can't remember if it was at 5,000 or 10,000 feet. And you can give it a Latin long, and it will navigate itself to like whatever destination you give it. And like that's what Charlie worked on this summer in Hack Club. Louisa is a 16-year-old from Kenya. She lives in Nairobi. This is Louisa. She's amazing. Earlier, I was showing in that video that was like in the upper right corner, she was one of the people who went on the trail, this, you know, the 7-day through hike where teenagers built their own equipment. Have any of you seen the Pico 8 before? It's like a fun little fantasy console. She is writing, I believe, a Chip 16, which is a Pico 8 variant emulator to learn how to write emulators from scratch right now, and she's posting daily updates. This image is an assignment from her robotics club, but you can see like she's posting her emulator, she's getting feedback from other Hack Clubbers. It's like very social. Zahir, who's 17 from the United Kingdom, spent his summer writing an operating system from scratch. It was this, and it's actually, I believe it's actually bootable with like a bootloader written too. And this was the first time he like really took a stab at doing low-level programming and like invested like almost 200 hours into this thing. We do, everything at Hack Club is always peer motivated. So we do like these peer, judge is a strong word, but like peer voted project celebrations. And Zahir was the most voted this summer as people dug into the project. I mean, it's just totally crazy. Oh, it's my, I think it'll pop back in. There you go. Annabelle is a 16-year-old from Australia. She is amazing. One of the things she did this summer was she wrote a terminal website as her new homepage. It's pretty sweet. Not only are there different commands, she even wrote her own like NeoFetch alternative, and then she deployed it on hackclub.app, which is a tilde server that's designed and built by hack clubbers. Like, one of the challenges a lot of teenagers run into is it's very easy to find free front-end hosting. There is like no free backend hosting available anymore. Like, they used to use Heroku, but like that they've shut down their free plan. So hack clubbers have rented like a, do you know how much RAM is in it?
Like 96 gigabytes?
Yeah, like a 96 gigabyte RAM dedicated server from Hetzner for like $60 a month, and they set up a shared Linux installation, and there's like hundreds of users on it where hack clubbers are like learning Linux, deploying their services. They're using systemd to like keep their things running in the background. So Annabelle deployed this site there. And then with the grant challenges I mentioned, these are the You Ship, We Ship grants we run, where we put out these project challenges out to teenagers and say, hey, if you build X, Hack Club will give you resources to do Y. The reason why we do this is because we've noticed that by far the most effective thing to help a young person who's like kind of on the edge and trying to get started with making code and writing projects is help them build something they're proud of. And somehow, like, I mean, as all of us know, if you want to be a developer, probably the thing that matters more than anything else is actually making things. And yet somehow in most computing classes, that's not prioritized. And it's for young people who are teenagers, they're super busy, and it's definitely not prioritized by many of their parents, and definitely not by the college admissions process. So Hack Club is trying to create a space and a system of incentives where if you spend your free time coding projects, you just get hugged with support. Not only with peers that you look up to who are like, you're awesome, that's awesome what you just did, but like with actual tangible resources you can use to take your work to the next level. So with Boba Drops, this is a beginner-oriented one. If you're a teenager and you design a website from scratch and actually host it on GitHub Pages or any other Git host, we will buy you bubble tea from your local boba shop, because that is an essential coding tool you need. Onboard is a PCB grants program. We actually collaborated with Steve Wozniak from Apple on this, where if you're a teenager, you're age 18 or under anywhere in the world, if you design a printed circuit board from scratch and publish it open source, and you have to use a piece of open source software to do it, like KiCad, we will give you a $100 grant to actually get your printed circuit board manufactured. We funded over 600 teenagers, almost all of whom are making printed circuit boards for the first time, and that's enough for like 2 to 4 design iterations of most board types. HackPad is super cool and just launched. This is our first multidisciplinary grant, where if you're a teenager and you design a circuit board, use CAD to design your case for it, and then code the firmware, I think it's in QMK most people are using, to build your own macro pad or mini mechanical keyboard, we will then send all the parts that you need to actually build it in real life, including getting your board manufactured. We'll send you the keycaps and the switches and everything so you can actually have a real product that you've designed from scratch that's like on your desk that you made. This is another one of these programs. They're called Retrospect. How many of you got started programming DOS? So a lot of hack clubbers love what they call retro computing. With Retrospect, if you're a teenager, the framing is programming is too easy today. You want to learn what it was like back when it was harder to program. If you make a game in DOS, we will install the game on a bootable floppy disk and mail it to you. And there's some amazing things teenagers have built. But you know, this is just one person. Like one tradition at Hack Club is anytime we do anything that's 2D, instantly at Hack Club it's a 3D version of it. Like the first project for Retrospect was a 3D rasterizer in DOS, which is like crazy. But that's all. That's Hack Club. These are just a few programs of the many we run. We're a small operation. We're a small team. And really, like, all of us have had our lives like very positively changed by open source and by coding and by making things and like finding this path. You know, the thing for me about software is like it's high agency. As a young person, it's hard. Like you're asking yourself the why questions. Who am I? What is this world I live in? What is my relationship with it? And it's very challenging to find a good source of support where you can feel like you can take control over your own life. And one of the beautiful things about code, and specifically open source, is that you don't need to ask anyone for permission. It's a form of self-expression that you can learn that will give you agency and control over your own life. And it's something that you can take control of today. Like you don't need, if you probably have a computer at home, you don't need a lot of resources, and it's something that's highly social you can do with other people now. One of the reasons why we're excited to be here is that many of you are the heroes of hack clubbers. Like you work on open source software that they use every day. An ask to all of you is that if you make a piece of open source software or you know someone who does, please help connect them with us. We run Zoom sessions with Hack Clubbers where they talk with people that make software that they use. They're really inspiring. It's an hour-long commitment. One of the biggest challenges Hack Clubbers run into is finding venues for their events. If you happen to work at a company that has an office they could use as a venue, we have Hack Clubbers in 119 countries trying to organize hackathons right now. If you know anyone that would care about this, wants to support the work, we're all donation funded, please help us get connected. But most importantly, the #1 piece of feedback we get when we ask Hack Clubbers is that they wish they knew about Hack Club earlier. Many teenagers find out about us when they're 17, and they only have one more year before they're not eligible anymore, because we're only 13 to 18. So any teenagers you know in your life, please help share Hack Club with them. Please help spread the good word, and please help us reach more young folks. Thank you all so much, and thanks for having us. It's really an honor to be here with all of you.
Thank you both. Don't run away yet. Let's see if we have any questions from the audience. We have the mics to the left, to the right. I do have a question, meanwhile. How can we bring Hack Clubs to our town or to our city, to our country?
You got to tell students about it. So the way Hack Club works is it's all student-led. And what that means is that the step to bring Hack Club into your city is that a student in that city needs to come to us saying, I want to start Hack Club here. So find a 13, 14, 15, 16, 17-year-old who's interested in this stuff, help them find Hack Club, and then they can be the leader in your town or in your city.
I like this approach. But also, apparently, it's too late for me to bring Hack Club to my town. We have another question, I see.
Yeah, so all of us know that we deal with burnout all the time as adults, but I imagine when you're in, kind of a transitioning period of your life, it's even more intense. How do you kind of address that?
Sure, do you want to take that?
Sure. Mostly it's like people are burned out because of stress, because of like external pressures, etc. Hack Club makes a big effort to like puts in a big effort to make coding something that people want to do and do for fun. So people aren't pressured externally by like, I need to get a job, I need to finish this assignment. So actually, like, Hack Club is a lot of times an outlet for burnout or stress. So
makes sense. Thank you.
I guess that's my take.
I think we are running out of time. Thank you very much for the presentation. I hope we can inspire some students to bring Hack Club to their cities or towns, I would say.
Yeah, help spread the word. We have the best stickers on the planet. Come to our booth. We will definitely give you some. And really, thank you all again so much for having us. Take care.
And now it's time for our lunch break. We have exactly 1 hour. And after that, we'll talk about the journey of KDE Plasma on Ubuntu Core at 2:30. Please be on time. Don't be late. Meanwhile, visit the booths. Get your swag if you didn't already. Maybe I see some Ubuntu Summit t-shirts by the time we come back. Let's see. And enjoy the break then. Hello again. Did you enjoy your break? Did you have lunch? That's a quiet room. There we go, thank you. While I was walking from my lunch break, I saw the mascots and I was thinking, did you take a photo with one of the mascots? Yes? Well, you should take more photos. Let's post them on our social media. Let's share them to the world and let's make a good memory out of it. But not now, because now we have another talk. Don't leave the room right now. Wait for the next break. I would like to welcome Dr. Kevin Ottens, who's going to talk about the journey of KDE Plasma on Ubuntu Core. Let's give him a round of applause. Otherwise, he might not come. There we go.
Hi. So, I'm going to talk a bit about getting KDE Plasma on Ubuntu Core. The reason why I'm doing this is that we've been working on that thanks to Canonical, who is basically funding that work. And I thought that could come in useful for people at large to have an idea about where the difficulties might lie if you want to do the same thing, right? I'm doing it for one desktop. There are more desktops around, and you might want to do something similar, and then it's a good idea to know what you're walking into. I've been told that clicker to say, if you double click, that will go, but that doesn't go at all. Ah, there you go. Just have to not be gentle with it. But before that, the vanity slide, basically. So I've been working around the KDE community for the past 20 years or so. Actually, as a matter of fact, it's not on the slide, but I actually remember in 2004 talking with a couple of free software contributors who were just joining a company called No Name Yet, which would become Canonical later on. And it's actually not my first Ubuntu Summit, because the first one I attended was in 2006 in Paris. And that was a very different kind of event back then. But that's interesting to be back. After this short trip down the memory lane, nowadays I'm working for Enyoka Haute Couture, which is a service company. So we are doing development for customers. We're also doing some consulting, training, coaching, and so on. As part of that company, I'm basically a lead developer, and I'm also a trainer and a coach. And I live in Toulouse in France. Now, let's get really in the topic. So there's Ubuntu Core, right? So Ubuntu Core, the official motto, kind of, is it's a minimal, secure, and strictly confined operating system. Initially, I mean, in the communication, you could tell that it was designed for embedded systems. That's basically the immutable version of Ubuntu, secured by design, containerized. Okay, you probably know quite some of that. All the components are in snaps, even the kernel and the snap daemon, snapd itself. You get the over-the-air updates with automated rollback if needed. That's the core promise for Ubuntu Core. Then last year has been announced Ubuntu Core Desktop, which is, I chose the motto there, but you could say it's a fully containerized desktop where each component is immutable and isolated. It's a full desktop session on top of Ubuntu Core. The idea is to get the same benefits, but for user-facing graphical interfaces. And so there, the promise is to have some security, because that's harder for malicious software to change the system or spread themselves among components. Stability, because the updates cannot leave the system in an unstable state because of the rollback system. Reproducibility, because it's easier to audit and verify such a system. And manageability, because if you have the same set of snaps, you basically have no inconsistencies from system to system, and you can predict what you would have. That said, it comes from some extra challenges compared to purely embedded systems, in the way that it's harder to draw the boundaries between the desktop components, which tends to be bigger, and there's more of them, and they like to chat to each other. Now, one part you might know a bit less about, that's KDE Neon. KDE Neon, that's the latest and greatest of KDE community software. This one is built on top of the latest Ubuntu LTS release, and it's a showcase of KDE exactly as the KDE developers intended. So there's no patches, there's no changes to the default settings when you're using packages coming from KDE Neon. And the idea is to get a stable Ubuntu base, but rolling KDE software. And you get a very up-to-date KDE Plasma experience thanks to that. Which leads us to today with KDE Neon Core. KDE Neon Core, that's all the KDE Neon benefits, so you get something which is up to date, but on top of Ubuntu Core instead of Ubuntu LTS. We designed it to follow a similar architecture to Ubuntu Core Desktop itself, except that it provides a Plasma-based user experience. The idea, again, is to get the greatest and latest of KDE software. And for that, that means that as part of the project, we have to provide building blocks to help snapping packages, KDE applications, to be able to use them on Ubuntu Core. Now, to understand some of the troubles you might get if you try such an endeavor, I'm going back a bit on the basics of how the snap confinement works. What we see very often is how to make a snap, right? So you write a build recipe, that's your snapcraft.yaml, and then you use snapcraft with that, build your package. In that recipe, you get many different things. You got some metadata, the targeted base system, the apps which are actually provided in the package. That can be one, but that can be more. The interfaces needed by the package or each of the apps, and you have to say if you want it as a slot or as a plug, if you're a provider or a consumer of that interface, and the packages which are needed to build your snap, and then the actual steps to build each of the parts which end up in your snap. An extract of a recipe, so that's coming from an example on the KDE side with the ARC application, which allows basically to look into your compressed archives. And we see some of that. So we're saying the name of the app, the type of confinement we want, the base, which in that case is core 22. We also describe where the information about the app is coming from. So here we're using the adopt.info trick, which means we're reusing the data which is already in the desktop file of that application. And some things you might notice is that we have plugs which are declared on the right-hand side for you, on the right-hand side of that recipe, and the KDE Neon 6 extension. We also have slots because KDE applications like to be on the bus, right, on the session bus. So we have to declare those to be able to run and to register there. Now that bears the question of, I just briefly showed that KDE Neon extension in the recipe, and then the recipe was kind of short. And that's thanks to this extension, which behind the scene positioned plenty of things which are useful for KDE applications. So the path is positioned, the XDG underscore whatever variables are positioned, and so on, so for the environment. We also hardwire through that extension the build time and runtime dependencies on KDE frameworks and Qt, because like 95% of our applications do that. And also we enforce some common plugs because that's desktop application, so we need access to desktop, and we need access to OpenGL and Wayland and the audio playback. Most of our applications need that, so it's hardwired in the extension. Now, once you have the snap and you kickstart your application, how does it work? That's basically a three-step process. The first thing which runs before your application is actually snap confine, which will set up the execution environment. In that environment, the home will be forced. There will be a bunch of snap-specific environment variables which are forced, like the snap variable, and I will get back to that particular one. You will see it has funny consequences for us. You get a private mount namespace so that you see whatever you need to see from the system. You get a private TMP directory. You get seccomp filters so that you cannot call any system calls unchecked, and an AppArmor profile. Then snap confine hands over the control to snap exec, which is started in this new execution environment. SnapExec will read the method YAML file, which is provided with the Snap package. And in there, we'll find the actual command which needs to be run. Once it found it, it launches that actual command, and then that command is under the right environment and the right confinement constraints. If you declare your application as a daemon, then you get a systemd service generated by snapd. Okay, I'm coming back to this one because that will be important as well. And those ones, those services, they don't run the actual command directly. They go through SnapRun for that. Now, one of the questions is where are the seccomp filters and app armor profiles coming from? Basically, that's snapd, right? Snapd needs to create them when packages are installed or delete them when they are removed. And then depending on how you connect your slots and your plugs, snapd will update the profile of the application. The corollary of that is that inside of snapd, that means there's some code mapping the interface state to seccomp and app armor templates, right? So that's your way into extending what snapd does. All right, now for the KDE Neon architecture. So we have some important parts in there. Everything which is in orange on that diagram, that's basically what was already provided before we started, so that the different services that you can find for SnapCore in a system. The blue ones are the ones we've been working on. So one important one we've been working on is the Plasma Core 22 desktop. That's the base snap which provides all the binaries which will be used to run an actual KDE Plasma session. Then on top of that, we have the Plasma desktop session, which is a regular application snap. This one is really tiny. It's just a bunch of scripts to actually kickstart the process of the session, but the binaries are coming from the base snap. And then higher up, we have a few applications, and we have the KDE framework runtime, so that the KF6 snap that you see up there. There's a big difference between the way we deal with the session, at least the binary content of the session right now, and the applications. We chose different strategies for now, is that the Plasma Core 22 desktop is populated with the KDE Neon Debian packages. And as for the applications, we're actually building them from source, from the code. We have a login manager, which is not GDM in that case, because we wanted to play with the idea of having like something completely different and what people would expect from a KDE session. So we're using SDDM, and this one is provided as well by the base snap. On first boot, the SDDM config is overloaded, and it only starts the Ubuntu core desktop init unconfined. And then the SDDM config is reset to default, so that you get your first user to be able to start the session. Fun fact, SDDM doesn't have that feature, right? So we had to kind of create it from scratch. GDM does that by default, right? You have a mechanism for that in GDM. Now that you got your first user, then you need to actually boot your session, right? You actually to start that session. And then on KDE Plasma nowadays, it's completely driven by systemd. So we got services which are declared for systemd. We have a graph of dependencies between those. We have the services. We have a few targets, right? And then we want to kickstart that. So on that graph, it's very simplified. I'm lying a bit because that made the graph prettier, basically. You can ignore the gray parts. They won't play much of a role in our story. The other ones will matter more in what I will explain next. The red ones are the interesting ones for us right now. It's because that's the only ones which talk back to systemd. Okay, so the Queen Wayland will talk to systemd, KSM server will talk to systemd as well, and Start Plasma, which is not strictly a systemd service, but that's actually the one talking to systemd to say, I want that target, make it happen. Talks also to systemd just for that, right? It needs to be able to say, okay, here is my target, now do your magic. That's the only thing it does. But Queen Wayland and KSM Server, they are doing other things. They are not asking for more targets or anything, but they are the activation environment which will be used by all the applications which are started by systemd after that. They manipulate that. It's important, for instance, for Queen Wayland because, as the name implies, you get a Wayland compositor, and your applications need to know where is the socket to talk to Wayland, right? So it needs to pass that somehow, and it does that through the activation environment. So we set out to get started, make our first snaps, and to have further the session unconfined. Should be easy, right, to have it unconfined. It's just distributed as a snap, but we don't confine anything, we don't force anything with AppArmor. We declared 2 services in there, 1 application and 1 service in there. So we declared Start Plasma, we declared the XDG Desktop Portal KDE, so the implementation of KDE for the Desktop Portal protocol. And we fire that up, we expect things to work nicely, and then we get a very nice black screen. So we had to investigate that. Turned out that we had a deadlock between Queen Wayland and XDG Desktop Portal KDE, which was very unexpected because there's no other system where that happens. And because there was this deadlock, Queen Wayland is stuck, nothing can proceed. The compositor being stuck, you get nothing on screen, and that's why you get a black screen. But then why the deadlock in the first place? Do you remember the snap environment variable I mentioned just before, that snap confined positions? Do you remember that Start Plasma manipulates the systemd activation environment? And it does it in a very brutal way, which is I take all of my environment and then I push it all into the activation environment, okay? Which means that anything which is started after that gets the same snap, snap underscore, and so on variables. Turns out that when you do this, all our applications are based on Qt, and there's a class which is named QGUI application, which controls quite a lot of things from what happens inside of Qt. And there's something very smart that they are doing, which is checking for the snap environment variable, and if it's there, they say, OK, I'm confined, so the user doesn't want me to do my in-process file dialog, say, right? And instead, I will go through the portal. But if you're Queen Wayland, that means that you have a QGUI application. Because of that QGUI application and because of the snap variable which is positioned, you end up loading the plugin to go through the desktop portal, and then you want to talk to the desktop portal who wants to talk to you. So that's a first big loop there where that cannot proceed. But if you look closely, you also realize that at the same time, XDG Desktop Portal KDE has also a QGUI application which loads the same plugin and tries to talk to itself. Yeah, so that could not work. So we changed that, right, obviously. There are several ways to reduce the issue or to avoid it completely. One thing, we control what's in the base snap, right? So we could say, OK, you know that plugin? We just shoot it out, or remove it from the base snap and gone. Now, the thing, it's not completely perfect because QGUI application does some less drastic, but some other adjustments as it goes, right, in its behavior, so it wasn't perfect. Or you can add your own service, systemd service, which tries to be started before everyone else, but just after Start Plasma, right? Clean up the environment before everyone is there, and then you should be fine, right, because you cleaned up the activation environment. It's kind of ugly, right? But that works. It's what we've been using for a long while, waiting for the patch to Start Plasma to actually be accepted, which is obviously the right solution that you want to apply. And this way, we get an unconfined desktop in all its glory, right? We could log in, log out, and so on. That was fine. But we knew that as soon as we would want to start the confinement again, right, that wouldn't work because we need to talk to systemd, right, to say, fire up that target. Or we need to talk to systemd to say, yeah, change the activation environment for me. And obviously, by default, snapd forbids all of this. So when the security is too tight, what do? You take the power drill out and you start poking holes, right? So we submitted, that's basically what we did. We submitted a new systemd user control interface, which is admittedly risky because anyone who gets that can talk to systemd directly and start whatever service is in the system, and that could be unconfined. But yeah, through that step, we managed to actually get an AppArmor profile, which allowed us to actually start things. But the fact that there's a risk ingrained into that interface, that means that that particular patch didn't land yet. That actually will be something else which will land at some point. And that's still in discussion due to this. But yeah, so with that little trick we're playing here, we get the confined session, and so we managed to get something which boots. Now, when we did that, we started to get the thing confined. We found some more errors, right? Some more problems showing up with what the services and applications inside of the session were trying to do. So we had to improve some existing interfaces from snapd, right? Unlike the systemd user control one. So obviously we touched the desktop, uPower observe, system observe, shut down. One of the reasons behind this, because that can come as a surprise, because well, there's Ubuntu Core desktop, right? They're already doing this. Why didn't they get into that? Yes, both are desktops, right? But they have their own code, they have their own lives. Yes, GNOME and KDE Plasma, they are using similar interfaces, but sometimes not exactly the same part of the dbus interface or things like that. Also, the Qt code tends to introspect more aggressively on the bus than GTK applications, so that would show up in the warnings. We wanted just to silence those. Once we did that, declared all the dbus services we needed as well, we got confined session, and then it was working. Almost. Because the thing is, if you remember, I said we declared Start Plasma as an application, we declared the portal as a service, but that means that all the other processes in the sessions are actually not confined, right? Because those, we're talking to systemd, right? And it said, do your magic with that target, but the service files, they're still there. So it still starts everything else unconfined, right? Which you can actually check. There's a tool provided with systemd, which is systemd CGLS, which allows you to look at these kind of things. And you can see in the control groups that, yeah, clearly those processes are not where they should be. And we would have those files bypassing everything. So we wanted to declare all the other services inside of the Snapcraft YAML as well. We could do that. That's what we did. But then you end up in a bit of a conundrum because the targets, they expect certain names for the services, but snapd generates services under other names, right? So we ended up having to ship aliases, predicting how the names would be, and that's what we used to be able to get there. Once we did that, we could have all the services confined. We found more interfaces to adjust due to this, but there. We got everything confined, each process even having its own specific confinement rules, right? So because we have everything really as services and not, we're not with a desktop where you would have like one script which starts everything and then everything would have the same confinement. Here we can actually pick and choose, say this one sees that part but not this one, right? Even though they're in the same session. Now you got your session, you want to launch apps, right? Because if I have my session, and then I can list the applications and I can start them, it's kind of pointless. So there's a pending snapd feature for this. We didn't build it, that was already there because it's been needed for Ubuntu Core desktop itself. And with that feature, you get snapd to generate desktop files for the declared applications. And then it goes through a snap routine and it talks to a privileged dbus interface for that. And you're only allowed if you use the desktop launch plug, which obviously we declared for use. Now, there's a fun fact about that one. It's that if, like we were doing before, you push the snap variable to the activation environment, then everything breaks loose. And you basically, the applications don't start, you get into a kind of infinite loop. And if you try to boot the session as something is plugged on your session, then you get a black screen again. You have to love black screens. Now for the apps, we're providing building blocks for them. So we're providing several content snaps. We have an SDK snap for just Qt, SDK snap for the KDE frameworks, which are used by the applications. From those two, we derive a runtime snap, which has both Qt and the KDE frameworks, and that's the one which our applications are using. So the applications are built on the SDKs, but then at runtime, they use the runtime bot. And again, those are built from source. Now, for the purpose of the project, we're covering only a few set of applications, and then we have the community picking up and packaging more applications. But we are focusing on a few, which are so GwenView, which is an image viewer, Ocular, which is document viewer, CaveWrite, which is just simple editor, Eliza playing music, and Discover to be able to install applications, right? The reasons why we pick those 5 is that through them, you're covering a good set of the overall features the other applications might need. And then we can validate that a user can view documents, can edit them, can listen to music, and it's actually playing, these kind of things, and also can install further applications. So that's good blueprints. With just those 5, we're providing to the rest of the community good blueprints for more application packaging. The good news is, most of them, we didn't have much to do, right? With the extension, which the Snapcraft extension that I mentioned before, we got everything pre-wired fairly easily, and most of them didn't require their code to be changed. The only exception to that was Discover, the one which needs to install all their applications, because obviously it has more proximity with Snapd, and due to that, you need to have a bit better integration. So we did a few patches to Discover itself. It was not handling properly, for instance, when you disable the auto-updates for a particular snap. It would be obvious to that. And there was also a problem with the way it was running a snap which has been installed, because you can install something and say, yeah, please run it for me now. And that was hard-coded to go through snap run, which is exactly the thing you're not allowed to do from within your confinement. That was working because nobody tested it confined this way, right? Everyone tested it outside from the host session. For the applications, we're going one step further, that we are wanting to validate them through GUI tests. That's still under construction because there's a lot of work to do around this. But the goal is that when an application, what we want to get to is when an application changes on the KDE repositories, then it will kickstart building the snap, and then the snap is actually validated by GUI tests, right? So we already have GUI tests for some applications, but if we go all that way, that means that it runs twice. One without confinement and one with the confinement, which allows us, for instance, to test, I'm not going through the desktop portal, and now I'm going through the desktop portal, right? That's 2 very different situations. For that, we're using the Appium setup, which is used in KDE, which is ramping up as I speak. And there's just a few guinea pig when we started. So we've been writing tests for the applications that we package. It goes through AT-SPI, so the accessibility layer for that. And so we found actually issues with the AT-SPI implementation in some bits. So that's actually good, because by doing this, we actually improve the accessibility of what's produced by the KDE community. And we also found issues in the test driver itself, so that helps to fix the test infrastructure for the community. Of course, those tests, as I mentioned, we want to run them on the continuous integration and to go toward continuous deployment for the snaps. And so that's basically what we built. We didn't quite expect to have to build the CI from scratch, because we thought that the KDE community already had some things. Turned out that they pulled the plug out of that one 2 weeks before we started. That was kind of a bummer. But they had very good reasons for that needed to be redone. So we swallowed that one, and we're like, OK, we're going to do it. And so what we're providing is we're building, so we're making the YAML files for the applications, the base snap, the session snap, and so on. And the CI then build the snaps from that. In the case of the application snaps, so that's, as I mentioned, work in progress, but we're getting to a point where we want the application snaps to go through the GUI test, and only if they validate those, then they get into the snap store. For the other ones, they are going in the Snap Store. And right now, so that's one of the other adjustments we want to do. They all go to latest edge. We are right now working into, depending on which branch it's coming from, that goes to edge or to beta or candidate, and then you can validate to Sable later. You also have, so that's one part. The other part is building the models, right? To have a whole system and to have an image that you can actually boot. So for that, we have model assertions, which gets signed with KDE sysadmin keys. And those signed model assertions, we get them through Ubuntu image that produces a system image. And with that system image, we slap an installer on top, make an ISO, and those are pushed to the KDE CDN. Now, the thing is, you will notice that on that graph, and hopefully you can see the color properly, some of those arrows are red. That's the steps, and you see that's quite a few of the steps, like almost all of the steps. That's the steps where it doesn't actually play very, very well with the KDE CI infrastructure, because the KDE CI infrastructure is all based on rootless containers. And all those red arrows here, that's the steps which don't play well with rootless containers because you need the root in some way for some of the operations. And that's particularly the case for Ubuntu image, for instance. That's the case also for building the ISO, where you need to do mount loops or things like that. You need to have the root at some point. So the KDE sysadmins have been very nice with us for that. They are actually providing a VM because they have that we can configure to deal with all those steps. They have a plan from moving from rootless containers to ephemeral VMs. And so what we are doing is actually kind of a blueprint of what's to come for the KDE CI. So again, that benefits the community. Now, for the challenges, where, as I mentioned, we had some problems we encountered, right? So along the ways, we had apps with glitches, and then we had various black screens for different reasons, right? Or the apps not starting. And so the question is, how do we assemble those? How do we tackle those, right? There's basically two cases, in my opinion. You have a problem with your Snap application. You check it also outside of Ubuntu core, okay? If you have the problem as well, that's a strong indication that the problem is with the application. And in that case, you have plenty of options available, okay? There's Snappy Debug that many people use. We process the logs, see the AppArmor violations, propose you fixes. Nice. You can, if that's not enough, you can use snap run shell, and then you can introspect the environment as seen by the process, right, from a shell. If that's still not enough, you can snap run strace, and then you can monitor all the system calls done by the applications and their failures. Or if nothing is enough for you, then you can turn to snap run GDB server, and then you basically attach to the process with GDB, and you really need to have debug info here to help. But yeah, you can introspect pretty much everything. That's the easy case in a way, right? Because if that's an application having a problem only in the session that we're providing for Ubuntu Core, for instance, or if that's with the session itself, like some of the problems I described, then what are your options? Well, you can turn to Snappy Debug. It still works somewhat. I mean, it will process the violations properly and so on, but then you should not trust the fixes it proposes, right? Because the fixes it proposes are all written from the perspective of an application packager. But now you're on the other side of the interface, right? So very often it will actually give you the advice in reverse or completely wrong advices. So still useful, but yeah, just be careful that you're not packaging application at that point. Apart from that, you're pretty much it, right? Because the snap run tricks I mentioned before, when you have plenty of processes in interaction, that's not going to cut it. So you need to go straight to lower levels. And then you can, things we've been doing have been to modify the Plasma desktop session startup scripts so that we change the environment before everything starts. And that allows us to enable all the logging we want in Qt, KDE frameworks everywhere, some extra dbus logging, and also to tell the user session systemd, okay, put yourself in debug mode and tell me everything you're doing. Then you get all the logs you can ever dream for, because you get actually megs of logs per second, but you get a very clear picture of what's going on. If that's not enough, one thing we did is actually modifying the base snap itself. We have been providing in the repository a small script that we call enable developer access, which does a few shady things that you clearly don't want in production, but which help. For instance, it opened the root access without passwords straight from the first serial port. So you fire up your VM with the image, get to the serial port, and then you can introspect everything you want. It also installs some extra developer tools for AppArmor, PushGDB, and some tools dbus related. And from there, you can basically log in and attach, debug anything. As you deal with problems, you have to really remember, yeah, it's all immutable, right? That's the whole point when you're making your image. It is immutable. That means you have to be strategic in what you prioritize to try when you're trying to debug a problem, right? And you want to validate your theory. Because the feedback loop is not the same depending on what you're looking at. If you need to change an application snap, yeah, the feedback loop is kind of quick, right? You just roll the new snap, install that into your running VM, and then you can see the effect. The Plasma desktop session snap, that's still fine because at the end of the day, it's kind of an application snap, right? You just have to log out first, then you change it, log in, and then you see your impact directly. Snapd is surprisingly nice in that regard as well. Very often, you can actually just upgrade it, right, and try a patch, see how it impacts. There are a few cases where you have to reboot the VM, but that's it. Now, if you need to try something inside of the base snap, then you're in for a long time, right? Because just building it takes a while, and then you need to redo the image, and then you need to boot that, and the first boot takes a bit of time. So the feedback loop on this one is fairly long. All right, so further work coming. So as you've seen from the slide, that was all Core 22. We have the switch to Core 24, which is in the works. We've been waiting for KDE Neon to have a Noble Numbat snapshot because that actually helps us, right? It's not a big architectural impact at the end of the day. I mean, that doesn't invalidate the architecture. We're just changing the base. But that means that even though the architecture doesn't change, you have plenty of components changing at the same time. And then if something breaks, you have to figure out which one it's coming from. So lots of things could go wrong still. It should bring benefits. For instance, the first user provisioning is actually different on Core 24, and we expect benefits from that. Now, the other thing which is coming is a change in architecture. That architecture we used so far is actually, that's a good start, right? That helps to see all the problems we had with the confinement. We confined progressively and so on. But that's not perfect because you cannot easily compose between having a GNOME desktop and a KDE desktop, for instance, these kind of things. So we need to slice things up a bit better. And so we are in the work of decoupling everything from the base snap. So the idea is that we will build on top of the Core 24 base snap. That's what you would get in your image. And in that sense, that would be a standard one. But then it will come with the desktop session snap, which is, again, an application snap. But instead of finding its binaries inside of the base, it will find them in a content snap instead. Right? That's basically the thing we're trying to do, and this way we will decouple. And that content snap, we are figuring, because that will change the prefix in which you find the binaries, we cannot really reuse the dead packages directly anymore, so we will have to switch to actually building everything. Which means that we'll then build on top of the runtime that we already made for the application. So that work is definitely not lost for the session. Lessons learned during that thing, and I will leave you with that, is packaging KDE applications for Snap, it's actually easy. I will be honest there. As I mentioned earlier, right, I've been around free software and so on for a very long time. One thing I really hate is packaging. I really don't like it. But definitely for snaps, it's a very different story. It's definitely easier. The documentation is good. The Snapcraft extension that we have definitely helps. So that's actually good things. The Ubuntu core desktop architecture, as you see, we are trying to stick with it, and we are changing along as the upstream, in that case, is changing. So obviously, it has sharp edges, but for now, right, it's getting better, it's maturing. But as it matures, obviously, the documentation needs to catch up, and the tools might have some sharper edges, but that's, in my opinion, temporary. The fact that we confined progressively, that actually made things easier. I cannot imagine the world of pain we would have had if we didn't have that power drill, which I mentioned, which allowed us to start just tiny bits, unconfined, and then confined as we go. If we had to go from everything is unconfined to everything is confined, that would have been much harder. So I'm actually happy we did that. And one thing I didn't mention a lot before, but the Snap Store controls kind of everything. And I was talking about the fact that we have an interface which is not in upstream Snapd. So for a long while, we couldn't publish. So now we can actually do that, but there's been quite some time before we could publish the desktop session snap to be able to use it, which makes the experience for people who want to contribute or for developers a bit harder. And one of the things which I was very pleased with was how we have good tooling to debug systemd-related issues nowadays, which was not necessarily the case years before. If you want to contribute, everything is in public on the KDE infrastructure. So we have the Ubuntu core project where we have all the scripts and so on to build the images. And then we have a snap packaging group where the base snap, the session snap, and so on are developed. We're also producing documentation to help with that. So there's a how-to for snapping applications. And there's some architectural guidelines and advices on how to contribute to the whole thing integrated on the Neon/core page there. I will be around. You can come and talk to me, obviously, if you're interested in what we are doing with that particular project. I'm taking credit of everything, kind of, because I'm the one talking here. But obviously, it's an effort of several people. So there's my team at Enyoka Haute Couture, which has been instrumental in doing this. We've been also working with a couple of contractors. So Scarlett Moore, which some of you might know because she's been doing quite a lot of things around Kubuntu around the years, and she's very enthusiastic snap packager. Carlos Dimain, who is another contributor, more on the KDE Neon side. Fun fact, I have one in the US, the other one in Australia, so for the calls, it's grand. Well, actually, it's easy for me. I'm sitting in the middle. That just sucks for them, so yeah. And of course, we got a few KDE contributors who provided help on their spare time, though, for some of the blockers, mulling ideas over and so on. And especially Ben Cooksley, who is like the person responsible for the KDE sysadmin team. And I'm really glad that he's not hating me yet with everything we've been very annoying on the CI side. So. Thank you for your attention, and if you have any questions, feel free to shoot them.
May?
Please.
This was really interesting coming from like my perspective as a Snapd developer to see how people consume all the things we're building. My question is, do you know or have you tried using SnapTry for making fast-paced iterative changes on an environment where you already have everything set up, but you just need to make this one change in this otherwise immutable snap? With SnapTry, it's actually quite easier.
Okay. No, because I was not really aware of it. So, okay.
All right.
If we can hook up after and you show me, I would be interested.
Okay, thanks.
So there was some slides you added about contribution by the community. And there was also previously in initial slides you mentioned about launching apps in a confined scenario.
Yeah.
So what's the thing currently used or the API that's used to launch the snaps in this scenario? Can you just
Right, so so that's something you get if you have the desktop launch plug and it's actually connected.
Yes.
But that desktop launch plug, as I mentioned, that's a Snapd feature which is coming, which is not in Snapd proper right now.
Exactly. That's not coming. That is there. It's been long because like.
It's been landed since I wrote that and now.
No. So there is an upcoming feature that it allows us to pass parameters when we are launching the apps, but we can launch the app using the desktop launch plug already. And exactly that's where my second question is regarding community. There was because basically this was my GSOC project this year to fix the Snap backend of Discover. But for some reason, like initially there was, I don't remember his name, but there was some guy who came up fixing the launching of apps in Discover, snaps, launching the snaps in Discover, and he came up with something like snap routine thing. And then I saw it and I thought, no, it's not the perfect way to do it, rather using desktop launch, and I created a PMR with using the io.privileged launcher debus. But for some reason, it was not merged, and that guy's one got merged, and mine was closed. Like mine is stale right now, and that I haven't seen him anymore contributing in Discover. And like later on was like most of the Snap backend issues that were in Discover now are fixed by me. But maybe you can look after that, like the community thing that I think this is like there are more closed door things, and I think you can be more open with the community about it, because like I have worked on a lot of things, like also the Snap KCM that I created, that can be helpful for the use of snaps for managing the permissions. But I think that thing can be improved regarding the community contribution in the snaps.
So for that particular one, the thing is you have two approaches, right? You can either couple to the debus interface, or you can go through the snap routine. Turns out that there has been one which has been chosen. We are doing it in public, right? It's not like we've been hiding that. So yeah,
not
but
really
then,
hiding, but rather.
No, but then at the end of the day, that the maintainer of Discover decision, right?
No, it's not like that. It's
okay,
like
sure.
I talked with him. Like he told me that it was some kind of like, I don't want to say that word, but some kind of pressure.
I think we're running out of time.
Yeah, it's
maybe
fine.
we can continue this after. I guess, Kevin, you're going to be around as well.
Sure.
That sounds great. And also, thank you. It's been interesting to hear the journey, I would say. And let's give a round of applause to Kevin.
Can you do that?
Let's see. We're going to talk now about the tech stack and the challenges that an organization has when it grows. So let's welcome Pablo Ruiz Musquiz, who's going to talk about the Penpot Tech Pivot. That's a quiet room. What's happening? Where are the applauses? There we go.
Thank you. Thank you. Okay. Let's talk tech pivots, refactoring, bad decisions, or not. We'll see. So, okay. So let me introduce myself, and I'm Pablo Ruiz Musquiz. I'm the CEO at Penpot. And last year I was giving a talk in Riga, Ubuntu Summit at Riga, and I wanted to share how particular the team that was building Penpot was and still is. You know, I share this unique ratio between designers and developers, that we have one designer per 2 developers, which is a unique ratio that you don't typically see. I also discuss how important it is to bring open source to the design process. And my point last year was how much was at stake for the developer world in terms of the open source design and prototyping challenge. Because we do believe that, I mean, we do believe that Penpot could become one of the most important open source projects of the decade. That's how we see it, and that is what motivates us. And I know where I am. I'm here at the Ubuntu Summit, so, and yet we feel comfortable saying something like this. Now, it's a year later, and a lot has happened in the design and prototyping world. We can discuss, acquisitions that failed, discontinued software, generative AI, all that stuff, right? But one thing that happened to us was that we continued to experience massive growth, whether it was new users using the SaaS or self-host, or whether it was, or the way people were using Penpot. And that became unsustainable for us. So it is something that you can enjoy, but only for a while, I guess, because the way people were using Penpot made some decisions, technical decisions that we made in the past, feel awkward, the least. So, so that's the intro, but let me tell you, for those of you who don't know what Penpot is, and this is just a screenshot. Penpot is a web-based design and prototyping tool. It's meant for anyone that is building user interfaces to enjoy that process. So, and it's meant for both designers and developers. That is one thing that we feel very motivated about, to bring both worlds together and collaborate instead of the traditional silo world where we have this waterfall model. So that is Penpot. It's open source. We use the MPL 2.0 license, which is very web native. And even though the primary use is user interfaces of all types, including terminals and whatnot, it does excel at web user interfaces. And you'll see where I'm going with that. But of course, we have a long tail of other use cases, and people keep surprising us with how they use and abuse Penpot every single day. It's real-time collaboration, so it's meant for teams. So it's really something that feels very native to today's online world. What it's not is an illustration app or a graphic design app. It is not. It can be used like that, but it's not like a tool like Inkscape, for instance, in that sense, if you know what I mean. So you would typically use them in tandem, like we do. So you get Inkscape for certain parts of the process, and then Penpot for other parts of the process. So speaking of Inkscape and vector graphics, I need to discuss SVG here. And this is where I'm getting into the business of the talk. Because when we started Penpot a few years ago, we made two decisions. To use the browser's DOM as an infinite canvas to draw whatever we wanted for that real-time collaboration process, and also to stick to SVG as the native format for Penpot. Those were the two decisions. And we did that because we've been in open source for 2.5 decades, some of us, and we understand the value and importance to adhere to open standards and to go, on top of giant shoulders, and that for us meant browsers, all of that. But it was also a very practical decision too, because we could offload the rendering bit to the browser. We would just output SVG, and the browser would do that heavy lifting for us. And that meant that we could focus on other innovation that was not headabout. I just referred to the fact that we are uniting designers and developers. We are not going after what other closed source design tools are doing. We want to broaden the audience for the design tools. So it was great for us that we could just forget about the rendering bit and focus on new ways of understanding the design process and involving developers at the same time. So, and I'm saying this because building a design and prototyping tool that is web-based, it is a very tough project. It is one of the toughest projects because it has all the challenges. You have the precision, you have the performance, you have the reliability, you have the real-time connection, you have conflicts that you have to resolve, and also it is a productivity tool, so it needs to give you freedom to create. We cannot bias your process. We need you to feel like, yeah, it's a tool, and there's options, and yet I can use them in any way I want. So it also is challenging in terms of how you build a builder's tool, okay? But with these decisions that we made about the DOM and the infinite canvas and the SVG, we thought this is perfect because we've managed to do the best thing and also the right thing. So, you know, no false dichotomy. We have it all. We are very ambitious, and we were fine with this. Now, we are now quickly approaching 1 million users. It could be more because we cannot really know how many people are using Penpot self-host. I was in Amsterdam this week attending a Blender conference, and we just learned that some university in Hong Kong just produced a 20-hour course on Penpot. So this university is teaching design to students using Penpot. We didn't know about that. And so we keep learning about new pockets of usage around the world. But let's just say it's 1 million users, split between SaaS and self-host. And then what is happening is that people are starting to use Penpot in bigger projects, and bigger and bigger and bigger, more ambitious, because they feel they can scale up their designs. And developers are joining, and they're adding more complexity. And we have even examples where people are forking Penpot and creating verticals, creating website builders with Penpot. So we are getting a bit of the WordPress, okay, the WordPress thing about a framework and not only a CMS, right, thing to Penpot. I'm saying that this is perhaps not the great week to discuss WordPress. And then people are loving our approach to design because they are enjoying how we are favoring the declarative design instead of imperative design. And again, if anyone's interested in both paradigms and what they represent, we can discuss, during the conference. But think declarative design more about just setting up some expected outcome, but not deciding exactly how to reach to that outcome. And CSS as a language very well represents the declarative mindset. And people are loving that too. And we make sure that we use that for layout and alignment rules. So, all is good, right? All is good in Penpot world. Huge traction, people doing crazy stuff. Well, it's not. It is not because our decision a few years ago had two flaws. And it might be very obvious to you now, like it is obvious to us now, but really we wanted to make sure that we would have it all. And so, but yet, I'm here to discuss some bad news. The thing is that we bet on browsers evolution and SVG support. We decided that browsers would continue to evolve and support SVG. But they are not doing that. 2.0, the SVG 2.0, is already a year old, and the first draft dates back to 2018. So we already started creating Penpot after that. And we were hoping that they would, browsers would support SVG in a performant way, and they're not doing that. They're still using 1.1 spec from 2011. Wow. So not only we have that issue, but also the way the DOM is managing this infinite canvas with SVG is not very performant. It's struggling. And it's fine if you draw some shapes here and there and some gradients and blur, but when you are really dealing with complex user interfaces and interactive prototypes, and then that infinite canvas really becomes infinite in a way, then this simple approach just breaks down. You can see the cracks in the process. So that was, we could say, okay, let's blame the browsers. No, let's blame all the major browser makers, and we actually even, I was thinking, just knock on the door of all those and say, how can we fix this? How can you help us make sure that we stay true to open standards, but also to the browser world, and we are browser native and web honest and all that. But there was a third issue that we could not anticipate some years ago. And it was our own evolution of the tool. I just mentioned declarative design, but it gets more complex than that. The way we are building what you can build also with Penpot, this interactive UI experience, and all the different things you want to introduce to get a richer experience when building live objects as user interfaces, or why not, cannot rely on just abusing SVG all the time. SVG it was not meant for this. And we were using SVG for things SVG was not conceived for. And yeah, if you download our SVGs, you can re-import it into Inkscape or any other capable SVG tool, but there's a lot of metadata there. And we're piggybacking SVG to add logic in a way that it was starting to feel awkward. Like, for instance, multi-stroke support was just hacking our way. We were hacking our way into SVG 1.1. It just felt bad. So it was not just browsers and DOM and infinite canvas, but also our own evolution. And we could not have anticipated things, I think. I feel okay about this. Like a few years ago, we were not in this position. We could not predict the future. So we've made the decision to decouple the format, our file format, from the rendering aspect of it. So what do? We have a dilemma here. And it's a big one because it's not just a technical one, but it almost feels as an identity crisis for the team. This is, we're people that we are free and open source enthusiasts, builders, that really believe that we should have everything, like, as I said, the best thing and the right thing. And I feel great saying this in this audience, in this Ubuntu Summit. We want to adhere to open standards. We want to make sure we are interoperable. We want to be very transparent about everything and give you ownership and agency when you're using a tool like Penpot. So after a lot of consideration, we decided that, unfortunately, we could not continue to this path. And so we have made the decision, and I'm just kind of sharing this world premiere here with you, to go to Canvas. And it's good and bad in some ways, because as probably most of you know, when you are using the DOM, you access the addressable memory that you have is almost what you have for the browser and the CPU. But when you go Canvas, you have WASM memory limits. You can address 2 gigabytes, or in some cases, 4 gigabytes. That's it. So you have to be very smart about how you're going to use that addressable memory. But work is well underway. We didn't want to rush the decision. We made a lot of proof of concept. I'm going to share you a sneak peek of that in a moment. The solution is Canvas based. It's WebAssembly. We're going to use Skia as a library. and Rust as a language of choice. Part of the process was to choose between C++ and Rust. And we decided that Rust was the best option, but not because of anything inherent to the language. C++ and Rust, for us, going the WebAssembly path were equally valid, but because of the way we were seeing kind of a trend in terms of language programming, people going into one language or not the other, and we thought it would be more accessible and easy for us to also make the community participate actively if we went Rust. And we're very happy with this decision. Rust keeps getting better. And developer experience is really improving every day. So now our stack is Clojure and ClojureScript, and then Rust and JavaScript. Because for those of you who might not know, Penpot is developed in Clojure programming language, which is one of those extreme use cases where you go also for extreme solutions because of the functional paradigm that works so well with continued mathematical operations that have to be like formally perfect, right? So, but this will decouple the render engine from the Clojure part of the stack, and we think it's fine. We think it's there's no need for Clojure to own that piece. So far, so good. Do you like? I mean, is this of any interest? I don't know. I'm just. This could be kind of some having a beer and just crying a bit and things like that. But I'm here in this plenary room, and I feel fine. I feel like you're being empathetic with me here and with the rest of the team. We want to share, members of the community have expressed, we were very fearful of how the community will react to this, particularly with the SVG aspect, but a few days ago I posted this online in the community forum before I was going to come here, and we got an amazing support from the community, and particularly what they wanted is for us to share exactly how we're doing this along the way. So you should be, if anyone's interested in that transition, even if you're not interested in the old or the current mode, you might want to enjoy, to look into how we're building this rendering engine. Because we are dealing here with massive amounts of information that need to go smooth in the user experience. As I was saying, I was attending the Blender conference this week, and they have similar issues in the 3D world, right? They need to be very performant also, not just have amazing features, but make sure that it just goes fast. And so they know very well, what we are feeling right now. So this is a multi-month refactoring project. I'm happy to say that this is not a year's, worth of effort, or depending on how you measure that. This is not like expect a new release that will have the new rendering in by 2027. Not at all. This is not like that. Fortunately, we are a great software development team, and fruits of this labor should pop up in some upcoming release in the next few months. So this is good in that sense. We feel fine. So. This is, I'm going to show you just a sneak peek. It doesn't really tell you much. Well, you now have some context, so perhaps you can enjoy this 10-second clip better than other people without the context. I was allowed by Belén Albeza to share this video only if I read a disclaimer, and it's like something like, this is an non-optimized proof of concept that tells nothing of the true potential. It's like, yes, Belén, but give me the video, right? So this is really, really early stage thing. So it's not even pre-production quality. This is something hacked in a week. But it does show, and you'll see now, Penpot user interface dealing with 10K shapes. 10K shapes, it's a lot of shapes for a user interface. Like, just think of user interfaces. Why would you need 10,000 polygons there, right? Well, it gets to that point that, you know, it's not the typical user interface project, but you might eventually get to several hundreds and then several thousand, and then you get excited, and then you add more and more. And I don't know where the World Guinness record lies, but probably in the 50K or perhaps 1,000K. I mean, you can split that into different pages, right? You should do that. But for whatever reason, you might want to have really the infinite canvas, just one canvas, a monolithic canvas, and you have everything there. So we need to make sure that you can do that. So what you're going to see now is just a proof of concept, but it gives you an idea of what a 10K shape canvas looks like and how this should go. So this is a Penpot user interface, and this is 10K shapes, and this is going super smooth. And so instead of colored rectangles, you can imagine, you know, buttons and labels and whatever a user interface has. So pretty good. We're pretty excited about this. Let me see. Yeah, so let's start wrapping up. So we are very excited about this, even if it somehow makes us feel sad, because we really wanted to go the native browser, the DOM, and the SVG, or some flavor of SVG, some extended SVG, but we are excited about the approach. Probably we are excited because we know that we won't reach, at this rate of growth, we won't reach that kind of glass ceiling, that performance bottleneck, where people will say, it's amazing, Penpot is amazing, has all the tools and features that I need, but it's not super fast. And that's a feature itself. So we cannot afford to hear that. We cannot have the best tool that it's slow. So we are now excited that, okay, that's not going to be an issue. So that's wonderful. Because I don't think there's in nobody's interest to keep innovating in those stuff and yet have that performance problem, right? And the good thing is that this does not mean that we are postponing cool innovation for a design and prototyping tool like Penpot, because we first need to fix this. We can do this at the same time as other things that we're building. And we are building native design tokens support that is coming up very soon. So if you're familiar with design systems in general, or if you're familiar with libraries in general, whether it's a developer or design tokens brings those tiny encapsulated design decisions into those, with radius, or a color, or a typography decision, or a scale, whatever, and you can actually create those design tokens as functions of other design tokens. So it is really a revolution in making sure that design can scale up. And this is something developers are going to enjoy a lot, and also technical designers, because this is where bridging the gap, this is how bridging the gap looks like in a way, we believe. So design tokens is coming also in the next couple of months or so. So again, we can go separate tracks, performance, this. And then we're also building Penpot variations, which is a superior solution to other tools have, like Figma variants, things like that. We think there's better ways to do that. And advanced editing for vector graphics, including plugins also. And actually, I'm super excited to share with you that we are releasing in 2 days the plugin system for Penpot. And so that's 2.3 release. This is huge because it means that everyone can actually build on top of Penpot and create integrations. Well, we already had the API, but things within the Penpot experience. And we want to make sure that we have some encouragement for the community to think about crazy ways to add extensions, plugins to Penpot, and that's why we are releasing. We're announcing our contest, tons of prizes everywhere in the world. So if you yourself or you happen to know anyone that's into the front-end development world or technical design or even UX people, they might want to look into this. And of course, Penpot, but like the contest itself, the plugins, and we have a Penpot hub that will be released next week, and you will see the typical list of plugins there. So I think a final thought I would like to share with you, and I think the Ubuntu Summit is a perfect space where it has to resonate with you, is that this is those moments where you feel that if you make that engineering effort and challenge, you could really have a profound impact. This we see when I was saying at the beginning, very presumptuously probably, that we think Penpot is one of those key open source projects of the decade. We come from this strong belief that unless we bring open source to design and design to open source, we are not going to truly unlock the potential of software development in the world. And since this is also about collaboration across different disciplines, we just feel great about this. So by doing this tech pivot now, instead of waiting until the pain would be probably unbearable, we think we're going to elegantly navigate this and reach and get to that profound impact sooner. And by sooner, I mean 2025, like very revolutionary. And I think that's it. Thank you very much for your attention.
Thank you, Pablo. I think we have time for some questions. And I see someone already rushing to the mic, or not? No? They're rushing to the break or to take photos with the mascots. Do we have a question there? Please.
Thank you. Any technical design choice has its own pros and cons. I'm just curious, going down the road of WASM and Rust, what do you see as potential risks or concerns that you're going to have to work with?
I think we are waiting for a more deep dive into that with technical documentation, the pros and cons from the team. But I think so far, we don't see any major limitations. We don't see, I think the 2 GB limit, for instance, the addressable memory, is my primary concern. And because all the 32-bit addressable. But I think since we're coming from the DOM, we will be just moving to that memory only what we need in terms of the runtime and keeping the DOM for kind of static assets. But that, for me, that would be a challenge because tools like, for instance, Figma, which is like they have 85% of the market, they have that limitation. And they have, is one of those frequently asked questions, how do I go beyond the 2 GB limit? And the answer is create smaller projects. There's no solution for that. So I think for us, when we say scaling up design, we want to make sure that you can automate and scale up through this alliance between designers and developers, and that is only going to make designs just explode in size. So we cannot take current sizes and scales as a reference. So, but I think if we are smart and we just do a hybrid approach, then this is a superior solution. And in terms of like the language, like WebAssembly is not going anywhere, and Rust, we think that before we get into some troubles, I think we will, it's a long way before we hit some roadblocks. And it's fine if this tech pivot only lasts for 5 years or 4 years. It's fine. We're not like now making a decision for the next decade necessarily. So, but yeah, if you want to follow, our internal discussions, I invite you to join the community space, and there will be regular updates on how we see things. Thank you for the question. That was a great question.
We have another one. Other two, actually.
Okay. This might be a bit early question to ask, but while it's great to use open document formats, I think actually using something like interoperability is not just about that. So do you have any plans yet to how to be able to integrate things like Inkscape back to that workflow and what that could look like?
Great question. So two parts to my answer. One is that we continue to export SVG. So SVG is still a format that you can take and import, so that's fine. We will be using the new engine to make sure that's that, because that is very important for us. Otherwise, there's an issue there with the identity crisis. So Inkscape should feel into the process the same. It's just that we are not using that for rendering in the browser, right? It's just that's the bit that changes. But then we are going to release very soon our own file format. So it used to be non-interesting, but now suddenly it is, because we can now make a decision. It's basically a zip file with a lot of JSON files in there. And by doing that, we will very quickly get into the, okay, then I can use my storage layer as a Git repository because it's just a file. And so if you change that file, you change in the Penpot project. And I can see Inkscape and other tools interfacing, or your IDE, interfacing directly with your Git repository and changing that file. And having a weird async full duplex mode and all the benefits from a version control system right there. But in terms of SVG and Inkscape, it should remain the same. It's just an internal rendering decision that has changed. And then the file formatting is going to be amazing to have that. And it's not going to be an open standard. It's going to be just an open format, but hopefully super easy for people to hack in. Thank you.
This is the last question, I guess.
I'm very interested to hear a little bit about your experience with WASM. Call me WASM curious. And in particular, whether you see relevance applications for it outside of the browser.
Good question. I don't know. I'm not that. I'm not an expert in WASM. My background is Python and Go, so this is far beyond what I master. But if that's a question that you or other people would like to get answered, like from the team that is going to in 2024 just go full in, I can definitely discuss that. And yeah. Were you thinking of any, are you already thinking of, no, just, yeah. Not on top of my mind, but we'll see. And probably, just very quickly, the fact that people are forking Penpot to build other weird stuff might actually get WASM into also weird use cases, and then we will both read, what's going on. But yeah, great question, thank you. All right, well, thank you again very much. Thank you, Andrea.
Thank you very much, Pablo. A big round of applause for him, please. And we are about to go to our last talk before the break. We're going to talk about an operating system and how to explore it with Ubuntu Kylin. One of the beauties of Ubuntu Summit, I think, is that we have speakers from all over the world. And our next speakers came a long way, so let's welcome Jianfeng Li and Wanzu Wang. That's a quiet room again. There we go, there we go.
Okay, good afternoon, everybody. It's a pleasure to be here in the Hague. And my name is Wang Wenzhu, and I'm an associate researcher at the Hague Lab of ITAI in China. I'm also a Ubuntu Kylin release team member, having been involved with the community for over 10 years. Additionally, I serve on the technical committee of the Open Kylin community. Today, my colleague Jianfeng and I are going to share our exploration of AI operating system in the Ubuntu KDE. First, allow me a moment to introduce the Ubuntu KDE. Ubuntu KDE is one of the official flavors of Ubuntu, first launched with version 13.04. The Ubuntu KDE community is supported and led by the CCN Joint Lab, which includes SCIP, Canonical, and NUDT. As of now, Ubuntu KDE has been in development for over 12 years, from version 13.04 to 24.10, encompassing more than 27 releases. It has contributed to the promotion of open source in China, serving as a Linux desktop operating system specifically designed for the needs of Chinese users. Simultaneously, Ubuntu KDE has gained international recognition by delivering an exceptional operating system for users around the world. To date, Ubuntu KDE has been downloaded over 40 million times and has more than 1,750 contributors. So UKUI is a desktop environment developed by the KDE team and is included by default in the Ubuntu KDE open source system. For more information, you can visit the official website at www.uqi.org. We warmly welcome you to explore it. UQI has indeed evolved over the past 12 years, which with its 4 major versions, UQI has aimed to provide a user-friendly interface that caters to Chinese users while maintaining compatibility with the Ubuntu ecosystem. Each version has introduced the enhancements in usability, aesthetics, and performance, making it a robust choice for users looking for a lightweight and intuitive desktop experience. UQI 1.0 was released in 2013, built on Unit 7 with a modified layout, themes, and icons. UQI 2.0, launched in 2017, is based on Mate and offers a Windows-like style. UQI 3.0 was released in 2020, featuring a self-designed environment developed according to its own interaction design principles. So now, UQI 4.0 is the latest big version released in 2023 and embraces a path to lightweight design that emphasizes vision focus and effortless interaction. This lightweight design and approach aims to improve performance and accessibility, ensuring that both new and experienced users can interact with the system easily and effectively. After a brief introduction to Ubuntu KDE and UQI, I would like to discuss our new work on the development of an AI operating system. So we are entering a new era of AI characterized by capabilities that were once unimaginable. Today, AI can understand the spoken language, answer complex questions, and inspire creativity for writing articles. Furthermore, it can generate images based on our description, create scenes and videos, and assist in writing code. So this transformation is driven by advanced AI models such as ChatGPT, Gemini, Llama, and Llama 2, and so on. So when interacting with an operating system, we typically use a keyboard and a mouse. However, AI is revolutionizing how users interact with their operating system. Instead of relying on traditional input methods, we can simply tell our OS what we want to do. Then the OS can execute tasks directly based on our questions. For instance, through the natural language processing, we can develop voice assistants like Siri and Cortana, allowing users to interact with the OS using natural language. This enables hand-free task execution, question answering, and application control. Additionally, AI facilitates personalization by analyzing their behavior and preference to tailor the OS experience. This includes personalized recommendations for apps, settings, and content. So AI-powered operating system also offer other interactive features such as intelligent search, prediction, analytics, and enhanced user interfaces. Currently, we have AI assistants integrated into various operating systems like Copilot in Windows, App Intelligence in macOS and iOS, and the Gemini in Android. These AI OS agents enhance our convenience when using an operating system and deliver an exciting user experience. So in light of these advancements, we have developed an OS system that integrates with UKUI, designed to work with Ubuntu KDE and other Linux-based operating systems. So next, let me introduce the framework of Ubuntu KDE AI OS. The current AI application deeply coupled with models, inference frameworks, and even chips, forming a chimney-like situation. Even the same model and application require multi-adaptation due to the use of different AI technology stacks and AI computing environments, resulting in severe fragmentation and restricting the development of the AI ecosystem. So in the era of big models, there is a significant consumption of computing and memory resources, making it difficult to run multiple models simultaneously. Each application contains its own model, leading to severe resource shortage and conflict, making it difficult to run multiple models efficiently. So we have developed the KDE AI subsystem. This subsystem comprises several key components: the unified reasoning framework, AI basic services, AI runtime, and the AI SDK. By employing a unified reasoning framework, we can decouple models from hardware, effectively abstracting the differences in underlying hardware computing power. This allows for greater flexibility and efficiency in deploying AI applications. The AI basic services provide foundational capabilities such as a vector database and document processing, streamlining the development process for AI application and enhancing overall productivity. The AI runtime facilitates hybrid scheduling of cloud and edge models, adapting to different operating environments. This ensures optimal performance and resource allocation based on the special requirements of each application. The AI SDK enables the decoupling of applications and models, allowing applications to flexible upon various AI models as needed. This modular approach enhances compatibility and reduces the need for extensive adaptations. So next, RISC-V is an open source instruction set architecture and notable for its flexibility due to its modularity and customization. Having worked with RISC-V for about 3 years, I would like to discuss the topic of AI on RISC-V, which is also a part of our efforts on AI OS. RISC-V already includes a vector instruction set designed for AI computing, and there are ongoing development of a matrix instruction set to further enhance its capabilities. Additionally, RISC-V offers several key features that make it well suited for AI applications, including many call for parallel computing, direct memory access, and accelerator integration SoC. So by leveraging these features, RISC-V is poised to play a role in the evolution of AI computing, providing a platform for developing and deploying AI applications. The software ecosystem of AI on RISC-V is evolving rapidly. Numerous operator libraries are now able to utilize the AI computing capabilities of RISC-V's vector and matrix instruction sets. Libraries such as OpenBLAS, XNPEG, and Triton are leading the way in this development. Additionally, major inference framework like TensorFlow, PyTorch, and ONNX have successfully been ported to RISC-V, enabling seamless integration with existing AI workflows. A variety of AI models include YOLO, GEMMA, and Llama can also run efficiently on RISC-V platforms. So with these advancements, foundational AI software ecosystem has been established on RISC-V, allowing us to develop innovation AI applications. So as we anticipate the emergence of more powerful RISC-V devices in the coming years, we look forward to expanding our capabilities in AI development. So okay, now, I would like to hand over to my colleague Jianfeng, who will introduce the exciting work being done on AIOS in Ubuntu KDE. Please welcome.
And thanks for Dr. Wang's wonderful introduction. Hello, everyone. I'm Jianfeng, also from the Ubuntu KDE team, and my nickname is Hansen Feng, although I'm not Hansen. Now, let me share some of the work our team is doing at the intersection of AI and the operating system. Currently, human-computer interaction on PCs primarily relies on mouse and keyboard. As AI technical advances, I believe that interactions will develop towards natural language. As Dr. Wang mentioned, many operating systems now come with built-in AI assistant, and we are also working in this area. The AI assistant will act as a central hub, including invoking system comments, answering knowledgeable queries, and facilitating inter-application collaboration. With so many system functions, finding less common settings can be time-consuming. By giving comments like font settings to the AI assistant, users can quickly access the right panel, making things more convenient and easy to learn. Currently, our AI assistants support over 200 basic comments, such as opening application, device control, media control. It also offers common generative AI functions, like compiling weekly and imaging processing. You can open the AI assistant by clicking the icon on the right panel, and it will pop up a chat window on the right side of your screen. You can interact with it via text or voice and configure the model in the settings. It supports switching between local and cloud models. Local models are being downloaded by our model management tool, and you can also configure your own models. However, local models support few features and have inferior performance compared to cloud models. You can choose one according to your needs. Beyond the basic system control, our AI assistant can also interact with other applications. It can extract text from various applications using global text selection and perform tasks like translation, expansion, and partition. For processed data, Like to-do items, the assistant can directly add them to the system calendar. Let's show you by a video. No voice. This video shows how to expand a piece of writing and then translate it. In addition to the features machined, we can extend the functionality by developing plugins using our unified AI SDK. Currently, we have a plugin called Meeting Assistant. It can record everyone's speech in real time, generate a meeting summary based on participants' contributions, and save it locally on the system. In daily office tasks, we constantly handle various types of document data. By integrating AI technology, we aim to enhance data efficiency in 4 areas: data recording, data management, data retrieval, and data transfer. When browsing websites, we often save important content, but later forget specific details. The memory map tracks recent user activities on the computer, creating a timeline that lets users to view a specific moment. They can also search for images or text by using keywords. Let's watch a demonstration video. Just serve the internet randomly. And then find the timetable in my memory. This is it. Additionally, the horizontal line in the top left of the video represents the timeline. By integrating with the display servers, memory map can efficiently capture screen content. OCR technology recognizes text. With both text and images are processed to extract data features, which are then stored in a vertical database. Additionally, all memory data is encrypted and processed using local models to ensure the security of users' personal information. And currently, the file management mostly relies on traditional pace, requiring tedious manual organization. With AI integration, our data manager organizes files by content, grouping similar files in one space and dynamically updating the list. You can set keywords, creation time, file types, and other criteria for each space. And this is the screen. Most global search functions rely on keyword matching, making it hard to find files without exact names. Our global search lets users give a general description of the file's contents and enable effective content-based matching. And suppose searching for file names, text file, office file, image file, and the internet. Data transfer between applications is essential. For example, when you received a photo of reading notes from your classmate, you can use our smart clipboard to easily convert the photo into editable text. And similarly, it also supports converting text into images. And in addition, we also have done some work on imaging viewing and driving applications. We have modified the color paint by adding a text-to-image generation feature, which can automatically create colorful images based on users' text description. Just a simple input the imaging description on the right, click the Generate Now, and you can set various settings for the image, including image style and size, and so on. And with the help of the drawing tools, users can also further edit and create based on the generated images. And as for the imaging viewing tool, leveraging our local imaging processing model, we can perform tasks such as one-click background removal, converting images to black and white mode, just like the picture shows, or recognizing text within the images. And in summary, we are integrating AI into system as much as possible to enhance the user's experience. In the future, we will collaborate with more manufacturers to support the latest hardware, and we will focus on optimizing local models to provide stronger functionality while ensuring privacy. Additionally, we will develop more AI plugins. We believe that as basic computing power improves, AI will play an even more significant role in operating system. But there are still many shortcomings in the practical applications of the functions mentioned above. And for example, they only support simple commands and have limited English support. Additionally, these features have not yet been added to the Ubuntu repository. However, most of them have already been open sourced on Git and will be cyclized to the GitHub in the future. We welcome everyone to follow us for updates and to participate. If you have any question, please don't hesitate to contact me through the email or other social media, and find me at the Ubuntu community booth. Thank you very much.
Thank you both. We do not have time for questions, but I have a moment before we move towards the break. Do you remember when I asked you to take fun photos with the mascots? I sneaked out for a bit, and I took a photo. Let's see. There we are. We have half an hour break until 4:30, and I would like, by the time we come back, to start seeing some fun photos. And you can also share them with us, so maybe we can share them with the world as well. So we'll meet at 4:30. You can visit the booth meanwhile. Don't forget to take your swag as well, and ask questions to the speakers if you find them around. it almost makes it look like I'm late, but believe me, it's not my fault. It's never my fault. Are we ready for the last talk of the evening? No, what's happening? There we go, there we go. But before that, did you take a photo with a mascot? Someone stole one of my mascots. Can you even imagine that? Was it one of you? No? You're too shy. Well, before we get into our next talk, I should say that I did capture a photo with Xenial, and there's also an Ubuntu phone there. And so thank you, Terence and Sander. They also have a talk tomorrow. You should do exactly like they did. And by tomorrow morning, we should have another photo to share with another mascot, if possible. Not Xenial, not Jellyfish. Now let's go back to our next speaker. I would like to introduce Daniele Procida, who's going to talk about developers, I think. I don't know. Let's give him a warm round of applause. Here we are.
Hello, everyone. Very briefly, I'm Daniele. I work at Canonical. I'm a director of engineering. There's my curriculum vitae. I have been involved in various open source things for several years. I live in Cardiff, the UK, maar ik woon ook in Leiden, net om de hoek van hier, just up the road. My colleagues are here. I work in documentation. My colleagues are here at Canonical. They've got a booth, so do go and visit them. I'll show this at the end, this QR code. We're hiring people for hundreds of different roles, and including in documentation, so go and speak to my colleagues in the Canonical Open Documentation Academy to know more about that. I want to talk to you about God. Let's talk about God. I interviewed a candidate for a technical author a year or so ago, and I asked her, what do you enjoy about programming? And she said, when I'm programming, I'm a little god. I create a whole world, and I put it in motion. It comes alive, my own universe. And I thought, I know how you feel. And I thought, actually, I know how God felt. God, at the beginning of the time, with a new text editor window in front of him and a blinking cursor, a blank page, the moment before creation. So programmers, we know what that feels like. Because God said, let there be light, and there was light. And it's the same way in programming. We say, let such and such be the case, and then it is indeed the case. It's the case because we said it. And so it's really nice to have something in common with God. In a way, we're working in the same industry. It's just really a difference of scale, perhaps. But the most important thing is that we, like God, we both do things with words. So that's one thing that we share, this creativity as the act of creation, of bringing things into being. What we will comes into existence, comes into being through our will. And there's nowhere else we can have that. In the rest of the world, I cannot bring things into existence through my will alone. So I have the power to do all kinds of things in the world. I can move a chair, I can turn on a light, I can pour a glass of water. And I can do things in programs too. So in Python, I can break out of a loop, I can add two values, I can call a function. But merely doing things is not the same as bringing things into existence. And also in the world, I can command. I can ask my colleagues to schedule a meeting, or my children to make less noise, or the taxi driver to take me home. And in programs, I can tell Python to do things. I can tell it to print something, or initiate a connection, or return a value. So I'm doing things with words. just like God did. But even so, commanding is not the same as bringing things into existence. Because in the world, I cannot make something the case just by saying it. Saying something doesn't make it so. I can't bring things into existence. However hard I try, there won't be light. But as a programmer, I can create an object. And programming is about the will, about doing and commanding, making things so, like x equals 1, bringing things into existence. And I can do it just by using words, just like God. And that's really an amazing power. Excuse me, administration. Finn, if you can hear me, could you make the speaker notes a little bit bigger, please? Thank you. So speaking of Python, by the way, when God said, let there be light, he was using the subjunctive mood correctly. Let there be light. And unlike God, Python doesn't do that correctly. So in Python, we say x equals 1. The let x equals 1 is implicit. Really, x equals 1 is an assertion of equality. The let is implicit, as I say, but it would be much nicer if we said, let x equals 1, and then we wouldn't need to use that ugly double equal signs to assert equality. So it's a shame that Python is not as good as God in that respect. Anyway, that was an aside, really, because my point is that programming is a world of intention. We program our will in symbols to be executed by machines. Programming is the expression of our will. Fiat voluntas tua, thy will be done. Everything in programming seems to be about our intention. So I love automated testing. It's a fantastic idea. I write some code, and then I write some other code to check that the first code is doing what it's supposed to be doing. It's like you send your 12-year-old to the bakery to buy a loaf of bread, and then you send his brother after him 5 minutes later to make sure he goes and gets the right stuff. Automated testing, everything in program, our agile methodology is all about making sure that what gets done is what we actually intended to get done. It's a discipline that's entirely aligned around intention. Success in programming is the realization of intention. So that's where the meaning and value in programming lie. So programming is one of those quite a long list of things that I like doing, that I enjoy doing, but I'm not actually that good at. I would like to be a better programmer, but actually, to be honest, I'm content with what I can do. I came to it so late in life that it all seems like a gift, a bonus. So I don't feel much pain, but some other things, they do give me a little bit more pain. You know, that my skills in the kitchen or my repertoire is a little bit limited, or worse, playing the guitar. I feel a real kind of envy of people who can do that well. Or photography, and that last one really hurts, because I understand it, and I want it a lot, and I can't have it. Henri Cartier-Bresson said, your first 10,000 photographs are your worst. What he neglected to mention is that as soon as you stop, the counter resets to 0. But still, there are consolations in both of these crafts, and they're the consolations of the machinery. So I'm fascinated by programming and philosophy and photography, but also by computers and cameras, the artifacts of those arts. I love machines and doing things with them. I was going to say the word playing, but I hesitate to use that. Anyway, pleasure in the equipment adds a kind of dimension to the experience. It adds to the pleasure, and it takes away some of the sting of not being so good at it, because they are both, computing and photography, disciplines with wonderful machines that we can enjoy. And as in photography, in programming, the relationship between the practitioners and the tools is an important part of the craft. People say that, a true craftsperson is not interested in the tools. I think that's wrong. I think a true craftsperson feels something for and about those tools. But it's still only a consolation prize, especially in programming. The essential fascination in programming lies in something else. I think it lies in intention, in will. And intention is such an interesting word. It comes from Latin, to intend. It means to stretch or to reach out towards. And there are these constellations of verbs and nouns that spiral out from it. I don't know if anyone has a background in medicine. Even wounds have intentions according to how they are healing. And it's like tracing rivers and mountains and roads on a map. These words, they come out of other words, and they occupy different but related spaces in different languages, slightly different ones as well. And none of this proves anything, although you might recognize some of those patterns there that all come out from this idea of stretching. It doesn't prove anything, but it still tells us something, and it shows us something. It puts a light on something for us. And if we think about programming as intention, then that's stretching out to the world with our will, with our intention to impose ourselves on the world, or at least some part of it. And it's active. It's about doing and commanding and making things the case and making things come into being. And it's possible to become a little bit wrapped up in all of this intention, because actually I think intention is not the only kind of meaning that there is, not the only kind of value. There are other clusters of words and meanings around here that tell us different stories. There's attention, to pay attention, to attend. And it has the same origins in Latin of stretching, but this time it's of stretching to rather than stretching towards. About making contact rather than reaching towards something that you haven't attained or doesn't exist yet. So there's meaning in this, but it's not meaning of the will. It's the meaning of being there with something, attending, like you're attending now. You're giving me your attention, I hope. So where is, in programming, our attention? Or where is the attention of programmers? Or what has being a programmer done to my attention? And I love programming, and I love photography. And I don't think it matters that I'm not that good at either art. But the reason I'm not a very good programmer is not because I lack intention or will. I am full of will. I'm willful. I've got it in abundance. But I can tell you exactly why I am not a better photographer, and that's because my power of attention is weak. My power of being there, my power to be present. This is Gary Winogrand. He's the photographer who says the most to me, who fascinates me the most. A photographer does things with light instead of words, unlike a programmer or God. And when God said, "Let there be light," obviously, he was looking forward to the invention of photography in the 19th century, several billion years later. That's what I call patience. And then he had to wait another 150 years or so for Gary Winogrand to come along. Winogrand he died quite young. He was staggeringly prolific. He's estimated to have taken about 1 million photographs. If you stretched out the 35mm film, it would reach from here almost to Amsterdam. He left behind about 300,000 unedited images, several thousand rolls that were developed but not even printed, thousands just printed to contact sheets, and several thousand, not several thousand images, several thousand rolls that weren't even developed. So photographs that he himself had never even seen. Stephen Shaw, who was one of the, is another of the great photographers of our age, said that it's a bit like Beethoven. He didn't need to hear his music to know what it sounded like. And so it was with Winogrand, that he didn't need to see his pictures to know what they would look like. But actually, Winogrand said, I photograph to see what things look like photographed. He said, I photograph to see what the world looks like in photographs. He said, a photograph is what something looks like to a camera. And actually, to me, it looks like quite a lot of the people in those photographs would quite like to punch him in the face. And probably at that moment, they indeed did want to punch him in the face, because he was photographing mostly with a 28mm lens. So he was up there in people's faces, actually within punching distance. So it's really no surprise that you see so many murderous looks in those photographs. But he was actually too fast to get punched, because he would shoot an entire roll of 36 frames in the length of a short city block. Anyway, what does this say about attention? This is one of his photographs from 1964, the Texas State Fair. And there's all the noise and this busy hustle and motion and commotion. There's an animal and its handler, a prize steer. It's part of the excitement. And the animal is swinging its head back and forth, and the handler's ducking away. And in all of this movement, in this flux of 1,000 things going on at the same time, there's one instant in this unceasing collision of bodies, and the flicking tongue of the steer meets the brim of the handler's hat in a perfect symmetry. And there's this resolving of order out of disorder. And in the next instant, it would have dissolved back into disorder. And that symmetry and form and meaning was available only in that instant, for 1/120th of a second that it took to take the photograph. Only from that point of view, only along that line of sight. Maybe something never to be repeated again in the life of the universe. And somehow, Gary Winogrand was there for it. And I want to ask, how? What kind of power to be there? To be there so much with such totality of presence. I am floored, because I feel a kind of shiver when I think about that time stands still and then lasts forever. This is the power of attention, of being absolutely present. I think this is the photograph that I love best in the whole world. Also from 1964, the World's Fair in New York. I can get lost in this photograph. I play it back to myself sometimes with my eyes closed, trying to remember it and its patterns. And what I see are patterns and rhythms and repetitions and disjunctions and variations, as if it were a piece of music that I could play back to myself. And I find it almost exhaustible in its forms and the relationships and the reflections that it contains, all their combinations. Relationship after relationship in that image makes sense, and I keep finding new ones. So every direction, every angle, every bend of elbow or knee or foot and shoe, hands and eyes, and also the relationships of the bigger wholes of the bodies and those people, those 8 people all at once in their situations in the world. Everything in that one instant. And he was there, somehow, he was there ready for that instant to bring beauty and meaning and sense and order to the random formlessness of the world's motion. And again, what are we witnessing? What are we witnessing here? How is this even possible? This is a superhuman feat of attention. And that's good. I will never do that. And that's okay. I'm allowed not to be a superhuman, so it lets me off the hook in that respect with photography. But I do recognize and understand something of that power and what it does. And just occasionally, I've had the smallest glimpse of it myself. This is the best photograph I ever took in August 2010. It's the one I'm proudest of. It was a time when actually I was working hard on photographing, on paying attention, on being there. This didn't happen by chance. I was ready for that moment, ready and able to resolve order and relationships out of the world's moving and shifting components and find them in that instance. It's a photograph I'm really not ashamed to show people like this. My life is immersed in intention. As a programmer, it's all about intention. My job, I'm a director of engineering, so I direct, I instruct, I make sure that my will is done across the organization in various different ways, and I seem to be very reasonably good at that so far anyway. And that's a kind of power. But I look at this picture and it reminds me that I have tasted a different kind of power, the power of attention. And I really want that so much. We can do things with words, just like God. In programming, we use symbols to express our intention that are enacted by machines. And we make things happen. We do things. We command, instruct, and direct, and we bring things into existence. And actually, not just in programming, in the world too. I mean, apart from bringing things into existence, which I already said we can't do in the world, but all those things, we can do them in the world and in programming. Programming, there's extra bonus. We can bring things into existence too. And I use words to make these things happen. Or at least I try to. And I can use words to do all kinds of things. So I can write a program to perform a task or solve a problem. And using words, I can write a threatening letter to frighten my enemies. Or I can write a love letter with a different kind of intention. But that's not the only kind of things that I can do with words in the world. So I might write a love letter not to have an effect, to express my will or as an act of intention, but to say something about something, to express something I see or feel. To say, I am here, that I have paid attention to something, and then I want or need to say it. I don't take a photograph to express my will. I take a photograph to express a different kind of meaning. I take a photograph, I do it to express my attention, not my intention, to capture something, to show something, to express my being present. It's about my being there. It's a different kind of meaning, and I think it's an equal kind of meaning. So I'm a developer. I am a programmer. I care about programming. I think about programming a lot. I might not be that great, but I do. And a letter or a story or a photograph, they can be about something. Can a program be about something? You know, programs do things, but I don't hear of programs that are about things. Is it possible? Have we missed it? Or have we just missed the opportunity? We have, you know, we all know what love songs and love poems look like. Could a love program exist? What would it look like if it did? I'm really fascinated by the relationships between programming and other crafts, photography. I love the connections that I find. Some of you, I know, work in engineering teams. We're familiar with the problem of developer exhaustion, the overworked developer. What happens when you ask more of the developer than the developer has to give? Burnout. It's familiar, it's a known problem. I'll show you a couple of pages on the subject from a book that was published even before I was born. Developer exhaustion. It's what happens when there are not enough active chemicals left in your developing solution to react with those in the film. It's an overworked developer. You have asked more of the chemical solution than it has to give. I'm a developer, and I don't have a darkroom at home, so I do my developing in the bath. And like the rest of my photography, not really very expertly, but I enjoy it so much, and I'm so thrilled with the results that I get from it. Do you know you can develop your film using a homemade solution, a homemade developing solution that's made of instant coffee, vitamin C, and sodium carbonate. And you can develop your photographic film using that. I have such fun with this. So here's a photograph that I developed using instant coffee and vitamin C powder, taken with a 50-year-old film camera that I found on eBay for about 60 euros or so that I had to repair before I could even use it. So the pleasure of photography, it's not all about the product, the photograph, the images that you result with, that are the result. And it's the same in programming. There are also these constellations of machinery, of working with the tools of the craft. That's the actual camera, the Canonette G3 QL17, which is such an enormous name for such a small camera. I don't know how they managed to fit it on it. It's from 1972, one of my very, very favorite cameras. And the affection for computers and cameras, I think, is shared by other programmers and photographers. I love cameras. I think they're beautiful machines. This is that same one. I know it really intimately. I've almost every single piece of it. I've disassembled it completely and rebuilt it. You know, not down to that level, but down to the individual parts of things like the rangefinder and the exposure mechanism and the film advance mechanism. I spent a lot of time, when I have time, inside cameras. And some of the pleasure of that comes from being able to have an effect, being able to repair these things, for example. But a lot of the pleasure comes just from being able to understand them. What I feel is that I want to know them. And we're always asking these questions, especially in the age of AI, and usually answering them in really stupid ways. But I think machines can have souls, because I think only something with a soul could have such a rich personality as that camera. When I encounter it, I feel there's something here that is worth meeting and knowing, like a person. I want to be with them, and I want to know them in the same way when I want to be with or know somebody that I love. I want to understand their thoughts. I want them to tell me what they feel. So these mechanisms in this camera, they're delicate and intricate physical mechanisms. And they encode logic and processes. They contain if-then logic. They encode sequences of events described in levers and springs, and they're alive with meaning and intention and purpose. And nobody explained any of that to me. I had to work it out. Or, actually, it feels as though they whispered their secrets to me because they trusted me. Honestly, I've met people and I've doubted if they had souls, but I don't doubt that here. And working on one of these cameras for me and seeing how it works, it feels like an intimate conversation with the people who created it, who I'm sure now are all dead. It's like receiving a message that traveled through time to reach me across decades. I want to say, I understand you. I can read I've got your message. I understood what you were saying and thinking. I feel the presence of those people. It's like reading their words when I'm in there. So in that experience, I feel I understand or have the power of attention. I have attended to this thing with a desire to be there, not to force myself on it, but to understand it and to know it, to be present with it. I literally have tended to it taken care of it with tenderness. Yet another word that comes out of this same, these same roots. So I asked, can a program be about something? Could a love program exist? Well, I recreated my Canonet QL17G3 in object-oriented Python. All of the parts of the program are Python objects, and every piece of the camera is a Python object. And their behaviors and the logic encoded into them and into their mechanisms are in the relationships of those Python objects and their methods. And the camera in software behaves like the real thing. So, because I'm a programmer, I can bring the camera into existence out of nothing, as if I were God. And it comes loaded, ready, with a roll of 100 ASA film, and I advance the film lever, and the machinery engages. And all the things that are happening in the software are the things that happen inside the camera. And I press the shutter release button, and now the light meter energizes, and it takes a reading, which is turned into a value for the aperture and applied to the iris, and the shutter opens for a fraction of a second and then closes again. All the things that you don't see inside the camera, but they're happening inside the code. Programmed, encoded in my little program at the level of levers and springs. The classes of just one part of it, the exposure control system, that one by one interact with each other. And all of these parts are modeled in software. Some parts to make my model work, I had to model some parts that are not even detailed in the service manual. What happens when you open the back of a film camera before rewinding your film back into the roll? You ruin your roll of film. It's all on GitHub. It's documented well, of course. It's a single camera.py file of a few hundred lines of fairly simple Python. For some reason, it's about 150 stars on GitHub, so it said something to somebody else somehow, for some reason. And why? What is the point of all this? What's it for? Well, it's not to do anything, because it doesn't do anything. But it's for me, because I love the camera, because of the experience I had in my encounter with it, because I felt something that affected me, because I paid deep attention to it, and it rewarded me with some kind of tender secrets. And I encountered something that astonished me, and I wanted to find a way to say it somehow. And this was really, for me, an experience of attention. It's not a program that does anything. So I wrote a program about something. I wrote a love program. And generally, we value intention over attention. We associate intention with activity, with being vigorous, with having will, making a difference to the world, and attention means waiting, and I mean literally in some languages, being passive, not making a difference to anything. But these differences are not so clear-cut, and these meanings and associations, they shift and flip depending on which direction you're looking at them from in which language, what's active and what's passive. They come in and out of focus at different times. Sometimes a word will have a more active shade and sometimes a less active shade, and it's not even consistent. And it's so easy to forget that there is active creation in attention. Because Gary Winogrand, he didn't put those people there to photograph them. He didn't arrange those bodies. The scene is not of his intention. The arrangement of those bodies is just a brute fact of the world with no meaning whatsoever. But with his seeing, with this magnificent power that he had to be there, he created the photograph. And the form and the meaning, the value are all his work, his creation, created out of his attention. He died. He was only 56 when he died. But his encounters with the world, they are so intense there are lifetimes packed into each 125th of a second that he took to make a photograph. So we shouldn't confuse intention with creation or creativity with activity in the way that we often do. We mustn't conflate attention and acts like seeing or listening with passivity or inertness. In school, as a small, not even just as a small child, but as a young person, I remember this awful injunction to pay attention while my childish body just itched with a kind of frustration. And pay is the right word because they really made me pay. I was made to pay and I got nothing in return. I'm paying for it still because it took me decades to find and understand and find ways to value attention as well as intention. And we live in an attention deficit world because people like me have found it very hard to find value and meaning or even pleasure in attention. So we do things with words, programmers and gods. But there are other people who also do things with words who are not God or programmers. Poets, Mary Oliver, who died 5 years ago, I think she experienced the same profundity of being there that Gary Winogrand did and was able to express it too in a different way. One of her best-known poems is Sometimes, and this is just a very short, 4 lines for it, a very short section. Instructions for living a life. Pay attention. Be astonished. And tell about it. So pay attention, to be there, to be fully present and alive, to be astonished, to be open and receptive, to be willing to be moved or changed by what you encounter, and to tell about it because it has to be shared, because you have to find a way to express it because it's too much to remain unexpressed. And maybe there are good instructions for life. I think there are also instructions for being a photographer, or instructions for being in love, or for writing a program about a camera, maybe. I think there is a truth there, that when you can be truly there, when you can truly pay attention to someone or something that you love, that sometimes they will tell you something profound in return. And that's what I've tried to do in various ways, and sometimes I think I might even have succeeded a little bit. Thank you.
Thank you, Daniele. Now I'm wondering, am I a developer or not? Do we have developers in the audience? Let's see. What do they think? Developers? We have a developer for sure, 2 developers. It's also time for questions. We have the 2 mics, they're still there, and we also already have someone walking towards it.
So yes, you were talking about attention, right? And in the age of social media, you see that a lot of attention is commercialized, right? The asking of attention for advertisements and that kind of stuff. But that is also interwoven in the attention of your real social contacts. And I'm wondering, how do you see it, that we can manage that we don't get insane?
What do you mean by your real social context?
So the people that you care about, that are around you.
Okay, yeah. I mean, I think that's, by the way, I think that they don't necessarily need to be the people that you care about. It could be the people that you hate or the ones that hate you. But like with Gary Winogrand with his 28mm lens, he was up close to, he was having close encounters with all of those. And there are consequences of having those encounters. Sometimes they're bad consequences, but they are real consequences. You know, you saw the looks of those people, if they could jump out of the frame, what they might do. Whereas there's such a distance in a lot of social media that the layer, there's something in between. And I think you're right that the encounters without consequences there seems to be something missing from them. We have so many of them, but they don't add up to very much. I'm not sure if I really addressed in any successful way what you were asking about.
Question, I think.
Yeah. I think that we have to fight for attention, and you know, we have this expression to pay attention, and it does cost us something to pay attention, but we should get something in return.
Thank you.
Daniela, you started talking about intention, realizing intention is kind of the godlike aspect of programming. And you moved to attention, in some ways kind of inspiring even more godlike feeling, right? Out of the aspect of what cannot be calculated or predicted, that uncertainty in attention. And so I'm wondering if programming and the predictability of it and the finite way in which the outcome can be predicted is in fact not the most godlike. So I'm suspecting that you're in fact advocating for quantum computing as the more godlike way for us to live our lives, because it's uncertainty, it's attention because you can't quite know the outcome. Is that the message?
No, I'm not sure if it is, but if you don't tell it, I'm not really an expert on God either. So, you know, the thing, we never hear about God's attention. Only, you know, God wills this, God wills that, God sets things in motion. There is something about the determinism. Our programs should be deterministic, and our computers should be deterministic. That means that they are, when things go wrong, when we've got a bug, that there must be a way to solve it. Because if, you know, there's not just randomness, for example, indeterminacy taking place inside those machines. Otherwise, we would lose all hope, I think, as programmers. It's bad enough as it is, isn't it, with complicated determinism. Imagine if they were indeterministic and we had to fix the bugs. That would be just too much to demand of us. Why did you ask about quantum computing?
Because I had an issue with that statement in the beginning about realization of intention is the most godlike expression. I feel that there's part of creativity, the true godlike experience, happens when the unpredictable arrives. Like I come from physical science, life science. The greatest miracles are not from what I expected as an outcome. It comes from the unexpected. So I'm really antagonizing you there.
Yeah, I think that, for example, in photography, the creativity is not, you know, you don't create stuff, you don't create matter, but it is a creative act. And it's funny that you're not quite sure whether you're finding the form and symmetry and meaning, because the photographer is not arranging those bodies on the bench or the animal and its tongue and the handler's hat. He's not arranging those things, but coming onto them, and yet the meaning comes from the artist in that case. Not the brute facts are what the brute facts are. So I think that the creativity is only in the world of form rather than stuff. And I'm not sure if that makes a difference, actually. So I don't know. Yeah, you've successfully antagonized me, Cindy. So. I'm here all day with more opinions about the use of the subjunctive in programming languages, so if anybody wants advice on that, I'm available for that too. Otherwise, if we don't have any further questions or comments or argument, oh, there is one there, so please, yeah. I'm just going to show that QR code, so if anyone's interested in the Documentation Academy, please take that link.
So the thing about being subjective, like in the imperative mood instead of declarative mood, there's so you said in the beginning that it feels like programming is like make it be like make the will happen. In a way, it's you don't make it out of thin air. You still like tell something to do it for you. Like you like when you're programming in Python, you have to tell the Python interpreter to make that happen. Or even in the lowest level, you still tell the machine to do something for you, and so it being in imperative mood might not be that wrong, but it depends on the abstraction level because most of the time you don't deal with Python interpreter, you just use it, and in the way you could say that you make it happen out of the will. So in a way you are not wrong. It depends on which abstraction layer you see.
Yeah. And I think that's probably right. And you know, as you say, everything is already given to us. We're not creating the whole universe out of nothing. We're creating, you know, I think I'm creating something out of nothing, but I'm creating it in the context of those Python rules that were already established. So it's a little world. And I think it's a little world. It's a really, I think this is why programmers are so, I think why people find comfort in programming, because it's a neat little world, unlike the filthy world outside, where we don't have that control, where it does seem indeterministic to us. You know, I'm thinking about the world of politics, for example, never mind physics. And we can retreat into our little worlds. Maybe that's not such a safe thing for us to do either. Yeah.
This is the last question, I think.
Yeah, I was just going to ask a question to keep the QR code up for longer. But I couldn't help but notice that all the photographs that you chose had people in. And the poetry also was about people. And you talked about soul. So where is the soul in programming?
You know, it's true, I did choose those photographs of people, and partly because it's the kind of photography that I admire the most and aspire to the most and wish, that's the one I really would like to do better. That's why the photograph that I was proud of is one of people. I think there is, I see it in programs and also in documentation and people's writing. Sometimes you know who the programmer is when you read the code, if you know them well enough. You see it, you think, I recognize, in some cases, I've seen it literally from the format of code on the page, how it looks, but also from the way they use abstractions and so on, because they are our works, and we do put ourselves into them. You know, we do put our personality into them, just the same way that we do into a photograph or a painting or a poem. And you know, this is why, I don't know why they teach computer science in universities. Programming has nothing to do with science, obviously. It's an art, it's a craft that people do. And computer science is a completely different thing. I don't mean, I don't know why they teach that. What I mean is, I don't know why it's important for programmers. Maybe that's just me showing my ignorance, but it seems to me that programming is actually a very personal thing as well, which is why people have such rows about it when they're trying to do it in teams together. So I don't know if that helps answer. I think we're out of time, aren't we?
We are out
Yeah,
of
thank you.
time, but we are hiring indeed.
Yeah.
The QR code stayed longer.
Thank you.
So thank you for the question, and thank you, Daniela,
Thank
very
you.
much.
Thank you, everybody. Thank you. Thank you. Thank you.
Now, it looks like we have 14 minutes left, but before you run away, did you register for Hackerspace Evening? That's a quiet room. Yes, no, we have one person registered. The rest of you must be upset you didn't get a spot because we had limited seats, right? You're very upset. I can imagine that. The community team just informed me that we have some free spots. So you should scan the QR code right there, register, and join the Hackerspace Evening from 6 o'clock. We're going to leave it on the screen until we start the lightning talks. They're going to be starting at 5:35 here. Don't run away. And if you leave, don't forget to take a photo with one of the mascots. I keep receiving photos, and they're really nice. So thank you all, and I'll see you in a bit. It's almost the end of the day, and I'm so happy to see people coming in. You're curious about the lightning talks, right? Yes. There we go, there we go. You should be curious because we have great lightning talks prepared. And before we get started, we should see, are we ready? That's too quiet. No. I'm not leaving the stage unless you're more energized. Try again. Are we ready? This is the last stretch. We have 5 lightning talks. They're quite exciting, so let's welcome our first speaker, please.
Thank you. Hello, I'm Heather. I'm here to talk about Thunderbird. Some of you may know that I used to work at Canonical, and I got to learn all kinds of snapping stuff. So when I moved to Thunderbird as my next job, I was able to carry that banner, and now we officially support it. So I'm here to talk to you about how I helped bring that about and make it a first-class citizen. So a little bit of a history lesson. Thunderbird has been a deb seated on the Ubuntu ISO for ages, and as of 2404, we replaced that deb with a transition package to install the snap. And that is joint maintained by Thunderbird as well as the Ubuntu desktop team. And we kind of share that responsibility, and it's great to work with old colleagues again. In order to do that, we wanted to bring a bit more feature parity and have a very open communication channel to make sure that we're both, finding issues and fixing them, and share that maintenance burden because it's better for everybody. And there's an upstream commitment. So now Thunderbird, officially sets time aside so that I can work on the snap to make sure that that is a great experience for the user. And that way it's not just the flat pack or the tarball, right? We're all team free software. And then we also adjust the user recommendations. So anybody that's using Ubuntu, we absolutely recommend the snap, as well as snaps for everybody else. But on our documentation, we say, if you're using Ubuntu, please install the snap and let us know how it goes. And if people want to help out on the snap, then you can go here and see a list of bugs. So one of the changes that we did was made sure that all of the snap bugs live in bugzilla.mozilla.org, which is where the Thunderbird bugs are. And if there's a snap issue, then both Seb and myself get an email saying, hey, there's a new snap bug, and we can go and be proactive and look at it quickly. If you do want to make changes, the Snapcraft YAML is all still in the Ubuntu GitHub repo, and that's where we do our collaboration. Yeah, so if you want to bring your snap into the first-class citizen realm, just have that open communication and try and get as much feature parity as possible. And if you want to help on the Thunderbird snap, we would greatly take those contributions. And that's it. Thanks.
Hi, my name is Pavel, and I'm with Heroic, and today I just wanted to show you a bit what we've been up to this last year, and some cool stuff I have to show. So we've been mostly catching up with Amazon, Epic, and GOG. They changed some services and added new stuff, so we had to add those features as well. But I'm the mostly focused. I will be mostly focusing on GOG Online features, and for UMO integration, you can hear tomorrow's talk by Glorious Egger. I really recommend tuning in for that. There's also one thing. we started a bit of effort to actually run UWP and or Win runtime apps in Wine. So you can see on the screenshot here, we actually got a DirectX example made by Microsoft running in Wine. And yeah, it runs pretty great. If you want to join that effort, here's a QR code. In case you wanted to see the slides again, they're linked in the talk descriptions. So the Comet is the project that actually allowed us to integrate with GOG services fully to enable achievements, playtime, and other multiplayer features. But there's a catch. Linux native games not really support that. The reason is GOG doesn't really advertise that they support it, and there are only few games that figured it out. So there is a game like Indivisible where, yeah, it works. It connects with Comet instance and works nicely. But how is it even possible? So there's this little download section called Steam Runtime that it's not even mentioned anywhere in the GOG's documentation, but it's there. And yeah, there's more information about that for game developers who are interested in maybe supporting those features and letting Linux users of native builds actually use them. So another thing is I want to introduce you to Maxima, which is the EA app replacement. So you can see the slogan, it's the farthest you can get from the origin, right? So it is a blazingly fast replacement that supports Windows, Linux, and maybe in the future Mac. And it will be provided as a Rust crate, CLI, TUI, and GUI. So whatever you want, you can use that. But now, the blazingly fast thing is not really up to the programming language used. Also, yeah, it is blazingly fast but not because we are using Rust, okay? So here's a little demo. It's running on a Windows machine, and this is kind of a speed run of getting the game to run. So it's about 6 seconds, and as you can see, we actually had to move the window. So even after moving the window, it's pretty fast. So it takes like 1 second to actually move the window itself. So maybe if someone wanted to do a world record, yeah, here's an opportunity. So if you have any questions, meet us at the Linux gaming booth. We are together with Pledtron as well, so thanks.
Hello, I am standing in for Anna Sarejo, who couldn't be here, and my name is Hayden Chambers. I'm a UX manager at Canonical. Let's talk about open design. Let's talk about building bridges between designers and open source projects. As you all know, at Canonical, we've been committed to open source principles and promoting collaborative spirit within the community. However, even though much of our development is open source, our design processes still don't reflect those values. Design in general certainly doesn't. So let's talk about that in more detail. There are challenges in making design inclusive and effective, not just at Canonical, but also in other open source projects. One big problem is a lack of transparency and clarity in our design processes. When it's unclear how decisions are made, it's hard for designers to contribute. It's hard to get involved. The quality of contributions is also a challenge. Especially without clear onboarding processes and documentation, it's hard to understand how to contribute and what tools to use, and this results in a time sink for both maintainers and designers. Lack of communications make it worse, leaving contributors feeling lost, unsure where to ask for help or to share ideas. On top of that, there's no central native place for design contributions. Out of curiosity, how many people here consider themselves developers for an open source project? Raise your hands. Great. How many consider yourself designers for an open source project? There's a challenge there, right? The numbers are way lower. As we push forward for evolution and innovation, as we move to have open source projects become first-class design citizens in a really competitive environment, we recognize the need for better collaboration in how we approach the design. So today, we're excited to tell you about our Open Design Working Group. It's still in early days, but our mission is clear. We want to empower both internal and external designers to contribute to open source projects. But what is open design? We believe that design, like open source, should be transparent, inclusive, and driven by a collaborative effort. We want to bridge the gap between the maintainers and design communities. We want to make it easy to identify open source projects, to contribute and to find designers. We want to simplify engagement. We want to enhance collaboration. We want to advocate for open design, not just in places like this, but in workshops and training sessions and conferences around the place. We aim to empower individuals to develop their design skills and actively participate in the future of open source. We're here to promote existing resources. We're having regular conversations with the Ubuntu community team. We're building and promoting resources. We're understanding the needs and motivations and interests of both parties. We're trying to prioritize those ideas that we discovered in a survey that was sent out to designers interested in OSS and maintainers and keep everyone's work relevant. But community doesn't happen in a vacuum. There's no oxygen. So if you're interested in this topic or feel like you could benefit as a designer or a maintainer, please reach out to us. We'd love your input, we'd love your collaboration, we'd love your collective wisdom. If you haven't already visited us at the Canonical booth wearing these t-shirts, please stop us in our tracks, or you can reach out to us on this form or email opendesign@canonical.com. Thank you.
Hello, my name is Eylül, and I'm here as part of the Ubuntu Studio. I'm the Ubuntu Studio Art Lead, but I'm also here as part of a new initiative called Ubuntu Flavor Design Squad. Now, before I go further about this, what is Ubuntu Flavors? Flavors are basically a variation and modification of the existing Ubuntu distro for a specific audience. This might be somebody who wants to use a different windowing system, like KDE Plasma. It can be someone who wants to use Ubuntu on a very low-end, very old machine. It can be someone who is using it from a special geographical area. It can be somebody who wants to use Ubuntu to set up a studio in their home on an old laptop, or a new one. Or it can be somebody who wants to install Ubuntu in a school network. This is why Ubuntu Flavors exist. And what this translates to is that we tend to be small groups of people who does often more curation and customization rather than full development. And what that means is most of the groups either have like single design volunteer or no design volunteers at all. And the work tends to be like nothing to do, a wallpaper, nothing to do. We are doing a whole overhaul of our UI. So you can kind of see the problem. And worse is most of us are single designers or just few developers who does design on the side. The person you have at hand might not even have the same skills. I'm a visual designer, I'm an artist. I know some UX, but like, I'm probably not the best person if we are doing something that's very, very elaborate and extensive. I need help. I'm definitely not a marketing person. So like, that's the kind of problem that starts to happen. And we try to communicate, like conferences like this help. But outside of that, it is hard to communicate and get help. And this is why Design Squad exists. So in the other side of it, for designers, we often work in a dialogue. Some of these are actually issues that are part of larger open design problems, which was mentioned in the previous talk. But also, the situation gets actually exaggerated because we are such small projects on our own. And you want to have feedback, you want to have brainstorming, and often there is nobody to do that. Similarly, as I said, extra specialized knowledge, sometimes what you need isn't even like UX or graphic design, it is somebody who's has experience in doing illustrations for young children. And then you want to get these people in. Sometimes there are people on the outside who will be able to contribute, but they don't know the infrastructure, they don't know how the volunteering structure works, they don't know the community and how it works, the etiquette, the culture around it, where to start help. Like, should I be going to Matrix? Do I know Matrix exists? So the goal of Design Squad is to try to help solve these problems today. That is specific to the flavor, eventually with the hopes of actually reaching out to the larger community, but right now to solve these issues, especially for the flavors. So how does it work? It's very simple. Projects for each release cycle are going to be announced and added throughout the process. And active volunteers will list their skills. It's important that, again, volunteers will let us know every cycle because life changes. Our time commitment changes. This is a volunteer work. And to keep sustainable volunteer work sustainable, it's very important that we actually make sure that, people can step down and step in. And now from there, people communicate and we move on. This sounds interesting. You're a flavor lead, you're a designer. Come join us on the Ubuntu Discourse, or you can use the QR code to get to our subsection. We are under flavors. It's a little bit hidden. Thank you.
Everybody, I'm Nirav Patel. I'm the founder and CEO of Framework, and I'm going to do something a little bit different. I think lightning talks are a super cool format because it forces you to explain a complex topic really quickly, but instead of explaining a topic, I'm actually going to physically demonstrate a complex topic, which is how and why we've made Framework an ecosystem-based company, and specifically an ecosystem-based hardware company. Now, all of you are obviously familiar with software ecosystems, given that we're in this room together at the Ubuntu Summit. Ubuntu and Canonical and the Linux community broadly is an ecosystem. It's a software ecosystem. And we saw over the course of decades really the power that comes from ecosystems and thought, why can't we have that in hardware too? And so what we've done with the Framework laptop and really the core philosophy of Framework itself is this idea that by designing products to be modular and repairable and upgradable, we can, of course, design them to last longer, but we can actually also enable the same types of powerful outcomes you get from software ecosystems with hardware as well. So what we've done throughout the history of Framework is open sourced as much as we could. So we've released open source reference designs and documentation and CAD around most of the core parts of the laptop, most of the module systems, and including things like the mainboard, and really just open it up to allow the community and third parties to be able to participate as well. And as a result of that, we've started to get some pretty exciting things out into the world, including this. So this is the first third-party mainboard from a company called Deep Computing that's actually here at the Ubuntu Summit. And the cool thing about this is that it's not just the first third-party module of this complexity as part of the Framework ecosystem. It's actually also one of the first RISC-V powered mainboards that's available for a laptop. And so the cool thing there is that by enabling this ecosystem-based approach with the Framework laptop, we've been able to get a super competitive product that is actually RISC-V powered faster and earlier than would otherwise have been possible, and we didn't have to do it all ourselves. We could do it by leveraging our partners. And so by opening up the source of the reference CAD for the mainboard, opening up a bunch of documentation, and just making it clear that the intent of this product is that it is not only a framework product, it's actually just a framework-fostered ecosystem. We're able to get the team at Deep Computing up and running extremely quickly. I know probably many of you are wondering, this is a 5-minute lightning talk, right? Is he really going to be able to do this? And I will say, I have practiced this many times, and on a normal day, I can do this in about 3 minutes and 30 seconds. I am running on less sleep than normal this weekend, but I am watching the timer and feel pretty confident that we're still going to be able to do this in a lightning talk format, not a long-form talk. But this is, of course, just the start. We're 5 years in as a company, and we're just 4 years in on the Framework laptop as a product in market. And here we are already with a third-party mainboard. And we expect that the success that Deep Computing is going to be able to generate with this, with developers specifically, is also going to bring encouragement to other third-party hardware makers to come and participate in the ecosystem. And of course, again, the power of that ecosystem is that the more participants there are in it, the more breadth of capabilities there are in what everyone is creating, the more valuable that ecosystem gets for all participants, and the more that ecosystem can continue to enable more people around the world. And so we are definitely enthused and excited to be able to continue to support that as a company and hopefully help all grow it together. So this was a physical demonstration of the power of ecosystems. And if anyone has any questions on it, definitely feel free to stop by the Framework booth in the booth area, or also the Deep Computing booth, which is right next to us. So thanks, everybody, and have a good summit.
That was an impressive demonstration. What can I say now? Well, I'm not sure if Nirav heard you, but if not, you can try to pass by the booth and ask for the demo again, I would say. It is the end of the day. Time flies quickly, right? Yes, it does. Well, the day is not over yet. If you registered for the Hackerspace evening, it's about to start right now, and you should check your emails because you have all the details there. Also, tomorrow at 9 o'clock, we start the third day. I was about to say the second day, but that's not correct. It's the third day. Don't be late. Don't forget to show up, check the schedule for the talks that you like, and I would say enjoy your evening. Thank you for joining us. Thank you for the questions, for the engagement, and I would like to thank all our speakers wherever they are around the venue as well. Have a good day.